Sorry.
Yes, Sandeep sir, you may share the PPT. Yes, so good morning, all of you, and sorry for the slight delay. So my name is Dr. Hamim, who will be acting as the coordinator for this session. And also we have Mr. N. Sandeep Kumar, who is the Assistant Professor, Department of Civil Engineering. He is also acting as a session coordinator. So I welcome Vivian Prabhakar Rao Garu.
Thank you, sir.
Can you move the slide?
Yes, please. We can go ahead.
Yes, sir. Very warm welcome to the third international conference in advances in civil engineering, sir. So we are in track 3, sir, session 1. Okay, we heartily welcome you, sir.
Thank you very much.
So to begin with, Sandeep, keep moving the slide. To begin with, I would like to welcome. I would like to give a brief introduction about the chair. So Dr. Vivian Prabhakar Rao Garu pursued MTech and PhD from Andhra University. His areas of research are geotechnical engineering, transportation geotechnics. He has been part of multiple international and national seminars and also was the reviewer of the project proposals for CERT, Department of Science and Technology, Delhi. He has created 4 international conference on nanostructured materials and nanocomposites and members of the organizing committee for the 5th International Conference on recent challenges in engineering and technology. So he has 3 decades of teaching and industrial experience and has done significant research and experimental investigations on expansive soils grouted with additives, swelling pressures of soil using a predictive tool, and generalized analysis of under-rain piles subjected to an isotropic swelling pressure. With this, I welcome you, Dr. Vivian Prabhakar Rao, sir, who is the professor, Department of Civil Engineering, VR Siddhartha, Andhra Pradesh. Thank you so much for joining with us, sir. So
Thank
apart
you
from
very
this,
much.
we also have, yes, sir. Thank you, sir. We also have our co-chair for this session, Dr. Y.V. Ramesh Babu Garu, who has done his MTech structural, and I welcome you, sir.
So Hamim sir will join in a couple of minutes. He's having urgent meeting with the member of
Oh,
parliament.
all right, sir. Well, anyways, to give you a brief introduction about him, Dr. Y.V. Ramesh Babu Garu has a rich industrial experience of 3 decades, and he has worked as an inspector of works in railways and has an outstanding experience as a lecturer in Government Polytechnic College. And currently working in Panchayat Raj department, he was involved in planning, designing, and construction of mega projects, construction of 10 over 10 service reservoirs, providing drinking water to 10 villages in Andhra Vidu in Prakasam district. He was also a part of planning, design, and construction of DT roads and roads bridges to connect the villages in Prakasam district and Guntur district and in various places as well. He's an active life member of Indian Roads Congress and an Indian Geotechnical Society. Sir, we heartily welcome you on the behalf of Third International Conference Advances in Civil Engineering. Thank you so much for being with us, sir. So for today, we have our first keynote, followed by the second keynote, and we have five paper presentations. So I would like to hand over it to Vivian Prabhakar Rao Garu, who will be acting as a chair, and your co-chair will be joining in a few moments, sir. So, sir, so you have certain guidelines here, sir. So you are provided with certain rubrics because we also have the best paper award for the conference. So I would like to request you to give certain markings to the paper presentations. So as per the rubrics given to you, and uh, and I would like to take it to you, sir, as well. So the first keynote speaker we have with us is Dr. Naveen James, who is assistant professor from IIT Ropar, India.
Thank you very much.
Yeah.
May I take the privilege to welcome Dr. Naveen James from the IIT Ropar. On behalf of the third international conference held by KLU on advancing civil engineering in the transportation and geotechnical sector, track 3 session G1, I welcome Dr. Naveen James and please start your session, sir.
All right, I'll start by saying thank you, Chairman. Thank you, the coordinators of this conference for giving me the opportunity. Let me share the screen. So I hope my screen is visible.
Yes, sir.
Yeah.
Yes, very much.
Yeah. All right. So thank you everyone for giving me the opportunity. So I will quick, since we are running short of time, I'll try to complete my presentation in the stipulated time. So without wasting any other moment, let me start. So today I'll be talking about seismic zonation of regions at different scales. So these are the content of my presentation. So introduction, study area, methodologies adopted, seismic hazard assessment, seismic site characterization, assessment of site amplification hazards, assessment of liquefaction hazard, and integrating all these hazards to a index value. Then I will conclude. So directly I go to the introduction. So we all know, we are very familiar with the damages, earthquake damages that had occurred in this millennia, which is the first and foremost the case study we can see is the 2001 Bhuj earthquake. So that is the typical damage occurred during 2001 Bhuj earthquake reported by the IIT Kanpur committee. So then later on, these studies were carried out, and it was found that about 59% of what do you call it, the Indian land area is prone to the earthquake risks, moderate to high, severe earthquake risk. So earthquake hazard. I'm sorry. So and in more than in the last 20 years, there are dead toll more tan 25,000. If 23,000 is just an approximate number. So the in reality, the death toll in those earthquake damages are far significant. And and it is being proved consistently after every earthquake damage that the human casualty in any earthquake event is not because the severity of the earthquake, but because of the lack of proper planning. That is the lack in the proper preparedness against the earthquake. We either the structures were not properly designed to count these earthquake forces, or we have not quantified the earthquake forces properly. So that is the main reason we find that the casualty on these during these earthquake events are so high. And if we look at the current urban centers in India, so we see that there is a tremendous growth in human population around these urban areas, and all major cities are expanding outwards to account these large population. Then when you have a very large demand of this urbanization, coupled with the underrated constructions and land use. So majority of the lands, we don't know that the good land where there is no problematic soil is very less. So when we encounter the problematic soil stratum, and without implementing proper mitigation technique for stabilizing these soil stratum, and then then we go ahead with the construction and with poorly designed building. It is nothing but invitation to another human casualty in a earthquake event in an event like an earthquake. So what we do about it? So first we have to do is we have to carry out the seismic zonation. So the first important part is to quantify the earthquake hazard. Which are the earthquake hazardous region, which are low hazardous region and all. And for that, we can only do, we have to do a seismic zonation. So this is the typical earthquake event map prepared by my good friend, Professor Srivalsa Kolataya. You are going to listen to him in the next talk after mine. And so if I continue, what is we start with the obvious question. What is a seismic zone? So I'm just rushing through it. I'm sorry. So if you have any queries, you can always get back. So we'll start with the fundamental question. What is a seismic zonation? So it is process of dividing a larger region into small zones. Okay, so we have classic example we have seen is our Bureau of Indian Standard 1890, IS 1893 2002. Even 2016 codes are also available, but I'm just taking an example. So you see that these zones, the entire country is divided into 4 zones: Zone 2 to Zone 5. And what is the basis of this zonation? So based on the level of earthquake hazards expected. So you can see that in zone 2, you have a level one, a certain level of earthquake hazard is expected, which is designated by zone factor. And in zone 5, where the hazard value is high, it is given, you will have the higher value of zone factor in those zones. So it will give you give you an idea of which regions are more hazardous for the earthquake point of view and which are not. And then we can adopt appropriate design guidelines for each of the zones. So then the question is, what is the need? Why do we need a seismic zonation? So yes, as I've said, to find the vulnerable regions in a particular study area. So that are being already showed out. All the red lines are called the danger zones. And then you will get an input, necessary input for the earthquake resistance design. So all the structural engineers require either what is the amount of acceleration that is coming if we are going for a pseudostatic analysis, or if we are going for a dynamic analysis, then we require a proper the earthquake time history for pertaining to the region. So these things we can get these inputs we can obtain only when we do a proper seismic zonation. So now the important part we need to understand is what is the levels of seismic zonation. So in the level of seismic zonation, we can do it at a micro level, then where we look at a very critical structures such as a nuclear power plant site. And the important part is the earthquake hazard parameters. What are the earthquake hazard parameters? We will see in coming slides. But the important part is these earthquake hazard parameters are estimated with a greater degree of reliability. See, if we have a nuclear power plant site like Alpakam, we cannot go with approximate kind of analysis for its its reactor structure and all. It has to be designed with a higher degree of reliability. So for that, these parameters, the hazard values, are to be determined in a more accurate way than the conventional ones. So that those type of zonations, we call it as a micro level seismic zonation. Now, at a meso, we can also do it at a meso level. So let's say for an urban center, cities and the urban centers. So for that, a moderate degree of reliability, the estimation of earthquake hazard parameters with a moderate degree of reliability would be suffice, because you have a very large area. And I will say why we can't go for a very higher order reliability when we go for cities and urban centers. There are certain constraints are there. One of the important constraint is obviously is the finance. So it is very difficult to do a earthquake hazard estimation with a very high degree of reliability for such a large region. So we can go to a meso level, and then we can go for a macro level. Like we want to do a hazard zonation for a country, a large landmass like a country or a state. So just to identify which are the vulnerable regions. So there we can go with predicting the earthquake hazards with a lower degree of reliability. Now, how to predict these with a higher, lower, and moderate degree of reliability, I will discuss in my coming part of my presentation. So typical examples of a micro, meso, and macro level zonation has been showed in this figure. So when we did a work done by myself for Kalpakam nuclear power plant site, so where the hazard index has been developed, considering the accurate estimation of hazard and hazard parameters. And then you may have the seismic zonation of Bangalore city done by Professor Sitaram and Professor Anbaragan in 2008, and which is an example for meso level. And the classic 1893 BIS 1893-2002 seismic zonation map can be treated as a macro level seismic zonation. However, many researchers have brought out the limitation of the maps, which are the maps seismic zonation map by Bureau of Indian Standards. So there are several studies. Professor Kolaptayar is one of the pioneer in that. Did a lot of seismic zonation studies for the entire India, considering various earthquake scenarios. So now another important question is how to carry out a seismic zonation. So I'll just give you a roadmap for that, and then then I'll go into each parameter. So the first important part is the estimation of hazard, the earthquake hazards, such as a ground shaking hazard, liquefaction, landslides, and tsunami if required for a coastal region. But in our case, we have not considered tsunami. Landslide we have considered, but since landslides are a bit localized and to be done at a higher resolution, so that has not been included in preparing the cumulative hazard maps. Then the important part is its spatial distribution. How does the hazard is being spatially distributed in your study area? So we tend to determine the hazard at certain control points, and then possibly we have to rely on the interpolation technique to determine the hazard variation to determine the spatial distributions of hazard. But this can be improvised by taking more control points. So we will see what is the space, the resolution of these control points and all in my coming slides. But the important part I want to highlight here is the knowledge of the spatial distribution of hazard is also important when we carry out the seismic zonation. Then integrated hazard. Integrated hazard is like we have different hazards. As I've said, ground shaking is the one of the important part, important hazard which is caused by the earthquake. So similar to that, there are like liquefaction hazards are there, landslide hazards are there. So these hazards have to be integrated or using certain methodologies so that we get the consolidated effect of all the earthquake hazards. So these are the major steps that are required in the seismic zonation. So if we go into detailed steps, so we will see these steps and its output. So first we need to determine the seismic hazard analysis, basically to evaluate the intensity of ground shaking, because the ground shaking is the one of the important aspect that causes the damage in the structures. So that can be estimated by conducting a seismic hazard analysis. So we get the peak horizontal acceleration (PHA) and the spectral acceleration, and we can also get the maximum credible earthquake for the region and the hazard curves. That means what is the probability that the set peak horizontal acceleration and spectral acceleration will occur in a given period of time. So that is also required in the probabilistic based designs and all. So those are the outputs that we get from a seismic hazard analysis. Then up till certain time, the scientists believe that whatever damage is occurring in a region strictly depends upon the intensity of the earthquake or the magnitude of the earthquake, or we can say broadly, we can say this is the source characteristics. Okay, so what is happening at the fault? And the effect of the ground surface or local soil is neglected in the initial days. But later on, once after 1983 Mexico City earthquake, so people try to understand that the local soil plays a crucial role in aggravating these hazards, aggravating or amplifying the seismic waves that are coming from the bedrock. So then the detailed studies were carried out and they found out, yes, it plays a significant role. So one need to characterize the site on that location using conventional geotechnical and geophysical methods, subsurface methods, that is subsurface profiling we have to do. We have to estimate the depth of rock, then average shear wave velocity for top 30 meter, and then categorize it into various site classes. So once after that, we carry out the liquefaction hazard mapping. So liquefaction, we have to find out what is the cyclic resistance of the soil, then the cyclic stress that are coming up at the soil at that level using the famous and interface equation. And then we know that the factor of safety against liquefaction, then there are probabilistic way to determine the liquefaction potential, etc. Okay, I think I have. There is one more part is there. After site characterization, we have to also estimate something called a. Let me write it off. The site amplification. So based on the site profile, we can do some analysis and we can do even some field experiments to determine what is the amplification. How much by how much margin the ground earthquake wave will be amplified by the particular site or particular strata. So that is also important, and then one more thing happens is the frequency content parameters like predominant frequency, etc., for the ground motion also get altered when the site amplification or de-amplification occurs. So these all will affect the response of the structure. So this has to be also be estimated. And then liquefaction hazard, and all those things have to be integrated to form a microzonation, or I will say seismic zonation maps. So either it can be a deterministic based or a probabilistic based. So with that, I want to bring the attention of everyone to these issues related to some zonation. So the government has initiated the seismic zonations in major cities. So for under that, we had Delhi microzonation, Mumbai microzonation has carried out, Bangalore microzonation, and also certain tier 3 cities were also being selected for seismic zonation. Now, as I've said, if you do the site characterization, we have to do extensive geotechnical and geophysical investigation, because the site, even we know the soil is highly variable, spatially variable. So even with a meter, if we do a site investigation with a 1 meter apart, we may encounter different type of soil.
Hello.
Hello. Yes.
Really, sir?
Hello. Can you? Hello.
Yadake. Capital C, small ed at 22. CED, suddenly C capital letter.
That's the problem with something.
Okay. Okay. No issues. Okay, fine.
It's okay, please. Please go ahead.
Yeah. Okay, so now, so the thing is, so then it is very difficult to carry out. We know that it is very expensive, and it consumes a lot of manpower to carry out the geotechnical testing, particularly SPT or CPT. So if we do testing at a very close resolution, it is highly uneconomical. I mean, it will be very difficult to not physically and economically viable to do these tests at very different locations. So what to do? That's a obvious question we have to see. But we have to know the site profile, the subsurface profile of the region, without which we cannot go ahead with the seismic zonation. And there are so many there are very few guidelines are available to state what level of zonation to be adopted, especially for a study area like India. So let's say if I said the micro level zonation, where the degree of estimation of the earthquake hazard parameter is very high, that has to be done for a seismic, that has to be done for a nuclear power plant. Now, a city, a very thickly populated city in a very high, what you called seismic zone, need to be also need to be carried out. The seismic zonation for that city also need to be carried out at a micro level, because the thing is, if there is any earthquake occurs in that region, the casualty will be high. So those kind of guidelines are not available in India till now. And as I've said, there are various methodologies. We will discuss it for site characterization, and site effect estimations are available. But the suitability of these methodologies to each level of zoning is remain unexplored. Okay. And generally, the macro level zonations are carried out. If you look at the seismic zonation map of India, it has been carried out based on one factor, that is the zone factor something. The influence of site conditions are neglected. So generally, the macro level zonations are carried out based on particularly one parameter. We don't consider the influence of site conditions and all, which also need to be included in the seismic zonation. So with all these shortcomings, we have formulated the objective for these studies. So I'm not going to list it out, but basically to assess the various levels of seismic zonation for different region, and assess the feasibility of various methodologies for seismic zonation. And then using the appropriate methodology, carry out the site characterization and hazard estimation both at micro and macro level. So we at the meso level, we have not considered, because there are significant work have already been done at meso level, especially the seismic zonation of big cities like Delhi, Bangalore and all, they have already done. So here we are going ahead with a micro and a macro level zonation. Okay. So typically the study area we have selected for a micro level zonation is the Kalpakam nuclear power plant site. And for macro level zonation is the state of Karnataka we have taken. And the following hazard parameters we have considered. Hazards were considered, that is the peak horizontal acceleration at the bedrock, then the site amplification, and the liquefaction hazard. Apart from that, we have also considered the site characterization, that is the site classes. I will discuss it here. Also as the hazard influencing parameters for the zonation. Now I'll just talk brief methodologies of our site seismic hazard assessment, but since I'm short of time, I'm not going in detail. So we have two methodologies available, that is deterministic and probabilistic seismic hazard analysis. So one consider only the critical scenario, while the other consider the contribution from all magnitude distance scenario, ranging from a minimum to a maximum in terms of its probability of occurrence. Now, the important part here is, like, due to availability of high computing power, we can carry out the seismic hazard analysis at to any scale. Like if you want to do the hazard analysis at to a level of 1 meter by 1 meter resolution for the entire India, it can be done because we have a superpower computers are there. So that you just have to need to run the simulation hazard simulations for a large number of grid points, maybe 1 crore grid points or something. So that can be done. We have a very good storage facilities are also there. So it can be done. There is no issue in it. But as I've said, carrying out the geotechnical and geophysical test for site characterization and site effect estimation is a challenging one. That cannot be done at a 1 meter by 1 meter interval for the entire state of Karnataka or even entire state of India. Forget it, entire for a district also it is not possible. So we have to come out with some way out for finding out the higher resolution for seismic zonation at different levels. So here for a micro level for Kalpakam nuclear power plant site, we have taken at a 100 meter by 100 meter grid resolution. For a macro level, we have taken at 5 kilometer by 5 kilometer resolution. Professor Srivalsa, I think, has taken a 10 kilometer by 10 kilometer resolution for entire India as well. So that work will also be there. So I'm not going to discuss all these things. These are, if anybody wants to look at it, please they can refer the geotechnical earthquake engineering by Kramer for more details. Basically, I can show the results. So these are the spatial variation of the PHA value for at the bedrock level throughout the state of throughout the Kalpakam nuclear power plant site. So I have done this zonation. So point for from DSHA, let's say 0.11 G to 0.127 G, I made a one category. 0.127 to 0.13 G. So this is based on my judgment. So that way we can do a seismic. So this is a particular zonation based on one parameter. Similarly, from probabilistic hazard analysis, I have determined the hazard curve. And based on that, I have determined the spatial variation of PHA value for 475 year, 2005 year, 2500 year, and 10,000 year return period, which is already there. In these details, I would request you to refer the Kramer book again. You can understand. So similarly, we have carried out the hazard analysis from deterministic and probabilistic hazard analysis methodology for the entire state of Karnataka. And this is the probabilistic hazard analysis from the probabilistic methodology. Now, so all these things are being conducted at a 5 kilometer by 5 kilometer grid because the area is more. So our course of resolution would work. Then the site characterization, yeah, there are different methods are available. We can do it based on local geology. We can based on geotechnical field test data, based on geophysical field test data like MASW, SSW, and cross field borehole test and all. And we in 2007, Ladd and Allen has already put forward that the site characterization based on the topographic slope map. So if we know the slope of the topographic slope of the region, we can use it as a proxy for the site characterization. So, so basically the local geology based is very approximate, very crude method, mainly suitable for a macro level study. If you know the geological formation, what type of rock or what type of geology it is, we can broadly find out what type of site classes it will fall. So that is categorized as a macro level study. Similarly, from geotechnical geophysical tests, that requires a large amount of resources, so it can be done at a micro to meso level. So then we can use a topographic slope map, and that can be applicable for macro to meso level study. Now this has been verified. I have verified with this is the site classes, the site class map generated from topographic slope map, and compared with the data based on the field study by Uma Maheshwari et al. And I think Uma Maheshwari et al. 2011 for the Chennai city. So almost it gives a reliable way of predicting the topographic what do you call site characterization map. So that is, and again same has been also what do you call it compared with the done for the Bangalore region and compared with the results of Sitaram and Anmargan, which all clearly shows that it is very well applicable for a meso level zonation as well. However, for a macro level, we have carried out the site characterization based on geotechnical as well as geophysical methods. So we used multi-channel analysis of surface wave testing, as well as in addition to that, we have taken the bore log data as well, and then we compared. We have carried out the site characterization map So I'm not going into details. So this is the site class map. So for the Kalpakam nuclear power plant site, based on the field test data, and the site characterization for at a macro level is being done using the topographic slope maps. So those who are very much acquainted with the GIS, so we know we can get the digital elevation map where there are freely available digital elevation maps are available for the entire world. So we have taken that digital elevation map, we have generated the slope map in ArcGIS, and from that, the correlations proposed by Ladd and Allen 2009, we can know what is the seismic site classes. So site class B is typically consists of rocks, and site class E and D are consist of a soft soils. So that is the variation. Then we have determined the site amplification hazard. So how to estimate the site amplification? So there are empirical relationships are there, experimental methods are there, and then we have classic our 1D, 2D, and 3D ground responses analysis are there, which is based on the soil strata, the data related, the geotechnical data of the soil strata. Yeah, so I'm just quickly go through the feasibility of each method. So the experimental method, like based on micro tremor and strong motion data, that can be used for the meso-level study, and the ground response analysis based on the field test data. It is more suitable. Even it can be even done extended to meso level, but it is very much suitable for a micro level study because we can accurately estimate. We can consider the nonlinear effects of the soil and all, response of the soil and all in those analysis, in these analysis. So we have carried out a 1D ground response analysis for Kalpakam nuclear power plant site for certain borehole data, which you can see here, and the soil properties we have assigned. And then we have obtained the ground motion data that is actually we use a synthetic ground motion data. The actual ground motion data is not available. And then based on that, we have calculate what is the surface level PHA, the peak horizontal accelerations, amplification factors, and predominant frequency throughout the study area. Now, similarly, for a macro level study, we use the empirical method, which is proposed by Raghukant and Iyengar. So for that, we have to know the what you called the bedrock level acceleration, and for each site classes, there are certain regression coefficients are available. We plug it in this equation one to get the factor of safety, the amplification factor value, and multiply the amplification factor with to the bedrock level acceleration, we get the ground motion, the PHA value at the PHA or spectral acceleration value at the surface. So this is the variation of peak horizontal acceleration at the surface from the deterministic, which is done using deterministic method, and from the probabilistic data, hazard analysis data. So you can see that all the red zones are shows very high value of earthquake ground motion, while the green zones are showing the lower hazard values, the lower value of the spectral acceleration and peak horizontal acceleration at the surface. So then I'll quickly go to the liquefaction hazard assessment. So liquefaction is also an important hazard that has been triggered by the earthquake. So we all know so the popular method to assess the liquefaction hazard is estimating the factor of safety against liquefaction, which is nothing but the cyclic resistance of which is the ratio of cyclic resistance of the soil to the cyclic stress that is coming onto the soil by from the earthquake. So so this CSR, we know how to estimate it. The CSR is already can be estimated using the Seed and Idris formula. The resistance of the soil can be estimated. Cyclic resistance of the soil we can estimate using laboratory testing, field testing, and then you have a performance based approaches are there. So if I quickly go through each the feasibility of each method, so it is very clear. So lab testing, it is very difficult to do a lab testing, and for even for micro level studies, because the complexities associated with these testing and the equipment cost are very high and requires a skilled personnel to do it. Even to do a conventional geotechnical test like static tractions, you need a skilled person. But so imagine if you have to do it for such a large area, it is not feasible, which is it's a common sense thing. Field testing, we can use it because for routine geotechnical investigations are part of any infrastructure construction. So those data we can use. So it is suitable for a micro to meso level zonation. And then we can also determine the liquefaction potential in terms of SPT value and CPT value required for this site. So so I will explain this part later. These are all pretty known. If we know the SPT and CPT value of the resistance of the soil is high, the cyclic resistance of the soil is invariably high. So in our study for the Kalpakam nuclear power plant site, we have used the SPT-based approach, like field test-based approach, and then we determine the liquefaction potential in terms of LPI, that is liquefaction potential index. So for more, you can refer either this paper or the Kramer book again. There it has been clearly mentioned. So we can see all the red zones represents the high liquefaction hazard regions in the nuclear power plant site. Similarly, if we know the site class values for a location and the expected peak horizontal acceleration, we can invariably, statistically, we can find out what is the SPT or CPT value required to prevent liquefaction. So we say that for a particular site class and particular level of peak horizontal acceleration, if the SPT value exceeds the N required or CPT value exceeds QC required, there is less than QC or N required, then we can say that there is a high chance that liquefaction will occur. So that method has been proposed by Kramer and Mayfield. We have extended it and we have applied it for the Bangalore region, and we found that based on the site class data and the PGA value, surface level PGA value, these are the locations. So locations where, like we say, red regions, there it says that it requires a higher SPT value. That means there's the soil, there the site, looking at the site classes and the level of acceleration, we say that, okay, here if the SPT value is less than 20, there is a high chance that here you can expect liquefaction or a cyclic mobility. So this way we can understand the what is the spatial distribution of liquefaction hazard value. Yeah, similarly, and then finally these hazard influencing factors are integrated on an AHP analytical hierarchical process platform. And then we gave the weightage. Here the weightages are actually user judgment. So here, since I have done it, so I have given higher weightage to the peak horizontal acceleration, considering that this is the peak horizontal acceleration is mainly responsible for your site amplification and your liquefaction hazards. So that has been given a higher weightage, and subsequent weightages are assigned as given in the table. Then there are certain analysis we do, piecewise comparison and all those things. So I'm not going into detail. And then we determine the hazard index. So looking at that, so it says that the orange region is having more hazard, looking at the contribution from all earthquake hazard and hazard influencing parameters. So here, if you remember, even though the liquefaction potential is less, but even the PHA value is very high, and the predominant frequency part is also very high. So that is why this region is showing up as a very high hazard region. Even though the PHA values are very less on this part, but still it shows a moderate level of hazard because the liquefaction hazard at these locations are very high. So this has been seen here. So similar exercise has been conducted for the Karnataka. So to identify the hazard indexes, and we find that all the red zones or orange zones are of high hazard region considering the consolidated effect from the all earthquakes. Now, this is not the end. The thing is, so this gives you this gives an idea to the engineers or planners. Okay, so if they have some main infrastructure to be built here, they can anticipate what will be the hazard value. So now they know that this is a probably high hazardous region, considering all major earthquake hazards. So then the construction or the design should be more rigorous, should consider more dynamic, should consider consider the earthquake resistant design. The foundations are to be designed in a more rigorous manner and all. So that this kind of input is very much essential for a structural engineer. So now with that I conclude. So if I can summarize it, these are the major earthquake hazards and the appropriate methodologies available. So, but at a micro level, yes, the hazard analysis can be done using deterministic and probabilistic approaches. And but the site characterization would be for a micro level needs to be done based on geotechnical and geophysical testing, while at the macro level, we can do it with the topographic slope map. It gives you a fairly accurate result. And at a micro level, we can do a numerical hazard analysis using numerical methods, while the macro level analysis can be done with the empirical methods. Similarly, for liquefaction, field testing methods are most suitable for a micro level, but a probabilistic performance-based approach provided by the Kramer and Mayfield would be more suitable for a macro level. Yeah, so these are much of these conclusions are nothing but I've summarized in the table before. Yeah, so that's it. Thank you from my side. I don't know if I have exceeded my time limit. So if I exceeded, I'm sorry. I thank everyone for the patient listening.
No, perfectly all right, sir. It will be unfair on us if we don't read his CV. But unless we start his speech, he cannot end. So that is why I directly rushed to the means asked him to read means go to his presentation.
Okay.
So
Okay.
the
Thank
next
you.
speaker will excuse me for reading out and taking his time, but it is our honor to read out because he has something excellent. Let me read out at the end. Dr. Praveen James pursued his MTech from NIT Surathkal and PhD from ISA Bangalore. He is currently assistant professor at IIT Ropar, and his research areas of interest are dynamic behavior of soil, liquefaction, experimental and numerical studies, site characterization and site response studies, seismic hazard assessment and microzonation, landslide hazard assessment, GS application in hazard studies. He worked as a principal investigator in national projects like development of low-cost artificial intelligence system for early detection of landslide and slope monitoring and landslide hazard quantification for hilly areas. And what we have to appreciate a lot from him is he has attained a Endeavour Fellowship from Government of Australia in 2016 and PhD Fellowship from Ministry of Human Resources Development and European Union Fellowship from International Research Staff Exchange Scheme, Geohazards and Geomechanics. You know, to get these awards, how people will scrutinize him, but he has, let us say, crossed all and got the, let us say, scholarship. That itself is a great achievement. And a presentation also we have seen what is meant by microgeneration, what is the usage of the many methods, physical like geotechnical, use of SPT. He has more relied on SPT and SCPT, which are less costly at the same time. And he has highlighted the, let us say, GS methods also he has highlighted, which is a really great work. Now I am leaving the session for only 5 minutes to ask, let us say, 2 questions from the audience. I don't want to deny the audience also. Please ask two questions, then we will go to next let's speaker. Sir, excuse me, I couldn't introduce you at the starting.
No problem, no problem. That is fine. That is fine. We know that the time is already exceeded,
Yes,
and we
that was the
started a
only
bit
intention.
late. No issues, no issues. Actually, I'm perfect with that. Yeah,
Yeah. Sir, good
I think
afternoon.
yeah.
Good afternoon, sir. Myself, I'm also a scholar under the guidance of Hanumantrao, sir.
Okay.
Sir, usually in the ground motion prediction equation, we have various details. It consists of magnitude, size, and site classification also. So, while evaluating the seismic hazard analysis, we usually evaluate the PSH at bedrock level, right?
Yeah,
So,
yeah.
what is the exact value of VS at the bedrock level, sir?
Yeah. So, I'll just answer your question. See, the thing is, the ground motion prediction equation, as you rightly said, they consider the magnitude, distance, and other source parameters. Okay, and that is specifically for a steady region. In general, they don't consider the site class, but there are certain next generation ground motion equations are there, which even consider the site class and give you the hazard value directly at the bedrock, directly at the surface. Now, the site classes, it is basically based on the shear wave velocity. You have to measure the shear wave velocity with respect to depth, and then take an average shear wave velocity for the 30-meter. Generally, if you look at these shear wave velocity, if you have the values between less 180 to 360, you call it as a site class D. Anything less than 180 site class E. So if you have a bedrock, if it's an engineering bedrock, generally its shear wave velocity is average shear wave velocity varies from 760 to 1500. But since majority of the earthquakes occurs at a seismogenic bedrock, which is much more denser than the what do you call the engineering bedrock. So there the average shear wave velocity is more than 1500 meter per second. 1500 kilometer per second. I'm sorry.
Yes, sir. Sir, and one more,
Yeah.
sir.
Yeah.
While doing ground response analysis, we usually select some input motion. Either it is synthetic or it is already recorded motion.
Yes,
So,
yes.
so whatever the type of motion we selected, that we are inputting at certain depth. So
Yes.
from that only we usually do the convolution and we'll get the acceleration at surface level. So
Yes. Yes.
is there any particular criteria to select only the input motion from the interpret region if you are doing for the Pennsylvania?
Generally, the response of the soil or any structure depends upon the ground motion, that what motion you are supplying at the base. So, let's say, and we have to understand that the earthquake ground motion is highly random in nature. Let's say in a particular intraplate region or interplate region, wherever, no two earthquake motions are same. They are always different. Their amplitude parameters are different. Their frequency content parameters are different. Their durations are different. So the thing is, then with different ground motion, you will see that the response of the soil columns are very different. So in general, it is advised to perform the ground response analysis for 2-3 different types of ground motion, see the response, and you can know what is the tentative range of the surface acceleration you can expect. So that is rightly the way to do. It is not good to stick on to just one ground motion. You can use any ground motion. I mean, from a minimum, provided that the PJ value should be in and around the PJ value obtained from the the seismic hazard analysis for that region. If your PJ value is around 0.1 G, means you can go up till maximum 0.15 G and all. So you don't need a ground motion of 0.4 G, 0.3 G in those regions. It may not be, but anyway, for a research purpose, you can do it. But for an engineering design purpose, it is generally recommended that you take the ground motion which is closer to the PJ value of that site and do multiple ground response analysis.
Yes, sir. Yes, sir. Sir, one more last question, sir. Sorry.
Yeah.
Yeah. Sir, for hazard analysis, we usually select some seismic study areas around 300
Yes,
kilometer, 500 kilometers.
yes,
So
yeah.
the other parameters like other seismic other parameters are completely depending upon the seismic area and seismic
Yes,
detail.
yes,
So
yes.
according to the US regulatory committee, they recommended up to 240 kilometers only the radial
Okay.
distance. But
Generally,
here,
it is not 40. It is around 300 kilometer, or for a intraplate, for the high hazard region, like a plate boundary region, it is 500 kilometer from a particular site. So you have to consider all these earthquake sources within that 500 kilometer radius.
okay, so 500.
Yes, 500 and 300. Yeah.
Thank you, sir.
Any
Thank
more
you.
question? Single question, one question, please. Sir, thank you very much. There are no more questions.
Yeah,
We'll go to
thank you.
next one.
Yeah, sure.
Thank you, thank you, thank you.
Thank you.
Thank you. So let me talk about the next speaker. Keynote speaker is Dr. Sri Valsa Kolathayar, and he is an assistant professor in Department of Civil Engineering, NIT Surathkal. Sir, we welcome you to your speech, and 1 minute. So you can see Srivasla Kaltayar pursued MTech from IIT Kanpur, PhD from IIC, and then served as an international research staff at UPC Barcelona, Tech, Spain. He is presently assistant professor in the Department of Civil Engineering, NIT Karnataka, Surathkal, India. Dr. Sri Valsa has authored 5 books that are now subscribed by world university libraries, including MIT and Stanford. And you can see how crowning glory it is. He published over 80 research papers. He is the associate editor of 2 international journals and acted as a reviewer for many international journals. He is currently the secretary Indian chapter of International Association for Coastal Reservoir Research, IACRR, and executive committee member of Indian Society of Earthquake Technology in 2017. The New Indian Express honored Dr. Sri Valsa with edX Award 40 under 40, South Asia's most inspiring young teachers. He is recipient of IEISET Dr. Paul Research Award from Indian Society of Earthquake Technology, IIT Roorkee in 2018. He is the roster of 2 technical committees of ASCE Geo Institute. He received IEI Young Engineers Award by Ministry of Engineers in India in recognition of his contribution in the field of civil engineering. Recently, he was featured in Geostrata magazine by American Society of Civil Engineers for his contribution at a young age. You can see how much he has worked. I think he has more than 24 hours a day. Sir, we welcome you to talk. And you have 45 minutes, sir.
Thank you very much. So at the outset, I thank the organizers for giving me this opportunity, and my thanks to the chair and co-chair of this session. And also it is my pleasure and honor to share platform with my good friend, Dr. Naveen James. Sir, I am trying to share my PPT. So please let me know if this is visible in full screen mode and if my voice is clear to you.
Yes, sir. Visible, clear.
Fine. If there is any issue, please interfere and let me know.
I
hope I can start. Yeah.
Yes, sir.
Thank you. So I will be making a small presentation on disaster geotechniques, that is geotechnical schemes for disaster risk reduction. Because your conference theme is advanced in civil engineering, and civil engineering has a lot of role to play in DRR, disaster risk reduction, in general, and in particular, the geotechnical engineering. So this is the contents of my today's presentation. So Naveen has made my job easy. The earthquake hazard part I can skip actually because he has covered it in very detail. So I will be talking little bit about hazard, risk, earthquake hazard, preparedness, water security, and landslide. I will be touching upon these aspects and the role of civil engineering in mitigating the disaster. So I will be talking some of the extracts of our book. So you can see 3 books here, one on earthquake preparedness by Springer, and another one on earthquake hazard assessment by Taylor and Francis. And the third book is on seismic sonation schemes. So Naveen James is also an author, and he has very in detail made a presentation. So it is easy for me to continue. And another book on water geotechnics and geoscience. So I will be talking some of the extracts from these books connected to disaster risk reduction and civil engineering. So all of you are very well aware about different hazards, natural hazards such as earthquake, flood, tsunami, etc., and man-made hazards like crime, accidents, war, fire, toxic metals, etc. So as most of the participants are civil engineering, and even every public will know what this structure is. So this is one of the wonders of the world, and why it is leaning? Because of differential settlement. So one side of the foundation was weak. Fine. So all of us know it was a geotechnical blunder that became a monument. So there was a problem in the foundation design. It was a blunder, but it is now a monument and a tourist attraction also. It's a major source of economy for that region as well. So even when they tried to erect it, repaired it, they did completely erected it vertically. They maintained some such that there is some unique attraction. So it is attracting people. If the same phenomenon of differential settlement happens to our house, it is no more a monument, it is no more a tourist attraction, but it is a disaster because the utility of the house itself is lost. So we spent our entire investment to make a house. So that is why civil engineer has a role, a special role in the lives of the people, because house is a lifetime, one-time investment in people's life. So coming to hazard and disaster. So there is a declaration made by the United Nations in 2011 at Chengdu. It says there is no such thing as natural disaster. The terminology natural disaster itself is wrong. Floods, earthquakes, landslide, etc. become disasters as a result of human and societal vulnerability and exposure. And it can be addressed by proper measures and policies. So disaster risk reduction is a no regret investment. We have to invest in that, even if it costs a little more extra, but that investment is worth. So when we say there is a risk, there are 4 elements that is coming: hazard, exposure, vulnerability, and location. When we say there is any disaster or any risk, all these 4 elements have to be there. So for example, now COVID-19 pandemic, say even if you assess yourself, if you do a self-assessment with the Arogya Setu app, it will ask you questions. Whether have you come in contact with the COVID-19 affected people, which location are you in? It will assess your location. It will assess if there are COVID affected people in 1 kilometer radius. So hazard, location, then exposure. If you are exposed, if you are not wearing a PPE kit, you are exposed. If you are not wearing a mask, you are exposed. So exposure and vulnerability. If your immune system is low, if you are old age, you are more vulnerable. If you are fit, you are more vulnerable. So if you can reduce exposure, if you can wear a mask or PPE kit and reduce exposure, you can reduce the risk. Or if you can change a location to a safer place, you can reduce the risk. Or if you can stay away from COVID affected people, you can reduce risk. And if you can boost your immunity, you can reduce the risk. Same thing applies to infrastructures also. So if you can plan your important structures like nuclear power plants, etc., in a location where there is minimum earthquake hazard, you are reducing a risk. That is why we don't plan nuclear power plants in zone 5 regions. And if you can reduce the exposure, like say vibration screening, vibration isolation techniques, etc., or if you can reduce the vulnerability of the structure through proper design, then also you can reduce the risk. So same principle applies everywhere in terms of risk reduction. So when we talk about infrastructure development, see, if there is an earthquake that is happening in Greenland where there are no people living, there is no disaster. There is a hazard, earthquake hazard, but there is no risk, there is no disaster because there are no people. And most of the casualties happen as a result of building collapse. So when a city develops, so there are a lot of infrastructure that comes up, which we cannot avoid. So it is a need for development. But if the structures are not built to withstand the earthquake forces, this is what happens. So there is a general saying that earthquakes don't kill people, but buildings do. So here is a wonderful example how civil engineering can mitigate earthquake disaster. You can see a retaining wall on the left and houses on the right side. This is in Kobe line in 1992 in Japan. In 95, there was a major earthquake, and after the earthquake, you can see all the fragile buildings collapse, but the retaining wall is intact. The retaining wall was just reinforced with the geogrid. So that is the wonder that geogrid reinforcement could do. So civil engineering can mitigate the disaster. So there are a lot of avenues to be explored. So usually earthquake happens along the plate boundary regions mostly, and these are some of the building collapse pictures from Indian earthquakes like Shillong earthquake, Kangra, Bihar earthquake, 2001 Kashmir earthquake, etc. And these are some of the damages due to local site effects and liquefaction, like in Kandla port in Gujarat also was affected due to liquefaction. So earthquakes don't kill people, but buildings do. So solution lies in buildings, not in earthquakes as such. And to design safe buildings, we need to evaluate the hazard. So if we see the reaction of people to an earthquake event, first 0 to 1 minute, there is a lot of panic. We don't know what to do. And 1 minute to 1 week, after shocks, fear, there is fear. Then next to 1 month, there will be short-term repairs and there are a lot of blame games going on in the media. Then next to 1 year, there will be long-term repairs and call for higher standards. That is why after 2001 Bhuj earthquake, in the immediate next year, the code was revised. Then next 10 years, people forget it, complete reluctance. Then when next earthquake comes, again, these steps repeat. So actually, there is a need to have preparedness well before an earthquake. We have to keep the preparedness alive. So that is the key. Now coming to the earthquake scenario in India. So 15% of the great earthquakes of 20th century happened in India, and Assam earthquake is the 7th largest in the world. And major earthquakes happen along the plate boundary, but we have intraplate earthquakes as well, like Bhuj earthquake, Latur earthquake, etc. So these are some of the major earthquakes in India in the last 100 years. And you can see some of the earthquakes that happened in southern parts of the India also. So this is the seismic sonation map of India as per 2016 IS code, and it was first developed in 1962, then revised in 66, 70, 84, and then in 2002. Anyway, there are a lot of comments from researchers about the unscientific nature of this, as it was completely based on earthquakes and fault, and not a proper scientific hazard assessment has gone into it. So there are several researchers, several studies on assessing earthquake hazard for several parts of the country. So anyway, we have also done an attempt by doing a hazard assessment for the entire country. So we have collected data from literature, the historical earthquake data from literature and instrumental data from different agencies. So this is the spatial variation of earthquake epicenters across India. So collected data compiled from 21 sources and data from 250 BC till 2010 AD. And all these are in different magnitude scale. So they have to convert it into a unified moment magnitude scale, which does not saturate. So we have developed our own magnitude conversion relations. So this was published in Seismological Research Letter. So we have converted the magnitudes into moment magnitude scale using our own relations. And then declustering was done because there can be aftershocks and foreshocks, and we consider earthquake to follow a Poisson distribution. So each event has to be independent. So we have removed the dependent events, and this is the final independent declustered earthquake events in and around India. And then we have also digitized all the seismic source data, And now it is freely available in Bhucos. If you search in Bhucos, the digitized fault map, the seismotectonic atlas of India, it is freely available. Anyone can download it. You need to just register. So we have superimposed the earthquake data into the fault data, and then comes assessment of the hazard. For that, see, India is diverse in lifestyle, culture, language, not only in that, but in seismotectonics also. See, we have active tectonic region with the shallow crustal earthquakes in the Himalayas, subduction in slab in the Indo-Myanmar subduction zone, and interface subduction earthquakes in the Hindu Kush subduction zone, stable continental region in the southern peninsula, and a mixture of active tectonic shallow crustal earthquake and interface subduction earthquakes in the Andaman Nicobar region. So different ground motion prediction equations has to be used for these different tectonic provinces. So ground motion prediction equations already Dr. Naveen have explained to you about that. So that gives you the ground motion parameter as a function of magnitude and distance. So there are several GMPs available across the world. So we have also made an attempt to develop our own relation for the northern Himalayas and northeastern Himalayas. So my research student so has done that work. So it was recently published in Journal of Earthquake Engineering. So two relations have been developed based on a actual strong motion data using a multilinear regression. So this is actually expressing ground motion parameter, that is acceleration, as a function of magnitude and distance. So seismic hazard evaluation, there are DSHA and PSHA. So I will not go into that all because already Dr. Naveen has explained to you that. So we have done a deterministic seismic hazard assessment for the country using different ground motion prediction equations and different source model fitted in a logic tree framework, and you can see the hazard map, spatial distribution of PGA. And now coming to a seismicity analysis, see, even though earthquake is a random event, so if you take an earthquake in the region, in a region for a certain period, say 100 years, so there is some. So that is how Gutenberg and Ritter, they observed some trend. So there is a GR relation so available. So if you can plot the magnitude of it with the number of earthquake events, so it is obvious that large magnitude earthquake, their number will be less, but small magnitude events, the number will be very high. In Northeast, there are, say, every week we see a report of a small magnitude earthquake, but large magnitude earthquake, they come, say, once in 50 years or so. So there is a trend, and that slope of that curve is called as B parameter, and the intercept as the A, which represent the background seismicity. So that is why there is a lot of uncertainties involved. In DSHA, we are assuming just a single scenario with a single magnitude and single distance. So there are a lot of uncertainties. That is why we follow a PSHA. So I will not get into the details. So we have done a probabilistic seismic hazard assessment for entire country using 18 different models fitted in a logic tree framework, and you can see the final earthquake hazard map. And this is, as Naveen told, this was estimated at the bedrock level using the GMPs, which gives the PGA value at bedrock level. So such GMPs were used, and this is the hazard map at bedrock level. So now to bring it to the surface, so site amplification already he has discussed in detail. So for a large country like India, we have used the topographic gradient as a proxy for site amplification and brought the hazard to the ground level, and you can clearly see. So these maps show surface level PGA value using DSHA as well as using PSHA. So if you see the bedrock level map and surface level map, you can see there is a hike in the surface level values. So there is a certain amplification that has caused. There are also scenarios where de-amplification is also possible. In a recent study we have done for a thermal power plant in Chittagong, we have seen there is a de-amplification. It is because of the soft soil condition. So this is the case study which we have done. So we have observed, here we have done the real site characterization because SPT data and VS30 values were available, and we have done a ground response analysis using deep soil software. Anyway, fine. So that is about assessing the earthquake hazard. So I have just presented a case study of India that we have done, and we have then integrated the population also to the earthquake hazard, because higher the population, higher the risk is. Population and building typology also matters. So one paper is just going to be published in Natural Hazards. So we have done a study. Actually, we have followed a DSH study, but we have integrated population and land use along with the seismic hazard. And also we have developed an earthquake readiness index tool. It's a survey-based tool. So that will tell you at what level of preparedness you are. See, there are certain things what needs to be done before an earthquake and during an earthquake and after an earthquake. Why preparedness is important? Because say if you board a flight, every time you board a flight, they will tell you what needs to be done if there is an emergency situation, how to take up the exit window, how to pull out the oxygen mask. But most of us traveled many times, and many senior people also never experienced such a situation where they have to use emergency exit window or oxygen mask. But every time you board, they tell you, even the probability of accident is very low. But if you check the north eastern regions or Himalayan region, see 1897 Shillong earthquake, 1905 Kangra earthquake, 1934 Bihar Nepal earthquake, 1950 Assam earthquake, and every actually 20 or 30 years there is a major earthquake happening, and we don't know. Every generation is facing an earthquake, a major earthquake, and we are not prepared. In Japan and all, every school kid know what to do. In 2015 Hindu Kush earthquake, there was a situation when in 2015 October an earthquake happened in the school. Children were rushing to get out of the building stair. Actually, stair collapsed, and a lot of kids lost their lives, sadly. But actually, the classroom was safe. They could have hidden their head below the table and save their head, because most of the casualties happen due to falling of non-structural elements. So there are building collapse also that happens where we cannot do anything during the earthquake, but that has to be done before an earthquake and inspection. Anyway, considering all these factors, we have done a survey and we have seen that literate people are little highly prepared compared to the illiterate, uneducated people, but even the preparedness level is not up to the mark, and at individual level, employed people are more prepared, but students are more prepared at community level. So these are the that we have seen. These kinds of workshops and seminars help to keep the preparedness and awareness live. So it's a need of the hour. So you know how a building behaves when there is an earthquake. So if you are in a bus and the bus suddenly starts, your top portion of the body will go. So simple law of inertia, you know. Same thing happens to the building also. When there is a shaking at the base of the building, the upper portion tends to go in the opposite side. So higher the stiffness of the building material, higher the chance of collapse. And similarly, coming to geotechnical structures, so usually the angle of repose is the maximum inclination the soil can have. But if there is an earthquake, even at angle of repose, the soil will fail under seismic condition, because there is an additional lateral force coming into picture. And ductility, so that is why we have seen an example of geogrid reinforced wall. It was remaining stable even after an earthquake. So that also helps. So this example I have shown you. So earthquake hazard is very important to plan future construction activities and retrofitting existing buildings, and local conditions amplify. So that is why geotechnical site investigations and site characterization is very important. And estimated value help in not only in design of structures, but also in geotechnical structures like foundation structures, and to evaluate the liquefaction potential at a site. The spectral acceleration value or the response spectra are useful in studying the response of structures, and preparing the community to face a future earthquake is very important. So I hope I have 15 more minutes time left. So anyway, this is our book on earthquake preparedness. So one chapter titled Do's and Don'ts Before, During and After an Earthquake. This is available for free download. You can Google out this book title, and you can download that chapter for free. So if you download the sample pages, you will get that one chapter free. So you can have a glance through that, where we have discussed about preparedness for individual, household, at community level, school emergency plan, at public policy level, etc. Now I will come to water security aspects, because flood is also a hazard, drought is also a hazard, which turn out to be a disaster for us. Now India is a country of rivers. We have number of rivers, Ganga, Yamuna, Godavari, Narmada, Sindhu, Kaveri, Brahmaputra. We are blessed with a lot of rivers. And we are blessed with precipitation also. Average annual rainfall in India is 1176 millimeter. And now also, for last 100 years data, if you take, it has not varied much. Almost now also, we are getting enough rain. Every year, we are getting about 4,000 kilometer cube of water as precipitation and another 400 kilometer cube from neighboring country rivers as a runoff. So 4,400 billion cubic meter or kilometer cube of water we receive from precipitation itself. And how many dams we have in India? When we got independence, so there was about 300 dams. Now we have more than around 6,000 large dams in the country. We have 6,000 large dams in the country, and total storage capacity of all these dams put together, it is just less than 400 BCM. So means even 10% we are not able to store. And even though we are receiving enough rainfall, actually the distribution has become erratic due to climate change effects now. So 1 month rain is sometimes received in a couple of days. So there is no time for water to percolate into the ground. So there is flood as there is high runoff. And also we have paved our roads and built a lot of infrastructure, preventing the way for the water to percolate into the soil. So during rainy season, we have flood, and summer, we have drought. So this is a topo sheet of Bangalore in 1960. So there were, say, about 150 lakes in Bangalore, and now it has reduced to less than 60. You will not believe the current majestic Kempegowda bus stand was once a lake named Dharmamudi Lake. Now we cannot even believe that there was a lake existing. So that is why our storage structures are also diminishing. So that is why we have water scarcity, water stress. 50% of India faces high to extremely high water stress. If you see the same map, world map for precipitation, India is shown in green. But if you take the water stress map, India is shown in red. So we usually say India is not running out of water, but water is running out of India. So this is let's have a look into the traditional water harvesting structures in India. So this is a picture from my home actually. So during rainy season and during summer season, same pond actually is from my hometown, our own farm field. And because of such structures, in last 30 to 40 years, the water table has not gone down even by an inch actually. It is because of these kinds of water storage structures, which are called as kulams or ponds. So especially state of Kerala, especially the northern Kerala, is blessed with a lot of such traditional water storage structures. And we use that water even for in summer season also, we get enough water to irrigate the lands. And in Rajasthan, they have tankas. This is to store drinking water because the rainfall is less. And khadins or dhoras in western Rajasthan, where they have an earthen bund actually, and they store water in that. Jhalaras of Jodhpur, stepped wells, Bavadis in Gujarat and Rajasthan. So they are also actually place for social gathering. So they have a lot of Bavadis. And this is Kankaria Lake in Gujarat. So our SBI logo also has taken from this lake only. In Ahar Pines of Bihar. So Ahar is a big lake and Pine is a canal, long canal. So in Bihar, when there is flood, no, the water is diverted through these canals called pines. And so wherever this water goes, no, flood water is diverted. So it recharges the groundwater and there is no flood. And finally, it is stored in Ahar. So it saves water for the summer season as well. And Bengal's inundation channels, Bhandaras in Maharashtra, Cheruvus in Andhra, tanks or carries in Karnataka, Kalyanis, and Zings in Ladakh, and Surankas. These are horizontal wells. These are also seen in northern Kerala and southern part of Karnataka where I am. So we have a laterite and it is very stable and you can drill horizontal wells and the water is so pure. And if we look at hydraulic engineering in India, ancient structures like Great Bath of Mohenjo-daro, Sudarshan Lake, so these are all from 250. So in 2nd century AD and 1st century BC constructions. So this is 4th oldest dam in the world, which is still in use, built by Chola King Karikal and Kallanai Dam in Trichy, Grand Naikat. And so anyway, so that is some of the traditional water harvesting structures which we need to revive actually. There is a need to revive them because now these days, even the United Nations, SFDRR talks about ECO-DRR, ecosystem-based disaster risk reduction, turning into nature. And there are other modern techniques like contour bunds, pits and shafts, boulder checks, recharge wells, water pool, afforestation, etc. So this is a case study from Jharkhand, Krishi Vigyan Kendra Ranchi, where I was a consultant. So we have created some recharge wells and water pools. And this is another case study from Dunda, Uttarakanshi. Actually, they have River Ganga at the down, and on top also they have a perennial water source, but the village which is in the hills, no, they don't get water actually. So we had tried to repair the pipeline supply from top Adera, where there is a perennial water source supply, fresh water supply. And this is another geotechnical structure, that is groundwater dam or subsurface dikes, which can store water underground actually. So this is an excellent technique. Why? Because it does not need any space. To construct a dam, no, you need to displace people actually. But underground dam, no, on top of that, you can have your structures and vegetation. So it is actually water is stored. It can be a clay barrier, or it can be a geomembrane, impermeable membrane, or it can be even concrete structures like this. This is a case study from Tamil Nadu. So there are a lot of such subsurface dikes. And in Japan, Khadin Dam is very famous for that. Anyway, coming to freshwater sources, we have several options like more inland reservoir, interlinking of rivers, groundwater, desalination plant, wastewater, etc. Now, if you look at the global dam construction, after 2000, nobody is building large dams. Even countries like US, Canada, they are decommissioning their dams because they are water bombs. No, after 100 years, once its life is over, what to do with that? And it causes a lot of environmental hazards also. And now coming to interlinking of rivers, yeah, small rivers you can, Krishna, Kaveri you can link, but very large river linking Ganga to Kaveri, etc. There are a lot of environmental issues. Groundwater, yeah, that is the best, one of the best source of water, fresh water, if we can recharge the groundwater. Desalination plant is very costly affair, and again it has environmental problems also. Wastewater reuse, it can be used for gardening, toilet flushing, etc. In countries like Singapore, they even use for drinking also, but we hesitate to drink reused water. And another option is coastal reservoir. I will come to that. So this is a pori, actually. It is a natural sandbar from Kerala. So during summer season, so there is a naturally a sandbar is formed between the river and ocean. Where river joins the sea, a sandbar is formed so that the salt water does not come into the river. So this is a scene from Porikara. So actually, Marina Barrage is an artificially constructed such sandbar, artificially constructed dike actually. So Marina Barrage, they got the United Nations Environmental Award also. So this is a wonderful structure they have created as a barrier between the Marina Bay, which is saltwater bay, and fresh water. So they have stopped the saltwater intrusion. So I want to play a small video. So if you are not able to hear the audio, please let me know. I hope it will work. Well, so it was a video that we have prepared from IACRR about the concept of coastal reservoir. So if we look back, no, even in our own country, the Tannirmukkam Bund, which is constructed in 1970s in Kerala, there is a coastal reservoir actually. So Kuttanad is an area where farm rice cultivation happens below mean sea level. So they have constructed a barrage, Tannirmukkam barrage, where in the Vembanad lake they are storing fresh water, because you can see Pamba and the Meenachil river fresh water is coming and they are storing it there. So this is the aerial view of the Tannirmukkam Bund. So we have done a study and published several articles for that. So recently the Swaminathan Commission report, Swaminathan report actually development package. So that report is very comprehensive and gives various suggestions, and the third stage of construction is almost over for the shutters, etc. And also we have done another study to turn another one of the second largest brackish water lake in India, that is Ashtamudi Lake, one portion of that into a freshwater storage by just building a 200-meter dike, which can solve the water issues. And even the bathymetry also we have analyzed. So there enough depth is there and a lot of water can be stored. So a feasibility study has been completed, and we are also having a project funded by Imprint, MHRD and Ministry of Water Resources and SCRB-DST on the coastal reservoir concept. So now see, when such water structures like traditional structures, they also face a lot of threats due to collapse, side collapse. And these are this is a picture from Bihar last year. A new bridge was constructed and the approach road was collapsed in the rain. And we have seen landslide actually in 2019 and 2020. Last year also in Kerala, Karnataka, especially in lot of rainfall induced landslide. This is a picture from Kavalapara where around 90 houses were buried under the mud. You can see a small part covered with vegetation. 7 to 8 houses were saved. So it is because of the reinforcement provided by the vegetation. So tree root reinforcement or act like a fiber reinforcement. And you know about the power of the vetiver, whose roots go even up to 3 meter long. So we have done some studies on fiber reinforcement in soils using different natural fibers like kayar, sisal, arakka, etc. So this is a study and published in Journal of ASE. So we have seen that kayar fiber provides a lot of strength to the soil. So we have done several laboratory studies and SEM microstructural studies as well as model studies. So you can see the interface between the fiber and soil. So they form a dense matrix, and due to the interface friction between the fiber and the soil, so its strength is increased. Shear strength gets increased. So geosynthetic reinforcement is very popular these days. So more than 50 years research has been going on, and now it is becoming more and more popular. So there are different types like geogrids, geomembranes, geotextile, geocells, geonets, etc., which has applications in land engineering, coastal protection, rockwall protection, canal lining, revetment, flood control, slope retention work, ground improvement, gabion walls, GRS walls, etc. So we have done some studies and we have developed a new geogrid using a new material, Alaka sheath. So I have patented this recently. So this is a study that we have done using Araka leaf sheet, making it into grids, and we have conducted model studies. So we have seen Araka leaf has a much more tensile strength, but it is very brittle. So you can see the tensile strength, stress strain curve, but its performance in the field is awesome. Just as good as the commercially available geogrid, which is actually costly. And also another innovative geosynthetics is geocells actually. So in this also a lot of studies have been done. Geocell has a lot of applications in embankment foundation, road foundation, footing foundation, earth retaining wall, and slope erosion control, etc. So you can see a case study from abroad how geocell is placed in the land. So we have also developed a new geocell using Araka leaf sheath, a new material. So we have conducted model studies, and we have seen that Araka leaf geocell also perform as good as commercially available geocells, but only durability is the issue, which can be addressed by proper treatment, or for short term, especially for slope stabilization applications, we can use this, because in long term, we can add a vetiver reinforcement as an echo DRR solution. Actually, geocell act through three mechanisms such as lateral support reaction, vertical stress distribution, and membrane effect. So this is the effect. Usually, this is how the failure surface is formed under a footing. So if you are reinforcing it with a geocell, you can see how the failure surface gets confined actually. It is because of the interface friction angle, lateral resistance effect. Actually, the bearing capacity gets increased 4 to 5 times, and settlement also gets reduced. So we have developed a geocell using different material. Actually, my students have done using Araka, Kaya, jute, sisal, etc. And we have assessed their performance. So recently a paper was published in an ASC journal also in that. So geocell has a lot of applications, especially in retaining wall. So we have done a model study in the laboratory, replicating rain and different types of geocell wall. Actually, we have constructed and assessed its performance. So this was done actually by an MTech student with very minimum resources. We even didn't have a loading device. Load was applied using construction blocks actually. But this was a good work by the student and recently published in Geotechnical and Geological Engineering journal by Springer. So what we have observed is that, see, HDP geocell and Kaya geocell were compared. Their performance is very good actually. Both perform very well. But HDP has a little higher performance under dry condition. But under wet condition, we have observed when replicated rain, we have seen that the Kaya geocell wall performs much better than HDP geocell wall. So that is the beauty of the natural material. So this is a consultancy work that we have done for Mumbai-Pune Expressway, where an RE wall was constructed. So this is using simple geogrids. And this is another consultancy work. Recently, I was the consultant for that. So this is from NH66. A major portion of the road was collapsed in last rain. Around they wanted. So what we study is a combination of soil nailing, because there is a road that's going on at the bottom, and on top there is a highway. I hope everything is fine now. If there is any issue, please let me know. If my voice is not clear or presentation is not visible, please let me know if there is any problem.
No, it's absolutely fine, sir. Srival sir, you can proceed, sir.
Sir, only 7 minutes.
I will conclude in another 2 to 3 minutes.
Yes, sir. Thank you.
Pardon?
No.
Yeah.
You answered already.
Yeah, I am. Yeah, fine. Yeah, I will conclude in 2 to 3 minutes. I am tracking my time. Fine. So this is the design which we have given using geocells. So coming to the concluding remarks about soil reinforcement. See, soil reinforcement using alternative material, offering lateral confinement has a lot of scope actually. Cellular confinement system, even though a lot of research has done, it is not very popular, especially in tier 2 cities. No, when we give such designs here, they say they get contractors. They only get contractors who build RCC wall. RCC is very costly and it is not environment friendly. See, in places where it has to be built, we have no other option. But there are so many places where we can go for soil reinforcement. No need to waste money on RCC wall, and the carbon footprint it creates, especially steel and cement, it is also very huge. So we can go for geocell retaining wall or RE walls, etc. Even natural materials like kaya, bamboo, jute, etc. can be used, especially for slope stabilization applications. So eco DRR is the future for sustainable development in line with the Sendai framework for production. So I will conclude. So these are some of the our actually from where I have taken some materials. So
pick a thesis. ఇదొకటే కానీ నువ్వు అందుకు నేను మ్యూట్
see
చేసుకోవాలి.
some voices coming. Fine. Anyway, before ending, I want to invite all of you to the 7th International Conference on Advance in Geotechnical Earthquake Engineering Soil Dynamics. So actually, on behalf of the organizing committee, I act as an organizing secretary for this conference. It is my pleasure to invite all of you. So this is a conference series, 4 yearly, once in 4 years it happens. And past 5 earthquakes, past 5 conference series happened in the United States and last one in the New Delhi, and now it is going to happen virtually. So we are going to have it in a virtual 3D platform, and the registration fee is also kept very low, as minimum as 1,000 rupees or so. So you can just log into 7icraji.org and get the details. So we have an excellent array of speakers from different continents and an excellent program for 4 days program. So I invite all of you to, there is a non-author registration option, which is very nominal registration fee. So on a 3D platform, you can enjoy the conference and learn and benefit from it. We have an excellent keynote speakers and different technical presentations, and 8 book volumes by Springer are also being published as the conference proceedings. So with this, I will end my presentation. Thank you very much. If there are any questions, I will be happy to take.
Okay, let me take the opportunity to summarize what is told. Sir told about the ring of fire and Kangra earthquake, disaster preparedness, earthquake magnitudes and relations, hazards, bedrock level, focus on the T-ground acceleration. So every generation has experienced at least one earthquake in the, let us say, Indo-Gangetic belt or Trans-Himalayan region. And earthquake-centered education is there in Japan. And he has mentioned some books. So our centuries-old tradition of building the ponds and protecting the water has been forgotten. We are not giving importance to that, and we are facing the water crisis. And then water cultivation. So filling up of the lakes, he has told about that bus stand at Kormang, some place in Bangalore. I have seen many in Hyderabad, and barriers between natural and seawater. And his patented product also he has displayed. He has showcased the models done by students, and topics are very diverse. And can I ask, let us say, the participants to ask 1 or 2 questions, so that I will conclude by 2 more minutes. Sir,
Yeah,
we will
please.
be in touch with you, sir. We will be in touch with you.
Yeah. Thank you.
Thank you, sir. Thank you,
Yeah.
Prabhakar sir. Thank you, Srivalsa sir. Thank you so much. Prabhakar sir, would you like to give any concluding remarks, or because you have requested that you wanted to go on lunch?
I don't have any this thing. See, they have shown their deep knowledge, and particularly speaker number 2 cannot comprehend the amount of work he has done in 1 hour. He needs
Right,
a
sir.
1 full day, and
Yes, sir, yes, sir.
diverse are so interesting and applicable to humanity. And I am not down counting the author number 1, who has highlighted both the methods, probabilistic and deterministic. And the
Right.
speaker number 2 worked on deterministic, and he has worked on probabilistic. We cannot compare. His line is different. His line is different, and they have done outstanding of work. And speaker number 2 has given a chance to all the participants for a 4-day workshop, whatever at his place, and that we should appreciate. Thank you very much. This is all what I want to say.
Thank you. Thank you so much, sir. Thank you so much, sir. Thank you so much, Srivalsa sir and Prabhakar Rao sir. So you may go ahead for lunch, sir. Thanks a lot. Thanks a lot. So we will be having paper presentations right now, and we will be calling upon names. Srivalsa sir, you can stay back and enjoy the paper presentation. So there are few paper presentations, and each presentation will be going on for 10 minutes.
Thank you.
Yeah. So to begin with, I would like to call paper number 1, Sandeep Kumar. If you are present, please respond. Paper number 126, Swaroop Shirpuwar. Paper number 126. Paper number 141, Sriram Karthik. Sriram Karthik, sir. All right, Sriram Karthik sir's paper is with Sham Chamberlain, who is the assistant professor in our department itself. So if he isn't available, we can go ahead for the next presenter. Excel Money, Bebeli, and Zahibodion. Paper number 5. You're present, sir, here? Paper number 5. All right. So paper number 14 is right now with us. Nirav Kumar.
Yes, sir.
And,
I'm here.
Yes.
Hello,
yes,
my
yes.
voice is audible, sir?
Yes, you're very much audible,
Okay.
Nirav, sir. Nirav. So you can able to share the screen. I mean, is it available for you? Yes.
Okay, my screen is visible, sir?
Yes, it is visible.
Okay.
It is right now.
Just wait a minute.
Not yet. Oh yes.
Okay, it is visible, sir?
Yeah, it is visible. It is visible.
Okay. So may I start the presentation, sir?
Just a second.
Okay,
let me introduce. So here it is paper ID number 5. It is, and the authors are Axel Mani Bebeli and Zohibo John. So they are going to talk upon geotechnical parameter study and solidification of marine sediment for road engineering. So excellent. Nirav Kumar and Umaria. So this is the topic on comparative study of existing cement fly ash, gravel pile, and encased stone column composite foundation. It is. So you will be given a 10 minutes of time, dear presenter. So you will have to present it, and you have certain rules to be followed, and the chairs will be following certain rubrics because we also have best paper presentation award as well. So keeping that in mind, so make sure you are going to complete the presentation well within time and also giving out the best out of it. Okay, so I wish you all the very best, and please go ahead with your presentation.
Yes, sir. I will try my best. Okay. Thank you. Respected Dr. VN and Prabhakar Rao sirs. Okay. Engineer VY Ramesh sirs, organizers, committee members, and all my participants. Warmly, good afternoon. I, NB Umravia, a research scholar at Sardar Vallabhbhai National Institute, Surat, going to present my research articles on the comparative study of the existing fly ash and gravel enhanced fly ash gravels and enhanced stone columns with the just wait a minute. Okay. Gravel piles and the enhanced stone columns composite foundations. These are the flow of the presentations. As we know that nowadays the city urbanization and industrial growth are more and more the requirement of the land to establish of the infrastructures and the and industrial expansions. One of the city is a Surat, which is situated at the near of the coastal area. So there are the lot of the industrials are already nearest of this place. Okay, if we're looking the geological conditions of this city, okay, the city shows the deeply backwater soils, and this is defined as a problematic soils. The problematic. So snow having the low bearing capacity, facing the problems like as a settlement, as like the settlement overturnings, and it is a problems to facing the infrastructures to resist on this kind of the problematic soil. So that is the compulsory to need to do the ground improvement techniques. Okay, either there are a lot of the techniques available in the geotechnical solutions to reducing the differential settlement as well as the lateral displacements of this solution. So these are the techniques. Among of that, the enhanced stone columns and the CFG piles both are the ground improvement technique to reduce the settlement as well as the as a vertical settlement and as well as the lateral settlements. So here my objective of this study to behaviors of the enhanced stone columns and the CFG piles under the embankment supported it's a design mix as well as the installation method. The numerical analysis of the embankment supported by the CFG and enhanced stone column piles with the square patterns applications and perform the static load under the numericals model with the defined form applications. What are the materials which we have to the use for the making of the enhanced stone columns? Normally, the stone columns is made by the crushed stone aggregate and aggregate within the 20 to 40 mm, and its advantage is the methods to give the reinforcement slip for the enhancement. Therefore, the name is known as the enhanced stone column. The CFG pile is made by the cement as well as the industrial weight like as a fly ash and the gravel to integrate with the proper amount of the mix with the adequate amount of the water and achieving the grade from the C5 to C30, where the C is a mix. As we know that what are the materials which these are just very speedily the cement, ground, fly ash. The cement you have to use as per the codal provisions. Fly ash either you have to use as a grade 1 and grade 2. The IS code 3812 2016. One of the researchers who already works on this area, and he can make the design for the M20 mix. The proportion of the cement is as per the table is mentioned, that is shown at help. Okay, installations of the enhanced stone columns is the basically the 3-step. First step to excavations like as a pile. Second is the laying. Okay, and third is the filling of the aggregate and the pour inside with using the heavy equipment. These are the flow chart. Okay, I'm not going to be deeply in this part for the installation process. These are the flow chart of the installation of the cement fly ash. Where both the methods, their installation process may be almost the same. That's why it is defined as a column technology. Both methods are defined as a column technology methods, and there is applications to provide the support of the heavy structures and transfer load to the problematic soils like that. So I have been the use. Before that, we're going to the numerical analysis. The arrangement of these columns either in a triangular pattern or the square pattern. These are the numericals model which I have to take. Okay, the problem is the considering of the embankment. Its length is a 28 meter wide and 4.9 meters height, which is basically used for the transportation purposes like as a road and the railway. And here the non-uniformity characteristic of the consider of the foundation soils have the 4 different soil strata like as a sand, silty clay, soft clay, and the clay. Its depth is a 0.5, 3.5, 10 meters, and the 6 meters respectively. When we analyze such as a kind of the enhanced stone columns and the CFG piles, that time in a Plaxis 3D, we have to consider the volumetric pile. And this is a property. So these are my Plaxis 3D modelings. Okay, the element which I have to mention first, second, third, and fourth. First, it is a embankment fill geosynthetic anchors in a stone columns is a vertically, and CFG pile we have to apply as a horizontally. Sand cushion is applied. Composite foundations of the reinforcement zones, soft soils, and all the things. Here we have to use at the half portions of the embankment smooth. The overall the height is 24.9 meters and the width total the length of this is 50 meters. Okay, so the model property which I have to consider for input purpose in the Plaxis 3D are the mentions of the different soils, embankment, cushions, silty clay, soft clay, CFG pile, and arrangement. So now the results, which is the base on the both the material which I apply on the embankment applications, the relations of the the material, the characteristic of the input data as a zones. Okay, zones of these graphical representations. The different length of the 12 meters as well as the 14 meters of the length of the CFG piles and the enhanced stone columns with the variable stiffness considering of the 250 kilonewton per meters as well as the 5,000 kilometers. The relationship is externally apply the stiffness pressures on the center row. If we have been looking in order to enhance stone column, the stiffness is increasing 20 times, is average the settlement is a decreasing rate is a 130%. But in the case of the CFG piles, the average value of the settlement is less than of the enhanced stone columns of the 5,000 kilonewton per meters, and hence the stiffness which is the basically based on the CFG based on the enhanced the geosynthetic is applied, and in case of the CFG pile, the stiffness which is the based on the its grade purposes. Now, one of the things I have to see here, as per the presentation, is there. One of the important the relation is the mention is the embankment, the settlements under its filling materials. It's a self-weight. The relationship between the distance from the center of the embankment average the settlements in both the CFG and the enhanced stone columns of materials. Here are the average the settlement is a 1 mm in a CFG piles, while the enhanced stone column the settlement is shows as a 6 to 6.94 mm, and the average the disturbance of the should be the found as a 0.07 mm and the 0.1 mm the respectively. This is the geographic. This is the graphical representation of the CFG pile and enhanced stone column. The average vertical settlement and a lateral settlement of the variable the length of the 12 meter, 30 meter, 40 meter length. The average the lateral settlement is decreasing the 30%, and average the vertical settlement is decreasing the 24% when we compare of the enhanced stone column and the CFG pile. So due to the remarkable decreasing of the value of the lateral as well as the vertical settlement of the CFG piles and CFG piles, it concluding is that part concluding that the higher the resistivity capacity of the CFG by comparisons of the enhanced stone column. So that's why the arching effect should be only the creating in the CFG pile. So this last result, which is only the comparisons of the two different 12 meter length of the CFG pile length and 14 meter the length, it's an arching effect. If you have to see the figure the left hand side, the arching effect is creating nearest pile because of the CFG pile. It is a stiff materials having the resistability. So surrounding the near the soils is creating the arching effect and arching the soil stresses. So hence it is a zones. So last result is based on the 12 meter, 14 meters, the length of the CFG pile arching effect has been the zones. It's a settlement, and arching effects is may reduce with increasing the length pile, and hence the longer length having the good capacity. They having the good friction resistance capacity.
Sorry to interrupt, Nirav. You have another 2 minutes left.
Yes. I'm concluding my last part. Okay. So when the soil pressures and its groups, the geostrophic embankments, where the investigator using the 3-dimensional spectrum analysis. Okay, we have to concluding that when the increasing the stiffness of the enhanced stone columns, confining the pressures of column pressures is higher, the CFG grade makes effect on the stiffness of the minimize the lateral and the vertical settlement. The CFG's reinforcement techniques give the better result comparison of the enhanced stone columns. And additionally, the length, significant the roles, the stress is applied by the structure. The subsoil to surface settlement is mainly affected about the grounds, and the soil arching has been the little affected on the neglecting arching. So these are my concluding remarks. These are my references. Okay, and thank you. Any questions or comments?
Yeah. Thank you so much, Umravia and team, for giving a very beautiful talk. In fact, I must say your presentation is looking really nice. I mean, you have also completed the presentation well within the time. It's really seems like a very good commendable work. In fact, so I request the participants, if you have any questions, you can please. We have 1 minute time left over. So you can please ask any queries if you want to, or you can post them in the chat box. We can try to collect them overall, and we can try to display it later in case if the time is not sufficient. Well, in that case, thank you so much, Neerav Kumar.
Thank you,
Only,
thank you so much,
excellent
thank you
team.
so much, and
Thanks.
thank you,
Thanks a
organizers.
lot.
Please.
Yeah,
Okay,
yeah.
sir.
Thanks a lot. So now I would like to call upon paper ID 126, who has contacted me right now. So Swarup Shirpur, Prakash Patil, Nikhil Pitale, and Sanket Shanghai. Okay, so they are going to be presenting on comparative vulnerability analysis of structure with sand and soft soil. So Swarup Shirpur, I think you can respond. Hello, Swarup.
Sir, Swarup, sir, is joining in another link. Okay, sir, I think so. So please inform to in another link, sir.
Oh. Swarup, please join in the link that is given in the WhatsApp group. Well, anyways, I can see in the chat box that Sriram Karthik is also available. So Sriram Karthik, if you are available, can you please respond? And I think we can go ahead with your presentation.
Yes, sir.
So
Hello.
is this Sriram Karthik? Yeah.
Yes, sir.
Yes,
Yes, sir.
Yes.
Am I
Yes,
audible,
Sriram.
sir?
Yes, you are audible. So you can share your screen.
Yes, sir. Please give me 2 minutes, yes, sir.
Yes.
Is it visible, sir?
Yes, it is. It is visible. Yeah, it is visible. Please make it slideshow, full screen, and you can start presenting.
Yes, sir. Now, everyone, this is Karthik. I'm a PG student in KL University, and my topic is paper is about strengthening of in construction using classifier and acquired geotextile mat. And in my paper, we go through abstract introduction, literature review, and research, and with the concluding remarks with the references. Coming to the abstract, in our country, 20% of land is in clay, and that clay is very expensive to maintain that. So to maintain that type by using just and to the environment also. And in this paper, I carried out my experiment using classify ash and oil fiber mat. And the experiments I carried out of CBO test, UCC test, and the common as OMC and MDD test. The result came that it is very good to use the oil and the ash so that 10 parameters only increase. You can see that in map, blue color, I mean the in the Indian map, the blue color called alluvial soil is mostly dominant in that North Indian, and while coming to Madhya Pradesh and Maharashtra, it is of black cotton soil, and the red soil. And these three soils occupied all over India. Coming to this topic, what is, I mean, you know that what is subgrade? Subgrade is the basic one, the first step to the pavement, and stabilization to the subgrade is a process of improving that to meet the engineering purposes which we want or which we need to the pavement. So what is the use of this? See, in some
Excuse me,
places of payments.
Sriram Karthik, your slides aren't moving.
Sir.
Yeah. Are you changing the slides? Or you're still in the first slide?
Yes, sir. No, sir. No, sir. I am in the fifth slide, sir. No, sir.
No. It is not changing. You are still in the first slide for us. Yeah. Now it is in fourth slide. Okay.
Okay. Sir,
you can continue. You can continue from fourth.
Sir, network problem.
Yeah. Your voice is also lagging.
Okay.
Yeah. Continue.
It's no problem. Coming back to the use of the stabilization, it gives us. So the first thing is we cannot replace all the soil that is in the place of that one. So by improving that soil, technically called as stabilization, we can improve that site conditions for that pavement. So how that it can be done? Mainly done basically with compaction and consolidation, and adding admixtures like lime, cement commonly. And now in recent years, fly ash is also one of the material that is extensively used. And in this paper, we use that classic fly ash we use, and oil geotextile mat, not fibers, is the mat. The classic fly ash why you use because the lime is extensively used. Okay, lime and cement are okay used, and in recent years we are using fly ash. Why fly ash means it is more, it has more content of CaO. Again, lime content, so it can be somewhat cementitious and can improve the strength of the soil. When coming to mat, geotextile, these are the modern solutions to the geotechnical problems nowadays. And see, these are the two types, and non-woven and woven type. Non-woven is somewhat dense, and woven type is somewhat uniform like thing. So quiet geotextile is a sustainable material in the coastal states like in Kerala and Andhra Pradesh.
Sriram, sorry to interrupt you. Again, the slides are not moving. Can you go for full screen mode, presentation mode?
Sir, I was in that, sir. Then now?
Just click on F5.
Sir, now?
No. Something. Other tab is opened.
Hello.
Sriram, you can continue. You are losing your time also. Just minimize the tab. Settings tab is opened. Oh, your presentation is lost.
Okay, sir. Sir,
yeah, now you can move ahead. You can directly go to results and discussion. Yeah.
Yes, sir. Yes, sir. I'm using fly ash and quiet geotextile, and my methodology is about collecting materials and testing of the only soil and determination of optimum percentage of the fly ash soil mix and optimum placement of coir mat in that fly ash mix. And when come research procedure, what we did is we find limits, maximum dry density, and the test with 10%, 15%, 20%, and that to quarter to that, and half of that, and 3/4 of that. When CBR test, it gives about we will do in source conditions and we will original soil. So in the graph you can see that the clay and fly ash mix and The position of the geotextile mat from H5 4 and H5 2 from top has given the maximum strength in the CBR test. You know that CBR test is the one of the pavement and what type of pavement it should be. And my conclusion is that soaked CBR value is 7 times increased than that original one, and soaked is 5 times higher than that original clay. So with that, I will conclude my paper by saying that cities can be used significantly like sustainable. It may make sustainable too by using fly ash and the quiet geotextile. There are other materials which makes this environment friendly also. Thank you.
Okay. Thank you so much, Sriram. So although we could not get your audio, I mean your voice clearly, but then your slides are partially visible and it was on and off for some time. But well, anyways, it was a good attempt. In fact, thank you so much. So I would like to call upon paper ID number 126.
I'm very
Swaroop
sorry
and
for
team.
that, sir.
Yeah, no problem. Swaroop and team. So
yes, sir.
yeah, yes, Swaroop, you can share your screen. So we have Swaroop and team from GH Raisoni College of Engineering, Nagpur. So they are here to present comparative vulnerability analysis of structure with sand and soft soil. Well, anyways, you can go ahead. Thank you. Please proceed.
Thank you. Good afternoon. My title is Comparative Vulnerability Analysis of Structure. It's based on sand and soft soil. Okay. Introduction. Here in this paper done with comparative vulnerability study of two structure, which is built on two different soil type. The high risk of suffering earthquake of intensity MSK 11 or greater, I considered for zone 5. The MSK means microseismic intensity scale used to evaluate the severity of ground shaking on the base of observed effect in the area of earthquake occurrence. The pushover analysis is a nonlinear static analysis method for determining the capacity of building. Okay. While attending the pushover analysis, some information is essential such as material property, section property, mass source, response spectrum, diaphragm, gravity loading, define the push X and push Y load case as a nonlinear static type of earthquake loading, plastic hinge. Okay, and classification of vulnerability index is used to determine vulnerability of structure. These codes are used the stiffness of foundation is infinite, and stiffness of soil is something in corresponding value. Therefore, balancing the stiffness of soil and foundation, and to determine the vulnerability assessment between two different soil, we have to need modeling of soil. For that, very first, I assume the data of the structure which is symmetrical, sections and story height and all. And and assume as a as a fixed support, and analyze with 1.5 dead load plus live load combination. And this is a joint reactions, vertical reactions, uh, um, for modeling the soil. uh, for modeling the soil, uh, soil can model using the three dimension directional spring, x, y, and z, and the three radial springs, krx, kry, and kyz. For that, we need a dimension of foundation. So shape bearing capacity I referred from book of geotechnical engineering of C. Venkatramaya. Um, First I taken soft soil and joint J1, J4, J3, and J13. For soft soil, uh, I calculate area and dimensions of footing and moment of inertia. This given this is given values for calculate the stiffness of equivalent soil spring. This is a These are the values of stiffness for the joint as per their vertical reactions. And this for sand, for sand, um, and this is the value of stiffness of equivalent soil spring for sand. And then I define springs on support uh, in two different structure in two different structure. I analyze the model on ETAP software.
Yeah, Swarup, you have just another 2 minutes left. Please try to conclude.
Okay, sir. Result and discussion. These are the push x direction push over analysis graph for sand and soft soil. Here we can see the in soft soil model, displacement and base shear is increase is more than sand model. Here also push y curve here also push y curve in soft soil model, displacement and base shear is more than sand model. Then uh, these are the hinges at each performance stages of push or analysis. All these hinges are counted in this table. There is a seismic vulnerability index. There is a distribution of weighting factor uh, as per performance level. These are the counted performance stages, beam hinges of beam and column, and these are the vulnerability classification for RC building as per ACVI. As per this calculation, this formula, I calculate the seismic vulnerability index. So conclusion is soft soil structure falls under minor damage for a structural member by both push over X and Y direction, and sandy soil structure falls under very minor minor damage by push over X and minor damage by push over Y. Result showing soft soil structure more vulnerable than sandy soil structure. Vulnerability assessment depends on safe bearing capacity of soil, which I consider. Graphs of pushore also
Your time
showing
is up, Swaroop.
more displacement and shear base in soft soil structure. Okay, thank you.
Yeah, thank you so much. I request if any of the participants has any questions, you can post it in the chat box. And also you have been given with the feedback link, so you can kindly fill the feedback link also. So I would like to call upon, thank you so much, Swaroop and team. So I would like to call upon the next presenter, paper ID 162, Rachel Chavan and Nikhil Pitale, who is going to talk upon use of tuned liquid damper to control structural vibration. So Rachel Chauhan and Nikhil Pitale, any of you are here? Rachel Chauhan and Nikhil. Nikhil?
Hello.
Yes.
Yes, sir. I'm Rachel Chauhan and I'm ready.
Okay. You can please share your screen.
Yes, sir.
Yeah.
Sir, is this visible?
Yes. Yes, it is visible, ma'am. Please go ahead.
Yes, sir. Good afternoon to all. I'm Rachel Chauhan, PG student of GH Raisoni College of Engineering. My topic is use of tuned liquid damper to control the structural vibration. So now the introduction. Nowadays, the earthquake is very severe, as we know that it affects the taller building. So there are many devices available to overcome this. So one of the device called as a tuned liquid damper. It can reduce the effect of earthquake. So tuned liquid damper is simply a tank filled with the water situated at the top of the structure. It uses the slogging effect to dissipate the energy of earthquake and to reduce the structural vibration. So objectives are to study and analyze the effect of tuned liquid damper on the building using software ETABS. Second, to get the significant result, we show that tuned liquid damper is effective. Third, to reduce the dynamic response of the system using tuned liquid damper. Methodology I had studied the research paper, then modeling of structure using ETABS, then modeling of tuned liquid damper for the structure using ETABS, analysis, and then compare the result of building with the tuned liquid damper and without tuned liquid damper. So for the modeling of structure, I had used RCC building of G+5 story. Floor height is 3 meter, grade of concrete is M25, grade of steel is is FE 500. Beam size is 230 by 380 mm. Column size is 400 by 400 mm. Slab thickness is 125 mm. Live load is 2 kN per meter square. Flow finish is 1.5 kN per meter square. I use seismic zone 5, and according to that, importance factor is 1. Seismic zone factor is 0.36 and response reduction factor is 5. So this is the lump mass model for a rectangular tuned liquid damper where M0 is convective mass, M1 is impulsive mass, K is stiffness of spring, H0 is height where M0 is assigned, H is the height where M1 is assigned. So for that, these are the formulas through which we can get all the values so that we can assign it at the A tab. So this is the model of tuned liquid damper, and I use 6 cases for the time history analysis of building with TLD, and the results are of first case is this which shows the displacement of building without tuned liquid damper in x and y direction, and displacement of building with tuned liquid damper in x and y direction. It shows that there are some percentage of reduction. Similarly, for case 2, where the PGA is 1G, and I use the Assam data for case 2. I use the Bhuj data for case 3 of PGA 0.11G. For case 4, I use the Nepal data of PGA 0.23, and we can see there are some reduction in displacement. For case 5, I use Kashmir data of PGA 0.4G, and for case 6, I use Bangladesh data of PGA 0.3G. So now the conclusion is, through all the result, we can conclude that the tuned liquid damper is effective to control the structural vibration, and through the research paper and the references, we can conclude that the tuned liquid damper is economic, and it requires minimum maintenance, and hence it can be easily handled. So these are the references, and thank you.
Okay. Thank you so much, Rachel and team. So I must say you have completed well within the time, and remarkable observations and results you have made. But well, anyways, thank you so much. So
thank you.
So we have our. I would like to call upon the next presenter, paper ID 5. So I have also called him several times. So if you are there, please respond. Otherwise, we can conclude with the session. So Excel Money, paper ID number 5. So well, I would like to give the concluding remarks for the session. So to begin with, we have started with the keynote presentation by Dr. Naveen James, who has spoken on seismic zonation of regions at different scale, followed by Dr. Sival Sakotliar, who has spoken on geotechnical engineering for disaster risk management. And then we have consecutive subsequent presentations. Okay, so starting with Swaroop. So Swaroop and team, they have presented on comparative vulnerability analysis of structure with sand and soft soil, followed by Sriram Karthik and team, who has presented on strengthening of subgrade clay soil in road construction using fly ash and coir geotextile mat. And followed by Nirav Kumar Umaria team. So they have presented on comparative study of existing cement fly ash gravel pile and encasing stone column composite foundation. Followed by paper ID 162. So Rachel Chauhan and Nikhil Pitale, who has presented on use of tuned liquid damper to control structural vibration. So this is all from the session GT1. So I would like to request you to stay back for another 15 minutes so that we can start with the session GT2. So GT2 we have session coordinators Dr. K. Nagchaitanya sir and Mr. K. Hemant Raja sir. So they will be there, and we also have paper presentations as well as keynote presentations. So stay tuned until then. So thank you so much.
Thank you, sir.
I request all the participants.
Sir,
just
can
fill
you
the Google form.
Yeah, sir. Yeah. Sandeep sir, please make Nag Chaitanya sir host and Hemant Raja sir co-host.
Yeah, sure, sir. The participants, just fill the Google form. If you already filled, just ignore. Chaitanya sir, can you raise your hand? Sir, did you join with mobile, Chaitanya sir? Chaitanya sir, I made you the host, and I'm leaving.
Thank you so much, Sandeep sir. Thanks for your kind cooperation. Thanks a lot.
Thank you. I have not seen. I am in mute mode. Thank you. Thank you.
Nag Chaitanya sir, I think Professor Ari is already there in the session. He was there from the beginning. In fact, I think so.
Yes, sir. Yes, sir. Professor Harry. Harry, sir, are you there? Professor Harry, sir, are you there? Can you hear me?
Sir? Dear participants, the session will be starting very soon, within 5 minutes. Please stay tuned. Good afternoon, Ari sir.
Hi.
Hi, sir.
Hello. Yes. Can you hear me?
Yes, sir. It's very nice to see you, sir. Yes, sir. We can clearly hear you. Can you hear us?
Yeah. Yes. It's very clear.
Yes, sir. We are going to start within 1 minute, sir. I will start the proceedings, and I have already given the presenter status to you. Once you are invited, I think you okay to present, sir. I think there is an option for you to share your presentation. Already visible.
Okay. I will try to share my screen.
Okay. Once you try to share, sir. Let us share once.
Yeah. Hang on. I have a PowerPoint presentation here.
Yes, sir.
But I'm not sure how to share my screen. But this is my first time using the Webex. Yeah, we are usually using the Zoom, and I should click share. Yeah.
Yeah. Share, sir.
Shares, yes. And then
And
can
it
I
will show you different. It will show you different windows that you can share that are open, out of which you select your PPT.
Yeah. Okay.
Yeah. If your PPT is open, it will show to share the PPT.
Yeah. But I can see my PowerPoint presentation in my layer. I only can see only my layers. Yes, but I cannot see the PowerPoint presentations in my layer. Should I send my PowerPoint to your WhatsApp?
Okay, sir. If you want us to, we can share. There is no issue. You just change the slide and we can share.
Sir, but I feel better if we can operate, that will be good, sir. Otherwise, there will be some confusion between you and us.
If sir, if you can share, that will be very good, sir. Otherwise,
Yes, I send my presentation to you. Yeah,
yes,
it's
sir.
already sent. Yeah, okay. It's ongoing now. Yeah, it's come to you.
Yes, sir. Yeah, I have received.
Okay.
Okay. After delay, I will start the session, sir.
All right.
Good afternoon to all. Welcome to the third International Conference on Advances in Civil Engineering that is being conducted in the Department of Civil Engineering, held in Andhra Pradesh. This is session number 2 in track number 3, that is track that is dedicated to geotechnical and transportation engineering. We have completed one session in the morning successfully, and this is session number 2 in geotechnical and transportation engineering. For this session, we have two eminent people as our chair and co-chair, and we will be having 2 keynote sessions given by prominent people in the field of geotechnical and transportation engineering. So let me introduce our chair for this session is Dr. Amarendra Kumar Sandra. He is an associate professor in RGUKT, and he did his from NIT Warangal, and he did his MTech from IIT Kharagpur, and he completed his PhD in BITS Pilani, and he is currently working as assistant Valley, Karama, and he had completed more than 55 consultancy projects in the area of payment evaluation and design, and payment material characterization, and design of airside elements in the airport, and traffic analysis, and pre-bid engineering, etc. And he got Dr. Shankar Dayal Sharma Gold Medal and DAD Fellowship for being best all-rounder in MTech at IIT Kharagpur. And Dr. has published 11 papers in reputed journals, and he has published 11 papers in peer-reviewed conferences also. And till now, he has guided 45 MTech students and 1 PhD student. He will be acting as our chair for today's session. And our co-chair for today's session is Dr. Krishna Gadam. He is an assistant professor in NRTI Vadodara. I welcome you, sir. Dr. Harkrishna Gaddam did his BTech from IIT Anantapur, and he has completed his MTech from NIT Warangal, and he has done his PhD from IIT Delhi, and he is currently working as an assistant professor in civil engineering department at NRTI Vadodara, and his research interests include our mathematical modeling of traffic flow, round out capacity analysis, calibration and validation and of simulation parameters, and pedestrian emergency evacuation studies, etc. And he has been acting as reviewer for 3 reputed journals also, and Dr. Harikrishna Gaddam has still now published 11 papers in reputed journals and 10 papers in reputed peer-reviewed conferences also, and he has been awarded fellowships and grants by Department of Science and Technology and Ministry of Urban Development, Government of India. I welcome you, sir, for the session. Now I request our respected chair to take over and introduce our keynote, first keynote speaker of the day.
Yeah,
sir?
thank you, sir. Yeah, thank you. Thank you. Thank you for me. And
thank you, sir.
Thanks to the organizers and management for selecting me as chair for this session. Keynote speaker, Dr. Ari Setovan. So he He is a civil engineer with nearly 30 years of professional experience in education and research involving highway materials, infrastructure, environment, maintenance, and policy regarding road management. He earned his bachelor degree in civil engineering from Sebelal Maret University, SMU, Indonesia, in 1991. In 1998, earned his master's degree from Institute of Transport Studies, Leeds University, UK. In 2003, he got a degree from Leeds University, UK. So he is now an associate professor and head of civil engineering postgraduate program, SMU, Indonesia. He supervised 7 PhD students and more than 100 PG by UG students from Indonesia and abroad. He has published many articles in reputed journals and proceedings. So Sar is going to deliver very interesting topic, lecture on very interesting topic. That is the viscoelastic mechanistic approach of designing the flexible pavement layer. So I request Sar to take over the session. Dr. Adi.
Yeah, okay. Thank you very much.
1 minute, sir. I will be sharing your PPT.
Yeah.
Yes, sir, we can
please,
hear.
Yes, please. Yeah, Dr. Naga, would you like to share my PPT, please?
Yes, sir. Yes, sir. I'm on the process. I'm just opening it.
Okay.
Yes, sir. I'm just opening your PPT, sir. 1 minute.
Yeah. Okay, while waiting Dr. Naga to help me to share my one presentation, I'm sorry, a little bit technical error in my computer. Yeah, I would like to, to send my gratitude to Dr. Amiranda as the chief of this evening session, as well as Dr. Hari Krishna and also Dr. Naga is a very friendly host for this evening session. Also, the professor and as well as the students, I have seen all the some of the presentations in today's conference, and it looks like a very interesting topic for students as well for another keynote speaker. The student is very well doing their work and research, so it's very interesting. Okay.
Are sir, can you see the screen, sir?
Yeah, it is ready now. Thank you very much.
Yes, sir. Yes, sir.
Yeah.
Just give me an instruction to change the slide. I will be changing the slides.
Okay. Thank you very much, Dr. Naga. Okay. Good afternoon, everyone. It is my pleasure to be here. It is an honor for me as well to be invited in the third conference on advanced in civil engineering. Maybe it is the first time I visit India. Unfortunately, I cannot go directly to India, but only from this online. Yeah. Okay. In this case, I just want to share the idea. Maybe it will be interested for the students to search in this area, because as I see some of student research, I haven't seen the research in asphalt or bitumen. Maybe I slightly changed the title. I use the title of mechanistic approach based on elastic and viscoelastic assumption for flexible pavement. Actually, this is the topic of my PhD students, Dr. Sanjarum Harnaini from other university in my hometown. Next, please. Yes, and maybe it's become clear for my presentation. I would like to give the presentation first of all the introductions, and then a little bit background why we did this experiments or research, and then what is the objective, and then slightly the method, because I cannot present all detail of the method, and then result and discussion, and finally the conclusions. Next, please. Yes. Since 2013, maybe 7 years ago, Indonesia has changed the flexible pavement design method from the empirical method into mechanistic method. Yeah. And in this case, the elastic assumption used in this mechanistic design of flexible pavement is the fact that the asphalt mixture is a viscoelastic materials based on the some reference as well as the theoretical that asphalt or bitumen, it is a viscoelastic material. So in this case, we think that it is need to evaluate if the elastic assumption is appropriate for flexible layer pavement and as well as the asphalt mixture. Next, please. This one is that asphalt is a viscoelastic material. This based on the handbook as well as the research that conducted by some researcher as well. And of course, there are a weakness of elastic layer theory on asphalt because asphalt is not really elastic. Sometimes it depends on the temperature as well as the time of loading. Consider the asphalt mixture is an elastic material is a significant simplification actually. And the further research we have like make a proof that actually we need the more thick of our asphalt if we use the viscoelastic assumption. So in mechanistic analysis, it is important to include the viscoelastic properties of asphalt mixture to improve the accuracy of the design based on the some reference as well. Next, please. Yeah. And the research objectives we divided into three. First, we like to analyze the response of the flexible pavement structure if the asphalt mixture are assumed to be an elastic. And then we like to compare with the result of the analysis that the response of the flexible pavement structure is considered that the surface layer are viscoelastic and the supporting layer below are elastic. And the third one, we also analyze the response of asphalt mixture specimens. It's only the specimens, not the layers. Yeah, it's only the specimen used as a surface layer of flexible pavement structure in Indonesia, which is usually asphalt concrete and hot roll sheet. If its behavior assumed to have the following properties: elastic or viscoelastic. So generally, we have three objectives in this paper. So the research method. The first, we use the two types of asphalt. It is asphalt concrete, which is a continuous gradation, and the hot roll sheet. In UK, we call this hot roll asphalt, but in Indonesia, we use the name of hot roll sheet. Actually, quite similar in the gradation, which is the gap gradations. And then the second one, we produce the specimens for Marshall. It is a very traditional approach, yeah, using the Marshall test, as well as the dynamic modulus testing. And the third one, we use the pavement temperature in Indonesia, which reaches 60 degrees Celsius. It means that if we use the elastic, maybe the asphalt is already collapsed at 60 degrees Celsius. And as well as the temperature variation in Indonesia is come from 17 degrees Celsius up to 60 degrees Celsius. But on the limitations of the equipment, we use up to 45 degrees Celsius. Next, please. And we also have determined the elastic and viscoelastic behavior of asphalt mixture using finite element simulations based on our dynamic modulus testing in the laboratory. The finite simulation were carried out in two reviews, namely first is for the flexible pavement structure. So we try to make a model from the first layer, second layer, and so on up to the subgrade. And the second, we use only the asphalt itself, the asphalt mixture itself. Yeah, it means that only the specimens. So the first is the model from the layer by layer of the flexible pavement on the fields, and the second, we only measure the asphalt specimen. Next, please. Yeah, and the last, we try to evaluate the elastic and viscoelastic properties of asphalt mixture in the finite element simulation. The factor under the consideration is the effect of loading time. So in this case, we use 40 kilometer per hour, as well as the effect of the temperature. Yeah, next please. Okay, first we do the laboratory work. We make the asphalt mixture designs. This just with illustration, the delimitations, yeah, of our surface road, yeah, the delimitations, as well as this is like a very heavy good vehicle as well. It's still the problem in Indonesia with the heavy good vehicles and overloading as well as the over dimension. Yeah. Okay, next please. Yeah, this is the two types of asphalt mixture. We use asphalt concrete and hot roll asphalt. As I mentioned before, the difference between asphalt concrete and hot roll asphalt is about the gradations. In asphalt concrete, we use continuous gradations, and hot roll asphalt or hot roll sheet, we use cap gradations. And in this research as well, we find that actually with the climate, the temperature like in Indonesia, and as well as the problem of the overloading or heavy load in our traffic, it looks like that asphalt concrete is better than the hot roll sheet. Next, please. Yeah, this is just the descriptions of the result from the Marshall properties. The Marshall speed stability is quite high, but asphalt concrete has the higher Marshall stability than the hot roll sheet, as well as the flow, and then the Marshall quotients. And the air voids, this is quite a problem as well. Within the laboratory, we are quite difficult, yeah, to find that the porosity on the void in the mix. In Indonesia, the standard is about 3 to 6%. Below 3%, the problem more than 6%. There's a problem with the ingress of water into our asphalt pavement. The void in mineral aggregates is quite good, as well, and the void filled with asphalt, and the density is fulfilled the standard. Next, please. And then the second one we test in our laboratory is the modulus dynamic test. So this is a bit illustration of very bad pavements, yeah, with a lot of water like this, and it crack happen everywhere, as well as the crack will propagate into the pothole like this. It happened in many district roads in Indonesia. Yes, next please. The procedure of the dynamic test. We use the asphalt mixer performance tester, or AMPT. It refers to the ASTO designation PP61 13 the year 2015. We follow the procedure in there, and we make the variations from 15 degree to 45 degrees Celsius, and the loading time, we represent the loading time by the frequency of the load. It is from 10 hertz into 0.01 hertz. Represents the slow and the fast moving of the vehicles. And the test objective is a cylinder with a diameter of 100 millimeter and height of 150 millimeters. And the test is carried out from the lowest temperature to the high temperature, and from the highest frequency to the low frequency. So in this dynamic modulus test was carried out with 3 test samples for each asphalt mixture, 3 from asphalt concrete and 3 from hot roll sheet. Next, please. Yes, this is the picture when we did the test for dynamic modulus dynamic test. We will find the stress and the strain diagram from this test. Next, please. Yes, and this is the effect of the temperature and frequency. It means that the time of loading and the temperature on our specimen or our samples. Actually, it gives the different dynamic modulus. It depends on the frequency or time of loading and as well as the temperature. This is, I think this is for asphalt concrete. Yes, next please. And it happened as well for the hot roll sheet. Quite similar on the trend. Yeah, it really depends on the time of loading and the temperature. It's not only a single time of loading or a single temperature. So this is actually that one that we want to know what happened if the temperature change, like what happened in the real life in the field. Yeah, not only in the chamber that we test in our laboratory. Yes, next please. Next, Dr. Naga. Yeah, and then from the result, we create a master curve for dynamic modulus. So the dynamic master curve is a curve used to calculate the effect of temperature and loading time. With the availability of the master curve, it will be possible to calculate the value of the dynamics modulus at the desired loading frequency and the temperature. And also the master curve at the reference temperature was made to take into account the effect of temperature and rate of loading on the viscoelastic properties of the asphalt mixture. So the master curve is made based on the value of dynamic modulus, which is determined from dynamic modulus testing on asphalt mixture specimen, which is carried out at several different temperature and loading frequency on the time of loading. And we create the master curve like this slide. This is the master curve for asphalt concrete. Yeah, and the next is the master curve for next please. Yeah, for hot roll sheet. Yeah, it looks like from this, if we put together this graph, it looks that the asphalt concrete have the highest dynamic modulus rather than the hot roll sheets. It's because the asphalt concrete have the continuous gradation with there are interlocks between aggregates. Meanwhile, the hot roll sheet, we have a lot of fine aggregates with a few of the coarse aggregate. So we call this gap gradation. And we use a lot of more asphalt content or optimum bitumen content. Usually looks like 8%, but in asphalt concrete, maybe just 6%. So at least from this master curve, we can see that the use of bitumen asphalt means that our sample or our asphalt mixture, it looks like have the lower dynamic modulus, but on the other hand, it become more resistant to crack. Yeah, but this is will suffer from the deflection. Next, please. Okay, and we come into our simulations with using the finite element method for flexible pavement layer. And then the second, the simulation for the specimen. So this is the simulation of pavement and specimen. The simulation were carried out on flexible pavement of asphalt mixture, specimen of asphalt concrete and hot roll sheet, as I mentioned, with the elastic and viscoelastic review. So we use both elastic and viscoelastic assumptions for these two types of asphalt mixture. The objective from the simulation, we are going to review the difference in the response of flexible pavement. In this case is the horizontal tensile strain, vertical compressive strain, vertical stress, and the deflection. When we load the vehicle wheels, assuming elastic and viscoelastic using the Abacus software tool. Yeah, next. Yeah, this is just show you the software that we are going to use to make these simulations. Next. Yeah. So this is the model for pavement layer. We have the two model actually. In this case, the flexible pavement model or the design, we use like the design of the flexible pavement layer. This is based on the very new pavement design manual published by the Minister of Public Works in Indonesia. We have the model have 3 meters, 5 meters in the 3.5 meters in the direction of traffic, and 3.5 meters in the transfer direction, which represent one lane of our route in Indonesia. We usually one lane we have 3.5 meters. And then the depth of the model is 3 meters, which consists of the surface layer, which is hot roll sheet or asphalt concrete, and then top foundation layer, and then subbase layer and subgrade with the characteristic of the flexible pavement presented in the next table. The subgrade below the layers on the bottom of the model is assumed not to allow the movement in the vertical or horizontal direction. So we use the subgrade and the depth of 2,335 millimeter below the subgrade. It is considered already achieved the hard layer of the subgrade. And it assumes that one layer to another is bound together. This is for the model. This model is idealized with C3DR8 mesh. It means that three-dimensional cube element with 8 nodes in the loading area as well as the part of the flexible pavement structure. Next, please. Yeah, this is the properties of the pavement layer for asphalt concrete and hot roll sheet. Yeah, we take this from the manual. Next, please. And the loading arrangement, the loading of the flexible pavement model refers to the pavement design manual. There are the standard as well. The loading on the flexible pavement is in the form of a standard load with a single axle double wheels. Yeah, the standard load single axle double wheels with the 8.16 tons or 80 kilonewton. The wheel load of 20 kilonewton with tire pressure of 750 kilopascal is fully distributed in the vehicle contact area. The loading on the asphalt concrete and hot roll sheet asphalt mixture specimen mode is in accordance with the load applied to the specimen used for dynamic modulus testing using the asphalt mixture performance tester. Yeah, next please. Okay, and this is the model for the pavement layer. This is the model of the pavement layer. Yeah, and then this is the configurations of the load application. Of course, this is we only use one configuration. Of course, there are many configurations because we have like single layer, single axle. This is single axle, single wheel. This is single axle, double wheel. This is the standard one, yeah. And then we also have the double axle, double wheel, and as well as the triple axle, double wheel. So we only use this standard. So it means that we still have another research topic to make different configuration of the load. Nice, please, Dr. Naga. Yes, this is the second model. We use only the specimens. Yeah, this is for asphalt concrete and hot roll sheet. Yeah, next, please. And this is the simulation of the traffic load movement. Yeah, we use Haversine function in Abacus. This is from the Abacus model. Yeah, we use this time, amplitude, and time, which is different from the asphalt layer and the specimen, because in the specimen we is quite similar with what happened in the dynamic modulus test. Yeah, next please. Yeah, and this is the correlations between the stress, strain, and deflection against the time. So from this we will make the note, yeah, the results, and we are going to put this into the graph to show what happened with the difference between viscoelastic and elastic assumptions on our asphalt layer and specimen. Next, please. Okay, this is what the vertical stress and time happen. Yeah, the vertical stress is it happened on the top of the subgrid, yeah, of the bottom of the asphalt mixer. We have time and the vertical stress. Hang on, yeah. Yes, we have in this we have asphalt concrete at the viscoelastic assumptions and asphalt concrete at the elastic assumption. We can see in this blue, the blue color and the green color. Yeah, sorry, and the green color. Yeah, it seems that at viscoelastic assumptions, the stress greater than in elastic assumption for the similar layer. Yeah, it also happened for the hot roll sheet. Yeah, yeah, okay. Thank you, Dr. Naga. Next, please. Yeah, this is the vertical compressive strain and time. Yeah, okay. The compressive strain and time. We also can see that the viscoelastic and elastic, yeah, for the similar hot roll sheets, in this case, yeah, the viscoelastic have the greater strain compared to the elastic one. Similar for HRS and for asphalt concrete layer. Next, please. Yeah, it is the vertical deflections. Yeah, vertical deflection. It happened at the bottom of the bounded layer. Yeah, it means at the top of the subgrid. Yeah, it can be seen here for the viscoelastic assumption and elastic assumption, both for asphalt concrete. Yeah, it's quite different. So in the elastic give more deflections than the elastic one, as well as the hot roll sheet. Okay, next please. Okay, back one slide. Okay, this is the yes, this is the horizontal tensile strain and the time. Yeah, quite similar. It means for the average, yeah, the viscoelastic give the greater results compared to the elastic one. This is the elastic and this is the viscoelastic. For the horizontal tensile strain, it happened at the bottom of the bituminous layer, on the asphalt layer. Yeah, next please. Yeah, just to give some discussion, yeah. In this case, that the result of the elastic and viscoelastic finite element simulation on flexible pavement using the assumption that vehicle traffic runs at a speed of 40 km per hour and a pavement temperature of 25 degrees Celsius. This analysis carried out include the horizontal tensile strength at the bottom of the asphalt layer, the vertical compressive strain above the subgrid, yeah, and hang on, and the vertical stress above the subgrid and the flexion above the pavement surfaces. This finite element simulation results shown that the response of the flexible pavement between the elastic and viscoelastic assumption is different. The response on the assumption of viscoelastic properties greater than the elastic one. The response of flexible pavement using hot roll sheet asphalt mixer is greater than asphalt concrete, both of the assumption of elastic and viscoelastic material. So it means at the specified temperature and loading time, the performance of asphalt concrete is better than the hot roll sheet. Next, please. Okay, this is what happened with the strain of the specimen. Let's see quite detail in this graph. Yeah, this is strain and this is time. The red line, this is the viscoelastic of asphalt concrete wearing force. And then the purple line, this is the viscoelastic of hot roll sheet wearing force. when we compare this with the result of the test specimen by the dynamic modulus test, this blue line at the very top, yeah, it is the hot roll sheet, yeah, and then the black line, yeah, the black line, this is the asphalt concrete, yeah. This is from the dynamic modulus. So from this case, we can see that actually what happened with the actual test, the physical test by the dynamic modulus test, with quite similar with the result of the viscoelastic assumption, viscoelastic model. Yeah. Meanwhile, this at the bottom, this one is the elastic. Is not quite difference with by the time. Yeah. Okay. Next, please. Yeah. So the finite element simulation of asphalt mixture specimen is carried out for verification or validation of the measure pavement response to the field to ensure that the application and accurate. Yeah. The analysis carried out is to compare the strain obtained from the finite element simulation of the specimen with the strain that occurs when the specimen is tested in the laboratory by dynamic modulus test. Based on the simulation using the finite element method on asphalt concrete and hot roll sheet, asphalt mixture specimen, it can be concluded that the finite element simulation result are closer to the laboratory test specimen assuming viscoelastic rather than elastic properties. And the viscoelastic finite element model is superior to elastic. So this is like, yeah, this is like, maybe we can say that this is limited on this research. The viscoelastic is more represents what happened in the field. Next, please. Yeah, we come to the conclusion. Of course, this conclusion is based on our experiments. So the behavior of the flexible pavement structure consisting of the surface layer and the layer below it, assuming the asphalt mixture on the elastic surface layer is different from the viscoelastic. Thus, the assumption of elastic properties used in the design of mechanistic flexible pavement in Indonesia is not really appropriate. But we need, of course, we need to make approval, yeah, from the different researcher or the different method of the research. And the response of flexible pavement, namely the horizontal tensile strain, vertical compressive strain, assuming that the asphalt mixture is viscoelastic, are greater than the assumption that the asphalt mixture is elastic. The response of flexible pavement for horizontal strain and vertical compressive strain for hot roll sheet is greater than asphalt concrete, asphalt mixture, yeah, assuming that the asphalt mixture is viscoelastic or elastic. So in both assumption, viscoelastic or elastic, asphalt concrete is give the better performance than the hot roll sheet. Yeah. Next, please. So, based on the finite element simulation on the asphalt mixture specimen with the elastic and viscoelastic properties, it can be concluded that the value of strain on the assumption of viscoelastic is closer to the strain of laboratory test specimen than the elastic properties. Okay, I think that's all the idea of which one is better between elastic and viscoelastic assumption. So thank you very much. To the last slide. Yes, thank you very much. Just to show you, this is our university in Solo City. Thank you very much. Another discussion, very welcome. Thank you very much.
Thank you, sir.
Ramarendra, sir.
Yeah. Thank you, sir. Thank you, Dr. Ari.
Thank you very much, sir. Thanks, sir.
Thank you for your wonderful presentation. So, before giving my comments, I request participants if you have please pose your question to Dr. Ari. Please unmute and please ask queries if you have any.
Yeah, I need some suggestion maybe, or maybe we could have collaboration in research. So I can fly to India.
I think nobody is having any doubts, sir. Even in the chat box also, there are no questions that have been asked.
Any questions? You can just check it, sir.
Yes, Viveka is saying it is very informative session. That is the comment that we have got.
Sir,
Yeah, can you say something?
Yes, sir.
Hello?
Hello, yes.
Dr. Raugar, sir.
Yeah, I just want to make a small comment on Prosari's presentation. I think it's a wonderful presentation. Really, he has modeled both the sample and the 3 meter wide and 3.5 meter length pavement, both numerical and otherwise now. And in fact, I can assure him that this kind of studies are not being done in the country. I think I appreciate the work which is done and the background for this now. I am sure that in course of time, we're able to do other mixes also, because your AC is something like our BC. That means your AC is like our bituminous concrete. And the second layer we are thinking of is somewhat like our what we call as a dense bituminous macadam. Somewhat similar to that actually, because we have our Indian terminology for that. Now, instead of asphalt, we use the bitumen kind of nomenclature. But I really enjoyed listening to you completely. You have been very patiently telling us what we have done now. Actually, I'm happy, more than happy, because of the thing that this gives me background for what the presentation I am going to make in terms of geosynthetics now. Because unless we have the bituminous place modulus actually, it's not possible for us to really design effectively either the normal payment or the payment of geosynthetics now actually. And I can also tell you that as of now, we are only essentially following the what you call the specification of Astro only. We have not made our own measurements as of now. So that way, it is very interesting for me. Though I am not a man of bituminous materials, but I can tell you that it is a wonderful presentation made, and it is very useful to all of us in India. Thank you very much.
Yeah.
Thank you, Dr. Raugar, for your.
Dr. Harikrishna, sir, can you make any comment?
Yes, sir. Professor Ari, it's a great presentation, sir, on this particular topic, especially difference between viscoelastic and elastic differences. So you have highlighted many points like why should we consider the viscoelastic properties in design of asphalt concretes and other types of design, like and also temperature susceptibility is issue, and you consider all the parameters correctly, like loading, temperature, and the speed. So and also you highlighted the importance of dynamic modulus test. So there also it's new for me. So it like I learned a lot from this particular presentation. And I have few questions related to this, like how accurate the abacus that you used based on the continuum mechanics. So the finite, you have done any parameter evaluation in the case of abacus before implementing that for payment modeling?
Okay. So I just answered the question.
Yes, sir. Yes, sir.
All right. Yes. Okay. Thank you very much for your comment. Yes. Actually, we are in the highway laboratory, especially in the asphalt. Sometimes we just like so we need something new. I mean, this time now we come to the mechanistic approach. Meanwhile, our own laboratory in the asphalt laboratory sometimes is we call this a very conventional one. We cannot take the measurement very accurate because this is like a physical laboratory. Sometimes in the university, the laboratory is quite old as well. The equipment is quite old, so we try to make cooperations with someone who will be able to make a model. Maybe within the model is more accurate than measuring in the test laboratory. So I'm not the expert in the abacus because I asked someone else to do abacus for me. So, but I trust the result. I mean, it's based on some experiment as well, some reference as well. That abacus is quite accurate, because this is like mathematical model. So I haven't make any validation of the abacus compared to the specimens test in the laboratory, but limited by the test that we carried out, looks like that from the abacus and the laboratory is quite similar, the result. This is from the dynamic test modulus and the simulation from the abacus. But the abacus itself, of course, because this is like the software, of course, they already have the standard of the accuracy. Yeah, thank you very much.
Yeah, if you have like time permits, I have two more questions, sir. Like, do we have really sufficient data in the case of hot rolled asphalt, because you have not achieved the S curve in one case. One case you achieved the S curve, another one you have not achieved. So, do you have sufficient data? Like, what is the issue in that case? Why didn't you achieve the S curve in the hot rolled asphalt scenario?
All right. Yes. Yeah. It's quite difference, yeah, between the test that we conducted in laboratory, because we have limited data, of course. We just only is like the 3 sample for each the test, yeah. But we call this not the sample actually, but the specimen. So we only based on very limited specimen, yeah. Of course, we need, as I said before, we need more specimen. We need more data, yeah, to make our conclusion is true. Yeah, I think this is kind of the first idea that we can find that there are differences between that viscoelastic and elastic. At least from this point, we will start to do another research to make more approval.
Okay, thank you.
That is my answer.
Yeah, some cases this AC and the HRA both are performing same in terms of stress strain curves, and also in the case of deflection. What is your comment on it?
Can you repeat your question, please?
So both this asphaltic concrete and hot rolled asphalt, the stress strain curves as well as the deflection curves are performing same, means showing the same results. So what is your comment on that? Under loading condition temperature, yeah.
Okay, yeah. I think it's the hot roll sheets suffer more than the asphalt concrete. The usual result is like that. Yeah, because something the ingredients in our asphalt mixture that suspects to temperature is the asphalt itself. Yeah, the aggregate is not really suffer from the change of the temperature. I think it's theoretically said that the hot roll asphalt, we use more bitumen, so that's why hot roll asphalt or hot roll sheet is more suffer against the temperature thing.
Okay.
I think that's as far as I know. Yeah.
Okay,
sir. Okay. Thank you so much for your patience.
Yeah.
Thanks.
Yeah.
Okay.
Sir, one more question, sir. Actually, we use a constant temperature of 35 degrees for estimating the dynamic modulus, and modulus we use in the pavement design. What about you, sir? There, you use the constant temperature or you vary the temperatures?
Yeah. So limited in this research, we only use the 25 degree. Yeah, for the modeling, because this is actually the limited of our simulation in abacus. Yeah, because it takes very long. Yeah, very long time. Only for one measurement. But we already tried to do the using the fatigue analysis. Yeah, but we haven't analyzed the results. So by using the fatigue test, using the material testing apparatus, maybe it will give more illustrations about what is the temperature change which significantly change the properties of our material. Yes, we still limited from the abacus, but we already done the fatigue test, indirect tensile fatigue test at different temperature. Because in abacus, if we change the temperature, it will take very long time, as well as of course the because of a limited of our budget as well, because it's quite a lot of money. We have to ask someone to do this research on this simulation and abacus for us. Yeah, I'm sorry for that. Yeah, but that is we realize that is our limitation. So that's why we still do this research.
Okay. Yeah. Okay, sir. Thank you, sir.
Okay.
Yeah.
Yeah. Thank you very much.
Yeah. Thank So let me give the final comments. Terry, for your presentation, explore payment design using viscoelastic mechanistic approach. So Dr. Hari started his presentation with a detailed explanation on various tests to be conducted to find the input parameters, which is very much required. Actually, many of us also were missing this point. So directly we are taking the modulus value. Suppose VG party bitumen, you take the modulus value is 3000. It's not okay. How to VG party bitumens are there, their modulus values are different. So SAR explaining it, and also the frequency of test, all those things I have explained in detail. And Dr. Hari presented how the finite element method was developed to find the stresses at critical equations, mainly horizontal tangents in the bottom of the bituminous layers, as well as the compressed strain on the subgrade, and what are the various parameters that they have considered. And finally, he has concluded that viscoelastic approach gives the results. So thank you, sir. Thank you again for your wonderful presentation. And that's all, sir. Yeah. Thank you, sir. Dr.
Thank you. Thank you. Thank you very much.
Yeah, thank you, Dr. Hari sir. Now I request our chair, Amrendra sir, to introduce our second keynote speaker.
Sir, now, see, so dear participants and other guests in the session, so I take this privilege to introduce Professor G.V. Rao. Professor G.V. Rao obtained his B in Civil Engineering from BIT Pilani in 1966. After completing his master's in 1968, he had a distinguished career of over 3 decades, 1975 to 2000, at the Indian Institute of Technology, Delhi, serving as professor and head department, dean students with other capacities. He guided and over 100 MTech theses while authoring over 30 papers, many of which have won awards for best thesis and best papers internationally. He developed and created the very first statistics laboratory first master's program in transportation. So he was the president of the and national consultant to project government of and the Japanese high-speed train project from Sabarmati to Mumbai. Since January 2006, he is associated with IIT Gandhinagar as a guest professor. Currently acting as chairman, GITAS and LRL. Sir, Dr. G.V. Rao today is going to deliver a presentation on application of geosynthetics in pavement engineering. Dr. G.V. Rao to take over the session. Sir.
Professor G.V. sir, I have given you the presenter status, sir. Can you please check whether you are able to share the content?
Yeah, just a second. Just a second.
Yes.
అక్కడ కనెక్షన్ సరిగా లేదు. ఎక్కడ చేయాలి? ఇక్కడ చేయమన్నారు కదా.
Yeah, open your PPT, sir. Automatically it will open. Sir.
Okay.
Screen presented.
First you open your PPT, then afterwards you share the contents.
మీకు షేర్ పెట్టాలప్పుడు ఏమో ఆల్రెడీ
Stop sharing చూస్తాను. Your screen present. You just have to open it.
Yeah, is my screen visible? Hello?
Sir, not
Hello?
yet, sir.
No, sir, no.
No, sir.
No, sir. It is showing
Sure.
that you have shared something, but
Sir,
Yeah.
you
black
just
screen is with, sir.
you are sharing your screen, sir. Just repeat it, sir.
Mm.
Yes, sir. Yes, sir. Now your screen is being shared.
Being shared.
Screen share. Yeah.
No, screen is shared, but not the presentation.
Yeah.
Okay.
Yes,
Yeah,
sir. Now you can open your presentation.
Sir, open your presentation, sir.
Yeah, presentation is open now.
Sir, in the top, you can see the
Yeah,
share
it
button,
says you
sir.
are sharing. Again, top you have to share.
Beside the pass button, yeah, share. Share content, sir.
Yeah, share content. Yeah, I think that's.
This one?
Sir, then here you select your presentation, sir.
Yeah. Okay.
Is it the one? Yes, something. Share no problem. Yeah, that's being shared.
Okay.
Yes, sir. Now it is
Okay,
visible,
now?
sir.
Yes, sir. We
Okay.
can see your
Okay, sir.
presentation.
Sorry.
Thank you, sir. Thank you.
I have to
Yes,
change my
thank
venue because there the network is not proper. So I thought I will change my venue in the house only. At the outset, I'm very grateful to the organizers, that is the KLU, Professor Hanmant Rao and his colleagues, for giving me the opportunity to share some of the thoughts which we developed over, I should say, many years. And the topic, of course, is geosynthetics in highway pavements. As you know, several things are happening in the country. One of them, of course, is one second. Sir. Ananya?
The slide shall change even after clicking on it, sir. Clicking on the slide will automatically change the slide.
Clicking on the slide.
Clicking on the chain. Okay. Okay. Okay, go ahead. So we know we have moved from this kind of roads, wherein particularly in our country it was good old practice to have roads directly only on soils and maybe some aggregate. And even the latest vehicles in the early days was causing this kind of rutting. Same thing used to happen also when we were using the bullock carts. So this was a major problem now. And from there on, years ago, we moved to the tracked vehicles, wherein we are distributing the load or wide area. Still, the same kind of behavior was there. And from this point onwards, actually, in the good old days, but in hilly areas, people started using maybe even tree trunks actually put across the road, connected together by either chain or you can say ropes, and then over that some it is being spread now. So this was behaving like an interface between the vehicles and of course the soft also grade. I should say that was the beginning of what we call as corduroy roads because they were kind of uneven, something like our corduroy jeans actually, and yet they were able to carry the traffic for a limited number of repetitions. That was the main issue which was there in the context of geosynthetics particularly. The one thing which we of course know clearly is that when you talk of payments, all of us know very well that it's a process of developing the most economical combination of payment layers in relation to both thickness and type of materials to suit the soil foundation and the cumulative traffic to be carried during the design life. Now, what is important for us is that we were always thinking of the most economical combination of payment layers. Yes, we know what are the different layers, which we'll see them again, once again for refreshing up. But nevertheless, now, what is becoming more, I should say, complex is that, as I said in the morning, the inaugural session also, the kind of aggregates which we wanted, they are becoming in short supply because of internal concerns now. We're not able to explore more quarries now. And in fact, we are short of all engineering materials, including earth and sand, aggregates, and also other materials now. So we are, of course, constructing payments in many different ways. We're constructing payments in many different ways. And when you take off payment now, okay, we start with the subgrade. And in the subgrade now, we know that we have a situation wherein it's a weak material, and then it is moisture sensitive, and then also naturally it is an in situ material. We may change it if required really badly, but otherwise it's an in situ material on which we don't have much scope for really improving it unless we really start spending money or we spend time on improving the subgrade. Then the next point we have, of course, is the next layer, which we think of normally as a sub-base course. And in the sub-base course now, which is distinct from the subgrade soil, is a layer of moderate strength, and then it's free draining, definitely respect to free draining, and it's again natural material. And of course, we are trying to use the most inexpensive kind of aggregate material or combination of aggregates in a sub-base kind of thing. And you also see relatively, when you go to the next layer, which we call as base course, naturally the sub-base layer is going to be more, I should say, thinner than the sub-base because base course is more expensive than anything else now. Well, after having said this now, what we are trying to look at is this base course is definitely a stronger material, stronger compared to sub-base course, free draining material, and it's manufactured, of course, and definitely less expensive when you compare with the asphaltic surface course materials, be it asphaltic or be it concrete materials. So that is the strongest material, and definitely it's supposed to be durable, and then impermeable, and then of course it's definitely manufactured, and as I already said, it is the most expensive materials now. So we are trying to get a combination of these kinds of things now in the case of modern payments now, modern heavy payments particularly, and that means starting with soft subgrades. We are developing a lot of coastal roads now. We are trying to develop roads in our borders also, let us say in Rann of Kutch area and things like this also, soft soils now. And then the traffic is increasing by leaps and bounds, and aggregates and other things are in short supply. So we have to look at newer kind of combinations to look at exactly a material which we are going to think of now. The other thing is that whenever we are dealing with the materials, I am taking for granted that the materials are being tested very well now. And also we have to follow the specifications of the country concerned. In this case now, our Ministry of Road Transport and Highways is the one which brings out from time to time the specifications of road and bridge works. It's a kind of contract document that means the contractors are executing the works actually. They have to follow every bit of it, every word of it now, because the kind of agreement now. The designs, all of you are aware, in India are of course being done by the method of IRC as 37, which calls as guidelines for the design of principal payments. But I can tell you that this is not guideline. This is a mandatory subject actually. That means every road designed in the country, the national highways and of course expressways and the state highways are bound to be designing this now. That is a kind of understanding we have from the concerned ministry. So in these layers which you are thinking now, we have of course a base course. We have, of course, the subgrade, and then, as I said, a sub-base course, base course, varying course, and things like this. But when you look at the thickness of these materials, for example, we take it into consideration that the subgrade soil thickness is going to be around 500 millimeters, and then the granular subbase, which we call as typical subbase, is say maybe less than that, maybe 250, 300 millimeters, and then there is granular base course, again maybe 200 and odd, and then maybe the two layers of bitumen materials, dense bitumen macadam and bituminous concrete. So that is the kind of layer thicknesses we are going to have as per a design system, let us say. So if you look at the same as the 7 now, for a traffic of 100 million standard axles now, we find that if the subgrade characterization is 2, we got this kind of total thickness now. If you go to CBR 10 now, obviously we have this kind of thicknesses. So what is most important for us is, in general, the top layer thickness, that means viscous layer thickness, is not changing as much as that of the granular layers now. So our soft subgrade now, our granular thickness is as much as 600 odd millimeters, whereas of course if CBR is 10 now, it could be maybe somewhat less, maybe 300 something. So softer the soil now, we are likely to use definitely more granular materials, which we already said are in short supply. So that is the main thing. Also, of course, bituminous layers are very expensive. We already said that now. Now, can we decrease thickness of these things now? as efficiently as we're doing otherwise. So that is the basic thing now. So the methodology we are following, in the case of design of roads, like our Professor Ari said now, we use actually the mechanical empirical design method, essentially following the ASTO and other recommendations now, wherein each of the layers actually we consider linear elastic, isotropic, homogeneous, infinite and Hausen extent, continuous and finite thick now. So obviously these are broad assumptions definitely, and we consider these stresses of different kinds, that means different kind of surface contact area, and then bandage accessibility cases we are going to think of now. So when you think of this now, the recommendations are based upon two basic factors actually. Ananya? Two basic factors, and in this case now, one basic factor is actually what we call as rutting. I'm sure you are familiar with this word rutting. And then of course fatigue racking. So today of course we know the reasons for both these things now, rutting and fatigue racking now. So one of course is that rutting, and you say failure model is rutting now, it is actually a permanent deformation or rut depth along the wheel load path, and that we'll see that the vertical strain, vertical strain at the top of the subgrade or below the subbase layer at the interface now, that is what we're considering as the reason for rutting now. And then if you go back now, in the previous case now, we also have the fatigue. Fatigue obviously is caused by the horizontal tensile strain at the bottom of the bitumen layers now, like exactly what Professor Ari has mentioned actually. And then when we think of that now, we also have other considerations definitely, but then in these considerations now, we have of course deformation and thermal cracking of bitumen layers. All these things are actually taken care of by power mix design. So what we are trying to look at is, we are looking at the kind of system which we thought of. What is the system we thought of now? The rutting caused at the interface of the subbase and the subgrade. And then of course, the tensile strain which we are having at the interface, at the bottom of the bitumen layers now. These are the two criteria. And here the empiricism is going to come in. And the empiricism is going to come in the way that, we have got these equations, the number of repetitions you can think of now. And when you think of rutting actually, what we are doing defining rutting actually separating life is the cumulative number of 80 kilonewton standard axle loads that can be served by the pavement before critical rut depth of 20 millimeters or more now. So for 80% reliability and 100% reliability now, so it is giving you the number of repetitions allowable now. In the same way, we define the fatigue life also as cumulative number of 80 kilonewton standard axles now, and that will cause actually a cracked area of 20% of the pavement at the end of design life now. So we got this failure number of repetitions now, and there are constants that are prescribed. And what is we are going to do is that now we are going to think of the least value. The failure can occur due to fatigue or rutting, and that is the basis of the MEA method of design. So the idea of this basic concept is what is evolved, of course, over a lot of work done throughout the world now. But want to introduce the same methodology when trying to use this also. That is what the basis of our present presentation. So in this context now, we got geosynthesis of various varieties now. The prominent ones, of course, are geotextiles, the geogrids, and in our concern today could be geocomposites now. So geotextiles are of various varieties. So also geogrids now. So what is it we are going to look at is very quickly introducing the subject of geotextiles. So geotextiles are of course permeable geosynthetic materials comprised solely of textiles. So they could be used of course in the geotextile applications very well now. We are trying to use it actually in our pavement structure. So these are of various varieties, basically polypropylene and polyester, and then there could be different kind of weave structure actually. So usually what we taught is a geotextile produced by interlacing, usually at right angles, two or more sets of yarns, fibers, filaments, and tapes or elements. What we're trying to say is when you look at the ultraviolet microscope view of this woven geotextile, what you find is that there are openings which are at each of the intersections now, which make this geotextile permeable, though it's a textile. And then, of course, we also have strength coming out by these filaments basically, and water can pass through in this also along this plane, and also these holes can also act as interlacing, some kind of filtration, but they are known for this strength basically. On the other hand, we have a non-woven geotextile of various thicknesses. And in this case, if you look at the ultra microscopy of this now, we find that there are a lot of openings here now of different size and different shape. This is what we call as needle pinch non-woven geotextile, and this is what we call thermal bonded non-woven geotextile. in all the cases now, we have these openings, actually very, very micro openings, basically, through which only water can pass through and the soil particles are not going to pass through. And because the thickness can also vary, obviously what is going to happen now? We are going to have filtration across the material, across the geotextile, and then along the geotextile, obviously there will be drainage now. So these are performed by this structure. So when you look at soil reinforcement now, the traditional solutions are take away the in-place soil and replace with very poor soil, or you do heavy concrete construction, or of course increase thickness of the aggregates now, or of course preloading is what you do in geotechnical engineering, extra load and wait for consolidation. So these are traditional solutions now. And all of them are obviously going to involve a lot of time also and then cost also. So when you think of a solution in terms of geotextiles, actually, we have situation wherein people can simply get bogged down on this now, very uneven surface now, and one can think of placing a geotextile on that now, but that is not the best way. But using them now, we can definitely, using geotextiles, we can construct good quality roads now. What is it which is being done now? The construction is possible in a low bearing capacity soil. Maybe excessive wetting is going to be done if otherwise not treated with geosynthetics, and we can have compressive layers. And like in Arunachal, we can have landslides also, we can have soil fails also, uneven settlements. For all these kinds of cases, now we have geotextiles of various varieties, not only pavement structure, also engine structures which give you overall stability now. So in these cases, what we are looking at is obviously soil reinforcement. The other major thing which is being done, of course, is in this case of what we call a separation now. So what we find is that, particularly in soft soil construction now, the aggregate layer, which is supposed to be just below the, you can say wheels actually, when you think of a single layer pavement to start construction now, we find aggregate is going to sink and actually, and to even many meters actually. So when once you place a geotextile, it bars further sinking into this now. So what is happening in this case? Obviously, it is going to allow actually only water to pass through. Soil particles are not allowed to pass through, and it also becomes a slightly load-bearing layer. And through the thickness of this, through the contact between the stone pieces, aggregate pieces, and the geotextile, it helps us actually in trying to contain them in the same place. The friction is not allowing the particles to move away. So it also becomes that way a construction expedient for a long-term effect now. So early designs were done like this now, saying that we can save thickness of the water pavement by using the geosynthetics now. These are very early days now. Design curves are there. There is not the modern CBR curves, but still they're based upon CBR or even things like things like shear strength or cone index now. You look at the situation now. We are talking of CBR of 0.25, 0.5, 0.75. Such low CBRs wherein you can't walk also. So these designs were, of course, early designs now. And compared to that now, we also have different variety now, which will interlock with the aggregates now. So these are geogrids now. A geogrid is actually grid-like polymer structure formed by intersecting ribs now. Something like this is there now. So in this case, what is happening is when you got a grid structure like this now, so what is going to happen is the aggregates actually will get into this now. They're interlocked now. They can't move away now. When once they want to move away, there is a tension building up in the ribs all around actually. And is the tension which is not going to allow these particles to move down now. So that's how they are distributing the load wide area. So this is what we call as a strong and positive interlocking basically. We also today we have three-dimensional permeable polymeric honeycomb structures actually geocells, which are becoming very popular now, not only throughout the world but throughout India, particularly in soft soils like Arunachal and other areas wherein construction is very difficult. And we also have shortage of aggregates now. We simply spread these cells actually, fill with coarse grained soil or aggregate, and that becomes literally a load-bearing layer now. So there are specifications given by the Bureau of Indian Standards on all these materials for different purposes actually. So what is the total role now? We are going to look at the role of the geosynthetics related to the pavement structure only. One is it is separation, another could be reinforcement, and of course it could be drainage now, and it could be filtration. And of course, in other cases which are not going to deal with now, it can also be act as a barrier. In back on soils, we can use them as barrier also, but we're not referring to that now. So what is it we're going to look at is we're going to look at the distribution of the stresses actually over a wide area. So this distribution is what we're going to look at. And in the early days, long ago, when I was at IIT Delhi, we just did simple tests now. We said how the geosynchrons would behave at an interface between the sub-base course and the soft subgrade, let us say. So we try to have a cylindrical specimen, 100 mm diameter, 200 mm height, and then is a composite specimen. Now at the interface here, we can put a geotextile or otherwise. or geogrid now. So tests which are done now, this was actually model WBM. Today we can call it WMM now. So this is the section curve for actual strain. This will be the deviated stress now in interaction test. So what is it you find is that just WMM, model to WMM actually will give you quite a high strength actually. On the other hand now, we have, let us say, our local soil, Delhi silt actually, where the strength is very, very low actually. And now when a composite specimen, that means at the bottom there is a subgrade and the top of the specimen is going to be the aggregates. We find the difference between the soil sample itself and the composite sample is very little now. That means this WBM, which is very strong actually, is not really contributing to the load bearing system. On the other hand, now, once you place this non-geotexture also, I'm showing the same picture in analogous case now. So we find again the Delhi silt and then unreinforced specimen. Once you have a weak non-geotexture also, you find actually the behavior is radically changing. Now, the three things which are happening now. You look at this now, these are the peak values for this unreinforced and pure soil only, pure subgrade only. The strength is improving almost 2-3 times actually. And this is improving actually with more and more strain. Very important for us to note. Later we'll see what is the effect of this on rutting. And then, of course, the strength, of course, is not decreasing within the limits of the strain we are allowing now, whereas in this case, it's decreasing. Also, we find that the modulus are improving now. So all the three things now, the peak strength is improving, residual strength is much more, and the modulus is also improving now. These are the things which are obtained in a static test now. So in those days, we have done tests, cyclic load tests actually, using parts of this kind of thing. And then what is it we find is that if these are load repetitions on this axis, and then we try to divide the cyclic load and strain curves into permanent axial strain and the rigid modulus. Now, what is it we find is that the unreinforced specimens now we find that they are simply sinking like a plate load test actually. Whereas once you place the geotest, we find that definitely even at higher repetitions, it is not going down, it is not sinking. So you find this also happening in for rigid modulus also, whereas these are the curves actually which are there for unreinforced specimens. For reinforced specimen, that means non-vegetation also, we find that it's improving by 2-3 times actually. So that's fantastic for us now. And we can see the kind of model ready for test for tanks now. Earlier we seen triaxial now. Same thing is happening literally in the case of static loading and of course cyclic loading. Behavior is very similar actually. And that gives confidence that yes, payment do work actually. And in this case, most important thing for us is see this now. The behavior with respect to geogrid is obviously much better than that of the non-geotest style. Of course, under assessment, it decreases quite significantly. This is the permanent axial strain, and this is the apparent digital modulus because we didn't test in tank. So here also the modulus is increasing significantly, whereas that of the soil is somewhere at the bottom only. So we find that now it is not 5-10% increase. It is really very significant. Sometimes 2-3 times improvement is there, both in modulus and the permanent axial strain. So this actually is taken care of indirectly in a new manual or new guidelines brought out by the Indian Road Congress called SP 59, Special Obligation 59, released in 2019. Naturally, I was one of the committee members to look into all the details. So this particular document is wonderful for India because now it says we can use these synthetics of different kinds in many different places at subgrade, at the interfaces, and then also at the edges now. And in fact, it requires maybe half a day to explain what all we can do with this. We'll only focus on some issues now. So one of the things which we try to say is that placement of geocells will actually constrain the aggregates from moving around, and it gives lateral constraint, and then it also gives you very diverse improvement. It also gives you tension support because as rutting is happening now, naturally the bottom layer is going to tension, and the tension is going to prevent further accumulation of rutting actually. So with these kinds of things, which are hypotheses to show that the strength definitely improves. So this is a typical hypothesis. Of course, we are long back now. So two things we can think of now. What is it we can think of? We can think of this as going to be subgrade improvement. That means just improving subgrade only, or of course within the base course. So for this, we use the same concepts actually. One is separation, we said now, allows filtration drainage anyway. And also this is also given in terms of any damage can happen during placement and construction top layer over the entire thing, over the geosynthetic actually. So a lot of tests are specified actually by our Ministry of Road Transport Highways, essentially based upon the ASTO recommendations now. So I will not want to go in detail of that, but what I'm trying to say is that now depending upon the condition of the pavement which are going to construct now, there are these limitations. I mean, there are these minimum values which are prescribed, minimum strength values, to ensure that the material which are using is it does survive the construction actually on a soft soil, also the heavy kind of equipment. These are also going to become part of the ministry's document, and will also probably become part of the extended SP59, which has been discussed now. So solubility is definitely based upon, we got heavy roller actually more damage to that now. If you got a soft soil at the bottom, is less damage now. Like this, the fundamentals are covered, basically taken from the ASTO document now. So different tests are prescribed now to see that the damage is limited, including ultraviolet damage now, or we also have specifications for subsurface damage now. So all of them are taken into consideration, and naturally these are included in the ministry specification book, which is what we call orange book now. But these are under revision because the entire book is going to be revised actually. And the construction is very easy. You just level up the grounds actually, and then spread the geosynthetic now, and then over that you can rear dump the aggregate, and then you can spread it, and then roll it actually, and that's it. Because the conditions are already taken care of for what filtration, what drainage, and what strengthening. So placement is very easy for us now. So this is the kind of thing. So one is mandatory kind of requirements to take care of solubility, and the rest of it is given, of course, also in various forms actually. The design methodologies, there are many available now, but none is recommended directly. But then for strengthening purposes now, it is geogrids which are going to come into more use now. So you can see here now on a soil wherein on a subgrade, which is definitely inundated with water now, we can spread a geogrid and start placing the aggregate now. You can move your equipment over this happily actually. So that is the basic kind of thing. So what exactly this is going to do now? So we have a situation wherein one second. We have a situation wherein we can think of no geogrid or no geosync. Now aggregate is going to sink into the ground. And once you place at the interface now, geotextile or geogrid now, so we find that this sinking is not really there, and we can definitely avoid this kind of damages actually. And when once you place a grid now, obviously we find that we got a better surface on the weak subgrade, and so even compaction becomes quite easy. And the interlocking business anyway there now. So it is constraining the aggregates now, the subbase aggregates, into the openings which are there in the geogrid. With this kind of thing now, we find that the load is now distributed over wider area than otherwise, than directly now. So that means distribution load is going to happen. The distortion which you are going to think of now, and then the distribution of the load because the presence of geogrid is both happening simultaneously. And by this process, what is going to find is that a subbase, a normal subbase course on a kind of soil or whatever where it is going to be, we can change this to lesser thickness of subbase and then placement of geogrid now. So though we don't want to quote the numbers now, so such a kind of thing may save actually significant amount of aggregates also. Okay, now where to use what is given by the simple philosophy. One, of course, if you think of separation now, we'll look at the severe value, soaked severe value greater than 3. So we are going to look at actually only non-woven geosynthetic, non-woven geotextile. If you're looking at reinforcement, that means that is for a soaked severe of 3 to 1. And in this case, we can use both geogrid and woven fabric, woven geotextile. And if you think of both reinforced separation now, that is for less than 1 CBR, we have to use a combination of both geogrid and a non-woven or woven geotextile. So this is general recommendation conceptually. Actual design has to be done. So a lot of testing has been done in the field by various agencies now, long back in the 90s itself now, and they continue to be there throughout the world now. But what is it you find is that now, if you think of the number of passes, number of repetitions you're thinking now, and the depth of pavement layer now, for example, look at CBR 8, very strong CBR, and for unreinforced pavement, this is the kind of thicknesses, that's as per ASTO. That means thickness are ranging from 6 inches to, in this case, inches only, to almost 14 inches now. Whereas when you use the reinforced material, actually, geosynthetic now, we find thickness reducing significantly. You see the thickness reduction now. It is a 4 to 5 inches, 6 to 8 inches now. And then if the CBR is going to be lower value than 3, same thing, unreinforced at the top now, reinforced at the bottom now. So always there is a decrease in the thickness requirement by any kind of standards. And various kind of assessments are done, section 1, section 3 like that now, on the study by Professor Kenne in Alaska. And in this case also we find that there is another new terminology which is brought out now called traffic benefit ratio. That means how many times more traffic the particular geography can take up now. Here traffic benefit ratio is as much as 10 times. That means if you are designing a traffic for 1 million standard axis as per the normal condition, put a geogrid now, it gives you 10 million standard axis. That's the kind of thing for specific cases, but not every time. You see that here at least 2-3 times improvement is really there. So like this, there are various studies done throughout the world now. Again, I will refer you to one of the specific documents brought out by the Transportation Research Laboratories as early as 1989 in Prothon, UK. So what they have done is they have, of course, done studies up to 2000 repetitions only, but they are bothered about the rutting only. So if you think of rutting, they defined the limiting value of rutting is 40 millimeters. And then on this axis, we got thickness now. And what is being shown is the dark line here is the reinforced case, geogrid reinforced, and the amber line, of course, is no reinforcement. So you find that if I'm going to put, let's say, thickness of layer, aggregate layer now, what is it defined? We find that no reinforcement, let us say the number of repetitions is going to be 100. And if you are going to have reinforcement now, it is going to become maybe 300, 400 like that, of that order of that now. Or otherwise, you can think of like this. If I am going to have 40 millimeter deformation, there will be 500 cycles, let us say, then naturally I may just do with only 225 millimeters of pavement layer. Whereas in the other case now, it goes to 250, 260, 275 like that now. So there is always the reduction in these cases now. But more than that, the pavement behaves actually as a rigid kind of flexible mattress. That is going to be very important for us. And now where to place this now is also a question which I address. If you got a soft soil, aggregate is good now, we definitely place the interface of the subgrade and the subbase course. If you got the granular material not very good now, but the soil is stiff now, we can reinforce granular material by placing it in between. It could be within subbase or within base course. And if you got naturally the property of the soft soil is, soil is very soft, and the material also is not very good now, then we may have to place it at two interfaces. One interface at the subgrade and the subbase, and within subbase or within the base course, we can put one more layer now. So that is the basic concept we're going to think of after a lot of assessments. Now, what is this really does? There are a lot of studies which have been done now, and the models have been developed now. But let us assume that we are just doing a plate load test kind of test. Okay, place a plate on a soft soil and then start loading it up now. So this settlement and this is the kind of pressure we're going to apply. So, in a typical plate test also, we have this kind of curves which are coming out after load test. Now, usually, we try to find out the so-called ultimate bearing capacity. We're saying that, okay, extend this line, extend the vertical line here now, and so the UBC, and that you divide by factor of safety 2.53, and then we come to the limit, elastic limit is what we call now. So that is the kind of load we can place. Initially static, we can reduce it for the cyclic also. But that is the kind of elastic limit, that means end of the linear portion actually. Now, by using geocentric now, we can go up to the ultimate bearing capacity because the factor of safety is now being given by the geosynthetic. So that means we are able to load the soil fully up to the ultimate conditions because the factor of safety is coming by the geosynthetic. That is basic concept way to do that now. And there are many theories given to put it in equations. We are not getting at all of them now. So the point where based upon these field estimates and based upon these concepts now, a lot of research evolved actually method of design of these things now by initially following the Astro method of design, payment methodology actually, and we are looking at a structural number now. So we know the standard equation based on Astro method actually, structural number equal to naturally D1, D2, D3, starting from the top now, top layer thickness, second layer thickness, third layer thickness, we can increase it like this now. A1, A2 are the layer coefficients. And in these things now, we introduce actually a layer coefficient ratio. That means what kind of geometry we are going to place, we are going to do this in this equation actually. And of course are the drainage coefficients actually. So the point is that we are introducing geogrids actually or geocentrics now in a otherwise Astro, which is universally accepted kind of equations now, and based on of course statistical kind of variations actually. So these, of course, these values of LCRs actually for various kind of layers, we got default values given by the SP59, and otherwise, if you want to improve further now, the manufacturer has to provide data based upon actual field tests now. So the layer coefficients actually, the professor also has shown this earlier, so are based upon the testing, in this case A2, A3 are granular layers now, so with that MR which is given by the ASTO or by our own countries, this one now, And the LCR values, of course, if the CBR value is 3%, then the indicative range of LCR could be 1.2 to 1.8, and the CBR value is 5% and above. This indicative value of LCR is going to be 1.2 to 1.6. That is the default values. So the same equation earlier we have seen, now that is going to place here. That means the A2 value is improved by the LCR value, A3 value improved by the LCR value. So that much improvement we are going to get now. Rest of the range is going to be easy for us to do this now. And the values which are taken from the measurement actually or from Astro, we duplicate that and do this. In the same way now, another kind of way of trying to do this is going to be by what we call as modulus improvement factor. MF it's called actually. MF can be done for both these things. It all depends on manufacturer what value is going to be. Is going to be MIF or LCR. A different kind of test conditions there. If you use MIF, modulus improvement factor, as a basis, naturally, if it is less than 3% CBR, we can have IMF of 2 to 2.75, and then more than 3%, of course, is 1.4 to 2. The one thing we had to recommend, we had also given in mind is that the softer the soil, actually, the better is the value. The weaker the aggregate, the better is going to improvement now. So it's like Mother Earth now. Mother Earth always supports which are weak systems now. Same things can happen. So that is why less than 3% we got higher MIF values, and more than 3% CBR we have obviously lesser MIF values. So construction again is quite easy. One can take it manually itself, and then the construction is almost similar to what we are doing in geotextiles, except that here we have to spike them down because in the factory they come in roll form when they're hot still. So we have to kind of level them and spike them actually like this to the ground by using U-pins now. And thereafter, of course, you spread the aggregate and then, of course, compact in the same usual fashion and then go through next layers. So these are granular layer improvement. For asphaltic pavements, we have a lot of data available to us based on the same kind of thing. We are looking at the tensile strain at the interface between the bituminous and non-bituminous layers now. But this is something I want to show you, very important in earlier literature only. But what we are trying to look at the initial traffic induced strain in terms of micro strains actually. And this is number of road applications. Okay. And if you're looking at that now, we got an unreinforced line here at the bottom, and we got also the reinforced grid actually. So in these cases now, let us assume that this is the micro strain allowed by the design now. So how many cycles we are going to allow? We'll say 10 to the power of 5, maybe 1.5 10 to the power of 5. And go to the grid reinforced now, we find that the number of repeats we are going to allow is again something like 1 to 1.5 10 to the power of 6. That means we are going to have one order. That means 10 times improvement is possible by using this kind of this. So usually we say that the improvement could be 3 to 10 times actually, one log cycle. Now this is also given actually very easily by early tests done in the UK with using the stiff grids basically. In these grids now, what is it we find? We find design life, the million strand axis on the horizontal axis. On the y-axis we got the, say, HBA they call hot roll asphalt. And if you look at that now, what is it we are going to look at? We first have a blue line. This blue line is for no reinforcement of the bituminous layers. And the single line here, full line here in orange is going to be the reinforcement, one layer, let us say. So if you look at this now, supposing I want design life of 10 million strand axis now. Just go up now. What thickness required? Let's say it's 150 or something like that now. If it is your geogrid, and then if it is going to be no reinforcement, it's 250 millimeters. So that means placement of one layer of geogrid is equal to something like 100 millimeters of bituminous layers now. Of course, there is a on the higher side, but then there is a kind of order of improvement which you are going to think of. Of course, if you place 2 layers, naturally it's going to be much better than this one. So the remarkable efficiency of the geogrids is something unbelievable now. A lot of work is done also in the states for this now, for different kind of situations. Again, 1 layer, 2 layers, design life here in million strand axis, and here in terms of thickness now, same kind of behavior in general is shown. Only percentage will vary. And obviously, the mechanism is going to be depending upon high temperatures, heavy axle loads, high traffic volume. All of them is going to be done. So we may use this data, which we already use now, but in the IRC 59 now, they allow us to use different layers of geosynthetics now in the asphaltic layers now. What was it now? Non-woven polyester filaments with either needle punch or thermally bonded, coated multi-filament polyester woven or other kinds of glass grids, and again using polyester grids now, or a glass fiber material, or a extruded woven polymer material. I want to just show them to you So this is what we're talking of now. A fabric, paving fabric, which is essentially meant for, you can say, strength, not really strengthening, but in terms of improvement, in terms of what we can call as impermeability. Okay, then we have glass fiber grids now. We can have a polyester grids now. We can also have actually an automated geotextile over which we got stitched or ornamented fibers of obviously polyester or glass fibers, and it could be also bonded structure like this. So you find that actually there's a huge table. I'm not giving all the table now. I'm just showing you that for various conditions now, the IAS 59 tomorrow, as well as the Ministry's document Orange Book now, will allow us to use any one of them, which is going to be specific and based on experience. There's no guideline of what is specifications are given, of course, but there's no guideline which one we have to pick up now. That is based upon our common sense. So that is the way different things are there now. What is the cover thickness we are going to have now? Basically, the cover thickness could be in a glass fiber grid, it's going to 25 millimeters, and in a pulse grid, 40 millimeters. But one thing which is very important for us is that all the materials are being made in the country. We don't have to import any one of them now. So, it goes to the system, the PM always both says it's called Atmanirbhar. They are made in the country to world class. In fact, most of the materials are being exported till COVID has come. So initially we thought of we can use these materials very well in Amravati, which was a developing stage at the time. This is a few years back history. And what was thought was that the selling price of Deccan soil in Amravati, which was supposed to be capital earlier of Andhra Pradesh, wherein KLU is situated, the selling price was as high as even 2 kilograms centimeters square, means 200 kPa. It is varying now. So the construction was in different conditions already. So one level of improvement is going to be that on a prepared subbase, we can use the geogrid come geotextile. If construction has gone beyond that now, we thought of using asphalt interlayer composite means is exactly same glass fiber grid on a geotextile. So these are the two kinds of things which we thought of which is possible. And so this can be done now. And thereafter, of course, we can go for other layers actually. So like this, the construction was done initially. I have some pictures of this. Wherein construction gone up now, we use only the top layer now. We don't use both the layers actually. That was the recommendation given by us long ago. And some construction taking place. I don't know what is the present story, but the first layer of geogrid come geotextile was used essentially. I do not know what is the condition of that. In them, everything is and things like that. Another important job which I have done, of course, is at Jaipur, which has gone a lot of distance actually. And I've been in Jaipur, of course, since as I do.
Sir?
I think there is a network issue with the GV Rao, sir.
Shows the questions actually.
Chaitanya Garu, can you please talk to GV Rao, sir?
Yes, sir, I'm calling him.
Yeah.
Chaitanya, I'm calling.
Okay.
Sir. Okay, sir. You please make the calls.
Hello.
Yeah,
Yes, sir. Good afternoon.
Yes, sir.
You are audible, sir.
Now you are audible, sir.
Hello.
Yes, sir. Yes, sir. You
Any
are
question?
audible. Yeah. Sir, you have completed, sir? Have you completed the presentation, sir?
Yeah. I already have exceeded the time, so I thought I will finish it quickly.
Okay. Yeah, sir, it's really great presentation. Participants, I request you ask if you have any questions, you please ask Professor G.V. Rao.
Amarendra sir, as you have requested, I have given you the presenter status, sir.
Yeah. I'll just show after
Want to
this.
tell us something?
Anyone, please, if you have any questions.
Can I have a question, please?
Yeah, please, sir.
Please.
Please, sir. Please, Dr. Hari.
Okay, yeah. Okay. Great presentation, Prof. G.V. Rao. It's quite similar what happened in Indonesia. We have a lot of problem with the soil, yeah, expansion soils, and about the intrusion of the water into our soil. So in Indonesia now, the pavements tend to be the concrete pavements everywhere. It's national road, it's district road. Yeah, it trend to be changed into concrete pavements. But sometimes the treatment from the soil is not very good as well, and the life service of the pavements we designed for 40 years, maybe by 10 years it's already collapsed. So
Yeah.
yeah, it happened for concrete and for the asphalt as well. But now the trend is come to be the concrete pavements. What do you think, sir, Prof? It is better to treat the soil, the soil with the geosynthetics, or it just change the whole structure into the concrete pavements? Maybe your opinion is useful.
One thing I feel personally is that concrete payments, you can't repair them.
Yeah.
Yes.
You can't repair them. See, flexible payments you can repair, you can strengthen it, That means, in our country, initially they used to have payments, flexible payments for 5 years, let us say. Because, we had a lot of roads to be covered and then money was not sufficient. So they were just spreading thinly. And so it's possible to improve them. And then you can find out these things. Otherwise, what we have to do is that we have to do some ground improvement. By using even geosynthetics itself, we can do that very easily. And they'll be, I should say, more economical also. Because any problem which comes now, we can take care of. Actually, a lot of new designs are being done, not necessarily concrete payments, but we have a concept called now in the world perpetual payments also.
Yes.
So if your payments are going to perpetual payments with geosynthetics, nothing better than that actually.
Yeah.
Concrete payments are not a panacea. Okay, it may look initially good. I live in I don't say I'm living in Hyderabad only, but one part of it now, it's a village-like atmosphere. They build these concrete roads with very little thickness now, and within 1 year they completely get cracked actually because they're not building properly.
Yeah.
So definitely for main highways, yes, the government can think of they have money they have to spend on big highways, but for other roads, I think I will go for some kind of ground improvement, and definitely some improvements required for black cotton soils. For black cotton soils, solutions there wherein we modify the soil partly to minimize the selling pressure. In India, we can think of mixing lime and fly ash, or we can think of other kind of chemicals, and by that process improve subgrade now, and improve subgrade meant now reducing the potential for heave actually. So that means you have to treat it from the source. We don't have to keep that, where the rainfall in Indonesia is very heavy. With all the things now, soft soil, black cotton soil, rainfall being heavy, naturally we can take care of now by the advent of all the materials actually. And I don't know whether you manufacture as of now or import geosynthetics now, but some of the common materials like woven geotextiles and non-woven geotextiles can be easily made also. Very inexpensive kind of treatments. And that way they're good enough for solving problem ab initio. because you have to see the source, the source problem has to be done, we think of, suppose you have a heart problem, you putting something on the surface of the body is not going to solve. You have to cure from within the system. So that cure is given by the geosynthetics now. And I know you are quite good in bituminous layers also. One can combine the bituminous layer thickness, bituminous layers with geogrids, geosynthetics. I mentioned 5, 6 of them. And that will be a wonderful experience. And definitely we'll be saving a lot of money. We'll pay a lot of money. They'll be definitely more economical in this. That is my gut feeling.
All right.
Have I answered your question?
Yes, thank you. Thank you, sir.
Sir, Money Excel wants to ask a question, sir.
Yeah, please.
Money?
Oh,
Money,
yes.
please go ahead.
Okay. Good afternoon. I have a question. If, for example, I want to reinforce a long road or strand for a long distance, is the geotextile is economically profitable? I mean, like, if I have to buy a lot, it can be cost a lot of money for the company. Is it economically profitable? Thank you very much.
Mr. Money Axel, I think Jivra sir is network issue once again. Anyhow, once the network is resumed, definitely I will put this question.
Actually, I can also
Amrendra, you can answer, please.
Yeah, I can also answer to Money Excel. Actually, sir, this is I have also Sir has come. Sir, actually, Mr. Money Excel asked a question, sir. Like introducing this geotextiles, different products in the payment layers, is it cost wise compared to the conventional payment, cost wise it is profitable or not, like that? Yeah.
See, one thing I tell you, Amarendraji, that if it's not cost wise economical, who is going to use it? Isn't it? That is common sense. The thing is that they give you longer life. That is most important, actually.
Yeah, that is there, sir. That is there, sir.
That is mainly. Sometimes investment may appear to be, initial investment could be higher, but I think maintenance intervals are going to be longer, actually. Okay, and it does take care of conditions of like very soft soil or like what Dr. Ari said, blackened soil, things like that. There is no other solution actually for these things. At least those of us who are on Andhra Pradesh know very well the condition of the roads on blackened soil, isn't it? And those things can be very effectively treated actually. You remember when I was in KLU long back with Hanumantrao, I was thinking of having a center of excellence only in dealing with blackened soils and geosynthetics actually.
Okay.
And the different options available also in treating it by other means, as I mentioned. We have right in Vijayawada, or right near Vijayawada and Vibhamatnam, we've got a lot of thermal power plants now. Ash is available actually.
Yes,
and
sir.
using waste materials. In fact, that was thrust for us, and somehow that didn't come up. But that is the only way in which you can improve the things actually. We can't go ahead continuously with the same standard, let's say, as 37. And what I wanted to show actually through my presentation is that what we are trying to do in SP59 is extending the logic of Act 37. Till now, we thought that juice is separate and then payment is separate, as though we're introducing something in between. Here it's not, we're combining these two things. That is the first step we've gone through. And that is where it is making profitable situation. In fact, it's part of specifications. Most of the, quite a big highways actually in the country, many projects are coming up like this. And also in hill areas and things like that. You see, I only mentioned to you about the basic payment structure. I didn't bother about the drainage conditions, the edge drains, which are important in hill areas and things like that. Drainage is, of course, very well, most critical thing in pavement life actually. So that can be done by various kinds of uses. We have also geocomposites which are there, drainage composites which are there. We have edge drains which are very inexpensive actually. And many such materials are there for the choice for the Indian engineer. Because I can tell you that till 10 years back, quite a few of them were imported actually. Today, that situation is not there. You have world-class materials being made in the country. You can go and see them. And Dr. Hanumantrao announced that we have a beautiful laboratory made up in Jaipur just for testing it. The testing can be done just in presence also. No hanky-panky. Not like some of the IITs wherein they say, no, I'll give the value, but stay outside. So you can see it yourself. You can bring your students, bring your colleagues, and see that testing is being done and what we should done and what we are going to get values. That means standardization in front of you. The quality control which is going to be done, the accreditation which how is being done now. So in all the things now, the quality control becomes very important for us actually. So this is assuring the quality actually. And the specifications are given by the BIS anyway. It's not ministry. The specifications are given by the BIS also. And because of the COVID, the IRC got postponed, but we also have a separate document on not directly payments, using industrial waste, bulk waste materials actually. So at least India, I think there is a wave which is coming up now. Only thing is COVID does not allow us to move forward. But I think most of you know that the only infrastructure which are building in the country very effectively is only roads. Thanks to Mr. Nitin Gadkari, so much is being spent. So, lakhs of crores are being spent on this. And despite this, we are going ahead with the road construction because you know very well road construction means labor is there, bitumen is there, steel is there, concrete is there anyway, and aggregates, local level aggregates. Now, you may also note just one more point I mentioned now. The ministry as a circular, ministry means the Minister of Road Transport Highways issued a big circular actually, general circular, that for these states, let us say, you have to use, if available, the local waste material. In these states, if available, you have to use geotextiles. In these states, if they're available, you have to use core geotextiles. So there's mentioned now. So this documentation has been categorized also in the document. It's a 3-page document wherein they mention for these kind of conditions, you have to use this code, you have to use this code. Only when these codes are not relevant available, then you have to go to foreign courts also. That is also given. Never before the government of India has promoted the use of geoscistics in this kind of way. In fact, they are promoting industry also, they are promoting the use of the materials also. And mind you that, as I told in the beginning, unless they are proved effective, nobody is going to recommend it. Not the least government of India. Because, we are spending lakhs and lakhs of crores on this. The behavior has to be as expected. Like our Professor Ari was saying, you design for 40 years and it fails in 10 years. It can't be, isn't it? That was the old days are there. Today we are caught red-handed. You see, the maintenance of the roads also is coming in the same contractor now. See, that also small decisions taken by Mr. Gadkari is part of the system now. That means the contractor has to be very careful because he's going to maintain for the next 20 years. If the road is not going to get tall now, naturally he's losing completely. There are new kind of contracts now also. That means the road system of tall is gone. Now, the major contractors can buy out the road, let us say. And he has to maintain it and get the toll back, actually. So it is his investment now on maintenance of roads. Maintenance of roads is an excellent thing. In fact, I can speak like this for ever together, but there is a lot of potential for doing this, a lot of potential for R&D, a lot of potential for instrumentation, and I think all of us will be richer. The country will be rich and will be rich by using them appropriately by doing relevant R&D in this.
Sir, really wonderful presentation, sir. Actually, in fact, I am also involved in the design of the pavements as a part of consultancy work. So in the recent times, sir, I have in the number of the platforms, I have supported this one, using the geotextiles or geosynthetic products in the pavement layers. And also, so many people, practitioners also, they don't know about this IRC SP59, sir. That is the problem, actually. Recently, sir, for 2 projects, one is by Adani, like for the Ganga Expressway, I have designed the pavement as per this IRC SP59. And I have suggested, sir, I have even economical analysis also has been carried out and found that you will be having very good savings, not only savings, as you said, a lot of other benefits also, indirect benefits also. That Another one, as you suggested rightly regarding the perpetual payment, sir, like government of India, like they have called for tenders the Bangalore Chennai Expressway, sir, dedicated expressway, many stretches, sir. Many stretches. So in that one stretch, sir, I'll take just 1 minute, sir, not more than that. I'll share one document quickly. Sir, this is the different. Are you able to see my present? This one, sir, board file.
It's coming.
This is it's a Bangalore Chennai Expressway, sir. This project. So in this, I have suggested different pavement compositions, sir. I'll just go through this one quickly. You can see, sir, there they have suggested to go for the perpetual pavement, sir. The thickness of the perpetual, using perpetual pavement, the thickness is coming approximately 300 mm, sir, bituminous layers thickness, which is very high for the country like India.
Definitely.
There are other type of payments also there, sir. In that, actually, finally, I have suggested this one, sir. You can see, yeah, perpetual payment composition with the GeoGrid as base layer, sir. Here, in case of the WMM, I suggested to use the GeoGrid, sir. This one.
Yeah.
And we found that the cost wise also this composition option 5 we are getting the less cost as compared to the other options, sir. Cost wise also it is less.
Yeah.
So I think
happening.
they are this is for the Monte Carlo, sir. They are now thinking. I told them because this one like you can see, sir, rather than going for CTB, sir, cement treated basis on the this one granular basis, the problem is CTB definitely it will get cracked, sir. It will get cracked. And once it gets cracked, then it's modulus. It will lose modulus like anything. It will act like a normal granular layer, sir. Rather than that, providing these geogrids is definitely acts like a reinforcement. And you can see, sir, I have taken only modulus is 600. The CTSB here, the modulus is 600 is there. On this, I am getting modulus is 800, sir, as per the whatever the layer improvement practice that you have suggested just now. So,
Yeah.
but I have taken 600 and designed, sir. You can see approximately with the 200 mm, 100 mm thickness of the bituminous layers can be reduced, sir.
Yeah, that is major saving, That is major saving.
Yes,
That
sir.
is
Major savings, sir.
Major
This.
saving.
Yes,
And
sir,
also, I can tell you, Amrinder, one more small thing actually. Not necessarily in the case of roads now. The Japanese actually for their what do you call high speed this bullet trains kind of thing. They
Yes,
use
sir.
a foundation layer of 1 meter of cemented layer actually, cemented aggregate, and bottom and top geotest sites actually and geogrids. In
Sir,
fact, that's a
even
wonderful thing. In fact, we don't any data on that now for
yeah.
payment purposes, but that will be beautiful. So don't ignore the cemented portion of it. Combined with these two things, actually, it will be wonderful behavior.
That's
In
what,
fact,
sir,
that's
that's
what I want to do some research also, but unfortunately, the COVID doesn't bring us funding also, and it is very involved. Yeah,
myself
but that is
and
wonderful research.
yeah, myself and Anmantra, we are combined guiding, sir. Definitely, we'll come back to you, sir. So that even sir, here also, like I am right now staying at Kadapa, sir, nearby our place, like Produturu. Here also, some section of the track, section of the tracks, the railway track is completely embankment failure happened, sir. There also for blanket layer, I have suggested to go for this GeoGrid, sir. So they are now using that one. This one.
Wonderful. Actually, if you are familiar with what do you call Gujarat now, Bharuch is having black cotton soil. That is where they have given tender for using perpetual roads. And Bharuch to the port, Hazira port actually, that entire road during construction got damaged actually. So we gave a lot of solutions, they have to construct anyway. But this gives a wonderful opportunity to think in a different ways actually. Thank you, then. I think Hanumantrao, we've taken a lot of time between Amrinder and myself.
Yeah. Thank you, sir. Thank you for your wonderful presentation, sir. You have explained many things, starting from the importance of the subgrade soil and using of the geotextiles and their applications in the pavement and design of pavements using geotextiles as per IRC SP 59, various case studies. Thank you, sir. Thank you for a wonderful lecture. Actually, I wanted to see you personally. I worked under Professor S.K. Rao, sir, at GMR.
That's where fundamentals are very clear.
Not like that. So, sir told me a number of times, sir, but I could not get an opportunity to meet you. So I will definitely meet you, sir. Right. Thank you, sir.
Obviously, he's still in.
Now he's fine. He's fine, sir. He's fine. Recently, Madam expired, sir, but he's fine. He's at Delhi.
I'm sorry to
Yes,
know
sir.
that.
Yeah. He's at Delhi, sir, right now.
He's at Delhi with his son.
Yes, sir. Thank you, sir.
Yes, sir. Thank you so much.
Thank you, then.
Thank you, sir. Thank you for the.
Yeah. So.
Amarendra, sir.
Yeah.
Number 26.
Let us take up the presentations. First, you please read the first presentation.
Yes, sir. So, dear participants, we will be going for the paper also who have submitted for the ISE 2021 conference. Paper ID is number 26, 40, 97, and 242. These papers will be presented in this particular session. Before going ahead, I would like to give you the guidelines. Please make sure that your presentation is over within 8 minutes, and there will be 2 minutes of time for questionnaire and interaction. And please try to stick to the timings that have been provided to you. And now I would like to call paper ID number 26.
Hello. Yes, sir. Am I audible, sir?
Yeah, Manik
Yes,
Ori.
yes.
Manik Ori, sir.
Yeah,
Am I audible?
yeah, yeah.
Yes, you are audible. Please share your presentation and go ahead.
Yeah, yeah.
We-
Present.
Is this visible, sir?
Yes, yes.
So the topic of my uh, first of all, good evening to every one of you. My topic for the presentation is an experimental study on ceramic waste and reclaimed asphalt pavement mix granular subbase for flexible payments. I'm a PG student in NIT Kurukshetra, India. So this is the introduction. In this, I have replaced natural aggregates with ceramic waste and RAP in granular subbase of the pavement. Why ceramic waste and why RAP? Because the ceramic waste is because as ceramic waste is 15 to 13% of the total quantity produced by the industries convert into waste material, which approximate 75 to 1 lakh tons waste per annum. And also due to reconstruction and resurfacing of the pavement, as we know, RAP is produced. This is a picture of ceramic waste and RAP that I've used. Due to reconstruction and resurfacing of the pavement, these are milled off, and during milling, a lot of piling up of these waste material uh, 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 is spreaded on the side of the road, which can be used in the bituminous concrete as well as bases and subbases. So that's why I've chosen this topic for my presentation. And as you already know, ceramic waste is any hard brittle substance that is made by shaping and firing the clay. These are the objectives of my presentation. First of all, I have determined the physical properties of all the materials that I've used, and I have done the grading according to Ministry of Road Transport and Highways grading 3 of GSB mixes. Then I find the properties of these mixes, and then I have compared the properties of these mixes at different proportion of ceramic waste as well as RAP. This is the methodology. I will come to the results as the time period is constant. I will directly come to the results. This will include my methodology. First of all, was the grain size distribution of the material that I have used, showing the percentages of various materials passing through as per grading 3 of Morth of granular subbase. Specific gravity. From the results, it was seen that the RAP aggregate has lower specific gravity, uh, uh, and I have removed the bitumen layer of the RAP, and the specific gravity coming out to be higher. The possible reason may be the presence of bitumen layer of the on the RAP, which has led to its lower specific gravity. To study the worst effect, I have taken the RAP as it was placed on the road, where I have taken it I have taken it from a site where it was light there over with some dust or particles. I have taken that on my while preparing my mixes to study the worst effect. I'm audible, sir? Hello.
Yes, yes, you are audible. Please continue.
Please go ahead. Go
Okay,
ahead.
sir. The specific gravity of the serum was coming out to be the lowest, and the aggregate impact values. Now the aggregate impact value of the RAP is coming out to be lower than the other material that I have used in my GSB mixes. The possible reason for this is due to the presence of a soft asphaltic layer of bitumen. Maybe the layer have been aged, but still it has absorbed some of the impact values. So that's why RAP values, aggregate impact value of the RAP aggregate was coming out to be lower than other aggregates. And when I have uncoated that RAP aggregate, the aggregate impact value increases. And the maximum aggregate impact value was coming out of ceramic waste, that is 19.26. Then I have done water absorption test, and while conducting the test, the values was come out to be higher. Then I thought, why it is coming out to be higher? But later on, I came to know through research that the possible reason for this is due to the agglomeration of the particles. Actually, the RAP material that I have used are agglomerated with one each other, meaning 2 or 3 aggregate particles are combining. And there are possible reasons that the dust or other material that are present in this may have absorbed the water, and the RAP uncoated value for the water absorption was coming out to be lower. So the bitumen content of the RAP was found out by asphalt content furnace, which is coming out to be 3.09%. And then I have named the GSB mixes according to the percentages of RAP and ceramic waste in it. I will come to the next slide due to time constraint. These are the proportions that were made for different percentages. I have chosen 5, 10, 15% for ceramic waste as based on the previous studies that have been conducted, and chosen 10, 20, 30% for a RAP replacement. The studies, it was noted that the maximum dry density, I have conducted maximum dry density as per IS code 2720 part 8. For the materials, as we know that this is the modified compactor test is for material smaller than 19 mm. So I've replaced an equivalent amount of material of particle size greater than 19 mm with an equivalent amount of particle size ranging from 19 mm to 4.75 mm from the other sample. That's how I prepared my GSB mixes for a Proctor and a CBR and permeability test. As from the test, it was seen that the MDD values was decreasing with addition of the ceramic waste as well as RAP. The possible reason for this is due to the lower specific weight, gravity of the ceramic waste, and maybe due to the formation of larger voids in case of RAP, and the OMC value was increasing due to the same reason. The SOC CBR was coming out to be lower than the conventional one. The same reason can be attributed to this. The ceramic waste may have crushed under the loading, giving large strains at the same loading, and this results were similar as compared to the previous one, where they have used one material for conducting their tests. Their values were also decreasing, but I have conducted tests up to 30% RAP replacement and 15% replacement, and the value was coming lastly was 41%. This is above 30%. For so CBR was coming above 30%. So this suggests that it can be used for sub bases as suggested by, as this was suggested by Morth. The permeability values was showing increase in the percentages of RAP and ceramic waste. From the data, it can be seen that the highest permeability was offered at 30% RAP and 15% ceramic waste replacement. So it is a good sign. Generally, the values for permeability values for grading 3 and grading 4 of Morth is generally greater than 12 meters per day, and it is, from the experiment, it has been increased. So it is a good thing for us to provide this material in subbase layer, as it has led to the better permeability. So I have already concluded my results while discussing the results, and why the results are getting that way. Thank you, sir. Hello.
Yeah, thank you, Mr. Manik. Yeah,
Yes, sir.
good
These are my
presentation.
references.
Yeah, good presentation. Yeah, participants, do you have any questions?
Dear participants, if you have any questions, please raise the hand in the WebEx, and I will be unmuting you. Otherwise, you can put your question in the chat box also.
Manik ji, please show your conclusions.
Okay, sir. So these are my conclusions.
Yeah. Okay. Any questions from participant side?
Nobody has raised the hand, sir.
Okay. So, Hare Krishna, sir, if you have any queries, you can also ask, sir. Dr. Harikrishna. Yeah, see, then you have selected GSB grading 3. Why you have selected GSB grading 3? Generally, if you can see highway, in case of the roads, generally we go for
Yes,
GSB
sir.
grading 5.
5 or 6, yes, sir. Actually, I have selected first of all that grading for for conducting my study, but the grading was the material available was not coming out to be while proportioning the value were not coming out to be same, and for collecting material, sir, time was not there because we have been provided 2 months to done our experiments. So I've done on this GSB grading 3. I have tried to use GSB grading 5, but material was not available, sir, for that grading.
See, what is the maximum percentage now based on your study? Yeah, you have done good study. Actually, it is very much required. Nowadays, there are different locally available materials. Suppose if you can go to the Rajasthan, this marble dust, you will get enough quantity, good quantity of marble dust. And different types
Yes,
of
sir.
locally available materials are they can be used in GSP or any other layers in the pavement. So that's good. I appreciate your work. Then one thing is what is the maximum percentage of ceramic waste that can be used in the GSB as per your study?
So maximum percentage, I have maximum percentage. I have for this I have to conduct more tests, sir. I have conducted up to this test. Because sir, as you can see, my ceramic at the ceramic content of 15% at 0% wrap, where value was coming around to be 53%. 53%. So it means ceramic waste can be more replaced. But for this study, I have conducted up combinedly.
Okay. One more thing, this one, this permeability, if you can see at a zero ceramic way, 0% wrap, what is this 0% wrap? The permeability is very, very low. You have expressed in terms of meters per day. You know what is the minimum
Yes, sir.
permeability requirement as per IRC?
Sir, as clearly, sir, sir, I have taken the values from fourth grading 3.
Oh,
So
grading 3
this
only.
it was for grading 3 and 4. They have provided for India, for Indian GSB grading. They have been providing it comes up around greater than 12 meters per day. For Tasto, it was coming out to be 350 meters per day. But their testing is also different. They do not replace particle size greater than 19 mm, sir.
Okay.
They conduct on the same material, sir.
No, but actually, even in our IRC guidelines also, it is mentioned that the minimum permeability of GSP material should be 300 meters per day. Of course, the testing is different, definitely. That's okay, right?
Yes, sir.
Okay, thank you, Nana. Right. Thank you, Mr. Mani. Okay, let us take to the other presentation, sir. Yeah.
Sir, thank you, sir. To call upon applicant number 40.
Yes, sir. Am I audible, sir?
Yeah, Jigyanshu.
Yes, sir. Yes, sir. Sir, shall I share my screen? Sir,
you please share yours.
Sir, is this visible?
Yes, yes.
Yes.
Good afternoon, everyone. Present over here.
It is not visible yet.
Yes.
Okay.
It is visible.
Go ahead.
Let's go ahead.
Yeah.
Sir, shall I start?
Yes.
Yes, sir. Good afternoon, everyone. Present over here. Today, my topic for the conference is investigation on crushed glass and wrap mix bituminous concrete for flexible payments. Why we have to use the waste glass and the wrap? Because in today's world there is a very great problem of the crushed waste glass because of the nearly 10 million tons of glass waste has been generated every year around the world. So it is very necessary to use it as a complement for the construction of the pavements. And the wrap is an wrap. What is wrap? Wrap is an old asphalt pavement that is milled up for existing roadways. RAP can be combined with natural aggregates, new binders to provide a recycled mix. It will reduce the cost of the construction as well as it will also prevent to the waste material to be to cause harm to the environment. The reuse of the materials like waste glass and RAP as done in this study will burden the environment and will be occupying land resource if we not use the material in the construction or any other use. For according to my study, the objective of my study is to determine various property of materials used in my study, to do the mix design for bituminous concrete mixes prepared with different proportion of crushed glass and RAP, and to determine various property of the bituminous concrete mix with different proportion of the crushed glass and RAP. And at last, I have to compare the properties whether it is feasible to use the RAP and crushed glass separately or combinedly in our mix bituminous concrete mixes. This is my methodology. As per my methodology, first of all, identification material as per done the crushed glass and RAP, then the material collection, and the experimental program include various tests for aggregate and RAP, and for the bitumen, and for the crushed glass, and on bituminous mix. And then we have to compare the results with conventional mix without adding the crushed glass and RAP, and then we have to at last we have to go for the conclusions. First of all, the particle sieve analysis. I have done this for the grade 2 as per Morth, bituminous concrete grade 2 as per Morth. For that, I have used the 10 mm, 6 mm stone dust, and for other mixes, crushed glass and RAP. This is the my particle sieve analysis result, and this is the graph plotted between the percentage finer and the sieve size for different 10 mm, 6 mm, stone dust, crushed glass, and RAP. Physical properties of the material, mainly the aggregates and stone dust, have shown the specificity greater than the 2.7, while the RAP coated aggregates show some less specific present in the RAP material, but uncoated aggregate show to about 2.7, which shows that the uncoated material remove the impurities from the RAP uncoated aggregate has been removed. And for the specific gravity of the crust glass, it is about the 2.54. Same case with the aggregate impact value. While conducting aggregate impact value for uncoated aggregate, this shows the more value, while for coated aggregates, it shows the less value, as some of the impact has been taken up by the bitumen that is coated on the RAP. This is the flakiness and elongation value. Same for the uncoated, it will show more a value because the bitumen has covered up the some space in the RAP coated aggregate, which led to less flakiness and elongated value. These are the water absorption values for 10 mm aggregates, 6 mm. Stone dust, there is no test conducted for the stone dust. And for RAP, coated and uncoated aggregates. This is the physical properties of bitumen. Penetration values came out to be 35.3. Specific gravity come out to be 1.01, which is under the Morth limits. And viscosity values are come out to be 3646, which shows that the bitumen used is of VG40. Sir, am I audible?
Yes, please go ahead.
And the bitumen content of RAP has been found by the asphalt content finder machine available in the lab, and the sample weight has been taken 1008 gram. This and the final weight came out to be 974, which shows the asphalt content is the 3.4%. And then test has been conducted for conventional mix without adding the crushed glass and RAP, and for different bitumen percentage, the test has been conducted for finding the optimum bitumen content, and the Marshall stability at 5.5% has came out to be maximum. This shows that the optimum bitumen content to be used for further mixing with crushed glass and RAP is to be used 5.5. I have taken the bitumen content constant for further mixing. Flow value is also came out within limit, which is 2 to 4 mm as per Morth, and the air void is also within limit. FB is also within limit, which is 65 to 75. At 6%, it shows some more value, more than 75, but due to some more bitumen content, this shows some more value. Otherwise, all values are within limit. These are the graphs for conventional mix result. as per the table, and the Marshall stability at 5.5% came out to be maximum. This is the flow value graph. This is the air voids graph at different bitumen percentage, bitumen content, and this is the density bulk specific gravity graph versus the bitumen content, and this is the VFB graph. Voids filled with bitumen. Then the naming for the bituminous concrete mixes had been done. B00 indicate that wrap percentage used is 0 and crust glass is 0. That is conventional mix. Then I have created some groups. In first group, the wrap content is 0 and I have varied the crust glass percentage. And in group 2, I have taking the wrap content constant at 10% and vary the crust glass percentage. In group 3, the wrap percentage increased to 20%, and at group 4, the wrap content is 30% and vary crust glass 0, 5, 10 and 15%. I have conducted up to 15% wrap percentage and 30%, both 30% wrap percentage and crust glass 15%. Then this is the proportioning of the bituminous concrete mixes for conventional mix. For conventional mix, it came out to be 30% 10 mm aggregates, 6 mm 22%, stone dust 48, and no crushed glass and no conventional mix for the conventional mix. No wrap and no crushed glass for conventional mix. And then these are the further proportioning at different wrap and different crushed glass percentage. All came out within limit as per the table given in the mode. And then I have conducted Marshall stability test on different mixes prepared with the crushed glass and the wrap, and all the values of the Marshall stability came out within limit, but at 30% wrap and 15% crushed glass, it's so very less value as compared to the 10% wrap and 10% crushed glass. That is that is B12.
Hello.
That is B12,
What?
18.2%.
Oh, where are you?
And all the flow values are within limit, and all the VFB values are within limits of the as per given in the mode. Then these are the graphs plotted at different crust glass percentage and different wrap percentages. This shows that
It's difficult to listen to them.
10% wrap and
They are
10% crust glass
absolutely
show the
not
better
audible.
result as compared to other values, and all the
You
flow
hear me?
values are within more
I
limits,
said they are not audible. Your people are not audible in English.
and all the air voids are within limits of the as per given in the mode specimen. This is 3 to 5%, and the voids filled with bitumen graph at varying wrap percentage and crust glass percentages. So shall I continue?
Hello?
Yes, sir. Am I audible, sir?
Yeah, please, but quickly conclude.
Okay, sir. So these are my conclusion. As per bitumen content of wrap came out to be 3.4%. Optimum bitumen content for the conventional mix came out to be 5.5%. And obtained result for the Marshall stability are all within limit as per mode. And 10% crust glass and 10% wrap replacement show better results on comparing with conventional mix. Flow value, air voids and VFB value for all mixes with the crust glass and wrap do not show significant changes. They are all about same as per the conventional mix. These are the references used for the study. Thank you, sir.
Okay. Thank you, Mr. Digneshu. Yeah, I request participants, if you have any queries, I request please ask. Again, it is a very interesting topic. Participants, if you have any questions.
Yes, sir.
Many participants are there. They're not
Nobody has raised.
No, at least you please type your question in chat box. If you are unable to ask, please type your question in chat box, and maybe presenters can give answers to those queries. Yeah, Mr. Khanna, actually, like this is a glass. How you have used this glass? This is completely in the powder form, or how you have mixed it?
Yes, sir, yes, sir. I have taken the waste glass and I have crushed in the laboratory itself.
Is there any like standard method for crushing, or like
Sir,
like you have simply crushed like that?
yes, sir. I have simply crushed it. No standard method used, sir.
Okay, okay.
Yes, sir.
See, this crushing also, I have again a doubt. Like a few people I have seen in some literature, people use this one glass as a filler material. So you have crushed. Can you show me that gradation of the glass?
Yes, yes, sir. Of course, sir. I will show. So yes, sir. So this is the gradation of my crushed glass.
Okay, right. So it is passing across completely almost 4.75 mmc.
Yes,
It's
sir.
a finer material, I can say.
Yes, sir.
But retaining almost on 0.075. Not okay. I say we can call consider it a fine aggregate, but not finer material. Not
Yes, sir.
passing through 0.075. Okay, fine. So stone dust is passing this one. Okay. Yeah. Is there, did you, I don't know, maybe I think you might have gone through the literature. Any ill effects with using glass with respect to the user point of view? Suppose if the vehicles are traveling on pavement.
Sir, it will cause some problem during friction, sir. It cause some problem in friction, sir. Because, sir, it's a smooth material. That's why if we use more quantity of material, then it will cause less friction, and it will otherwise it will provide some loss to the vehicles. Okay. Yes, sir. Yes, sir. This is the main problem I have faced in literature review.
Okay, so we can use it in lower layers, I think, without any problem, no?
Yes, sir. Yes, sir. Of course, sir.
So in case of the bituminous base layer, it can be used.
Yes, sir. Yes, sir.
Yeah, that is really interesting. And even see, you have like without wrap, how you got the results? Only with the crushed dots. Can you show me that plot?
Yes, sir. Yes, sir. That's I will show, sir. Sir, these are the results
without wrap.
Sir. Sir, group 1.
Group 1. Okay.
Yes, sir.
So Marshall stability is fine, and this is flow L with good theoretical specific gravity, bulk specific gravity, air voids also getting okay. VMA, this is the one parameter that I am looking for. Because see, most mixes always we should concentrate on VMA. It's all other parameters you will get Marshall and this all those things.
Yes, sir.
But VMA only always we face the problem. Okay, here is 15.6 is good. 16.1 we are getting. In group 2, group 3, 16.5 we are getting this. What is this combination? Group 3 B20.
Sir, 20% wrap and other 0, 1, 2, 3, 4 indicate the crushed glass percentage, sir.
Okay, so 20% wrap and this one 0, 1, 2, 3. Okay.
Yes, yes, yes.
20% wrap. Okay. So I think with only wrap 20% and 30% VMA and here also VMA.
Yes.
If you only wrap, you are getting good VMA, and also of course adding the glass also okay.
Yes, sir.
See, more the VMA always in the mixes, you can push more the bitumen. They're all durable mixes, generally you consider.
Yes.
And coming to the VAB also within the right. Okay, Mr. Khanna. Yeah. Thank you for your presentation.
So, shall I stop sharing?
Yeah, please stop sharing. Sir, next presentation, sir.
Sir, now I would like to call up Mr. Rajat Mohan, rating number 97. Are you ready with your presentation, sir? Paper ID number 97, sir. Rajat Mohan.
Hello, right. Hello? Yes, you are audible.
Yeah, Rajat Mohan, your voice is a bit low. Please, if you are ready with your presentation, please start sharing your presentation.
Is my PPT visible to you all?
Yeah, it is being shared. Not. Yeah.
Is it visible, sir?
Yeah, it is visible. Please go ahead.
Yes.
Good afternoon, everyone. Rajat Mohan is here to show you a presentation on the topic utilization of bitumen aggregate and wax with rubber tire in a flexible pavement. Due to the ever-increasing number of vehicles in our environment, waste tire rubber has become an important environmental concern. The used tires pose a great threat to the environment and human health, since they are non-biodegradable. Thus, disposal of these waste is hazardous and has become a serious problem globally due to its non-biodegradability. The main purpose of the study was to examine the effect of adding crumb rubber and wax content and replacement of bitumen at different percentages to asphalt mixture in design mix and laboratory hot mix asphalt design tests of different crumb rubber content, which were performed using the Marshall stability test. Also, we are here to we have determined the suitability of the waste tire, which is being checked, and need to determine how helpful it is while replacing of the bituminous layer of road pavements. Here in this slide, the study is conducted using the conventional bitumen of 80 by 100 grade, and we have used fine and coarse aggregates such as gravels and crushed stones, which are being sieved and used in the experiment according to their respective sizes. We've also got paraffin wax for our experimental purpose, and waste rubber tires were accumulated from dump sites, which were cut into small pieces as per the experimental requirement. For the experimental testing purpose, weighted amount of rubber aggregates, which were approximately 5%, 10%, and 15%, are being sieved as per the IS code 383/1970 sieve analysis method, where particles of sizes between 2.36 mm and 75 micrometer were used in the replacement of aggregates and bitumen binder respectively. For the preparation of CRMB mixture, bitumen is heated at 165 to 175 degrees Celsius and aggregates are heated to the temperature of 145 to 155 degrees Celsius. After mixing bitumen and aggregate uniformly, the mixture is required to be heated at 165 degrees Celsius so as to keep the viscosity of the bitumen lower for proper coating of aggregates and binding both bitumen and aggregate efficiently. We have conducted certain laboratory tests on various samples of bitumen, aggregates, and bituminous mixtures, such as Los Angeles test and aggregate impact value tests, which were performed on the aggregates, which conforms with the IS code 2386 part 4 1963. The ductility and penetration tests were performed on the bitumen samples, and Marshall stability test was performed to evaluate the mixed design parameters of bituminous mixture samples, which confirms with the code ASTM D6927. Now, in the graph, we can see from figure 1, it shows the ductility value of the specimen decreases with an increase in the crumb tire content, which corresponds to less flexibility in the pavement when no wax is added to the sample. With 15% replacement of bitumen with crumb tire, the ductility value decreases by almost 23.53%, although it was still more than the minimum value. While in the figure 1b, the ductility has been noted down for bituminous mixture containing 5% wax and varying percentages of rubber aggregates. It can be seen from both the graphs figure 1a and 1b that ductility value is less for sample containing 5% wax, which is 91 mm, while the ductility value is more sample with 0% wax, 102 mm. Now, in this slide, the penetration result illustrated in figure 1c depicts the penetration value which decreases with the increase in rubber content when 0% wax is present in the sample. As the rubber aggregates increases in the CRMB sample, the penetration value decreases by 18.2%, indicating the stiffness of the sample increasing. And in the figure 1d, penetration value has been noted where 5% wax has been added to the sample containing mixture of bitumen and rubber aggregates. We can observe that we have added 5% of wax in the bituminous sample. The penetration has decreased from 98 mm to 86 mm for 0% addition of rubber aggregates in both figure 1c and 1d. As per the data shown in figure 2a, the stability value initially increases with an increase in bitumen content, but then the stability value decreases sharply. When there is an addition of rubber aggregates in the CRMB mixture, the interlocking bond between the aggregates and bitumen binder improves, which causes an increase in the stability values. However, due to non-uniform behavior of bitumen, the rubber particles get distorted and dispersed inside the mixture, causing poor bonds of rubber aggregates with bitumen binder and reduces the stability value. As per the graph illustrated, the maximum stability value occurs at 4.23% of bitumen content when 5% tire has been added into the CRMB mixture. Here, the air voids in the tested sample can be observed in the graph represented in figure 3A. At same rubber replacement content, the air voids can be seen to decrease with an increase in the bitumen content due to the presence of 5% wax content. As we know, if the voids are less than 3% in the mixture, it can lead to rutting due to the plastic flow, and if it is more than 8%, then it may result in premature cracking or raveling due to the moisture. In the second figure, it represents bulk-specific gravity, which helps in calculation of the voids in mineral aggregates and voids filled in by bitumen. This is calculated covering the specimen with the wax and using the water displacement technique. Values obtained from the test are represented in figure 3B, where when the percentage replacement of bitumen with tire was kept constant, the bulk-specific gravity of the specimen increases when the bitumen content increases from 4% to 4.2%. and tend to decrease after 4.2%. As we can see here in the graph 4A, it shows that on the same level of replacement of bitumen with the waste rubber tire and adding wax content, the VMA decreases when the bitumen percentage increases from 4 to 4.2%. But when the bitumen percentages increase after 4.2%, the VMA value increases slowly. Minimum value VM is generally desired to get the durable binder film thickness. The graph in 4B depicts that the VFB percentage increases with an increase in bitumen content due to the fact that more bitumen content will fill up the gaps between aggregates in the mixture, which increases the effective bitumen film thickness between coarse and fine aggregates. However, for increase in bitumen content, the trend of VFB percent decreases gradually because of addition of rubber aggregates increases the voids in the mixture. Now in the conclusion, based upon the experimental research conducted in this paper, the addition of rubber aggregates and varying wax content in bituminous mixture helps in enhancing the physical properties of CRMB, as illustrated in the results by showing a decrease in ductility and penetration value. Rubber aggregates in bituminous mixture tends to increase the stability to some extent, increases the value of voids filled with bitumen, and decreases the voids in mineral aggregates, depicting various properties of Marshall stability design for obtaining the optimum bitumen content. For 5% rubber content, the bitumen content corresponding to maximum stability and bulk specific gravity comes out to be 4.23%, which is considered the optimum bitumen content for replacing it with rubber aggregates. It is also observed that with the addition of the wax content results in the reduction of mixing and compacted temperature. It indicates that the addition of wax content is beneficial in reducing the mixing and compaction temperatures. The utilization of rubber in road pavement will help in providing improved life and durability of flexible pavement, provides least cost recycling method of waste disposal. These are the references which I have used for my research work. Thank you, everyone.
Yeah, thank you, Mr. Rajat Mohan.
Yes,
so again, a very good presentation. So can you show me the gradation of the rubber aggregates? So meanwhile, I request participants, please, if you have any queries, please ask Mr. Rajat Mohan. Show me gradation of rubber aggregates.
Just a second, sir. Actually, I have not shown in this PPT. I have done it in my research work.
Okay.
Yes, sir.
Okay, fine. See, what is the it's a rubber, actually, see, there is a crumb rubber generally we use in the bitumen more than 15%, and we know that CRMB, all those things. But you said it's a rubber aggregates, it's a little, it's new for me actually. And what is the, do you have any idea? What is the percentage of passing on 4.75 CU?
Basically, sir, we have to cut it into small pieces so that it could pass through the respective Cs like 4.75 and all. We will have to replace with both the aggregates as well as the bitumen content. So we have to basically cut and crumb it according to the sizes which are required for our experimental purpose. I
Okay.
also confirmed with the codes which are basically SP 105 and 107 for my graduation, for my values and all. So I've confirmed with them.
One more thing I have noticed, like if you can increase the percentage of the, see in case of the conventional without rubber aggregates,
Yes,
so
sir.
if you add more bitumen and it is going more than that, VFB is going more than 75%, like we have
Yes.
a limitation of 75%.
Yes, sir.
But whereas if you increase the rubber percentage, rubber aggregate percentage going up to 15%, and a VFB also, can you show me that graph, VFB graph?
VFB, sir?
VFB.
Yes.
Yeah, that's what. If you can see, can you just, yeah, this is the one. Increase
Shall I
the
zoom in?
size. Sir, please zoom in, zoom out.
Sure. Is it visible,
This
sir?
is for, yeah, is okay, fine. 15% also you are getting, see, this is going almost constant. And of course, for 15% also you are getting 67% is VFB.
Yes, sir.
And whereas in case of the 0%, it is going up to 80%.
Yes.
So why this difference? Did you observe anything? Why this difference?
Basically, I experimented it. I thought that it would decrease, but after experimentation, the results were like that it is increasing with a constant rate. And I was a bit confused with that, sir, why it is increasing.
Okay.
Yes.
Okay. Okay, please like study that part also. That is very important actually in this.
Sure, sir. Sure, sir.
Yeah. Anybody, any participant? Okay. Thank you, Mr. Mohan.
Thank
Yeah.
you, sir.
Let us, Mr. Chaitanya, let us, sorry, Dr. Chaitanya, let us take another presentation.
Yes, sir. Thank you, sir.
Is it the final presentation, Chaitanya?
Yes, sir.
Okay. Okay.
Yes, sir.
Now I request. Hello.
Go ahead, sir. Go ahead.
Now I request paper ID number 242. Paper ID number 242. Please ready with your presentation and share.
Tanisha Shetty.
Tanisha. Tanisha
Yes.
Shetty. Your screen is visible.
Hello, everybody. My name is Tanisha. I'm a graduate from Amity University, Dubai. And my topic for today is effect of size and depth on capacities of strip footing in limiting settlement approach. So in this research, the effect of different sizes and depths of footings below the existing ground was studied based on the load-bearing capacity using GeoPhy spread footing software. And for this study, we only took the vertical loadings into account. We took 4 different strip footing widths, 1, 1.5, 2, and 2.5 meter under 3 different loads, which is 260, 600, and 1000 kilonewton. Now I'll talk about the problem. We know that soil parameters are usually seen with a considerable variation over space. So in general, what we do is we neglect the horizontal direction because it is not really practical that we investigate the ground strata with large number of boreholes, especially when this difference is not very significant. So on the larger side, foundation settlements were proven to cause damage to structures majorly made from concrete, which is like when concrete is the rigid material. So it is important to check both the immediate and long-term settlement as part of the foundation design. So the main aim of this research was to understand the influence of weak layer presence, which is actually the clay soil layer settlement on the foundation. However, the extent of this research was limited only to strip footing of various sizes at different depth with 12 mm limiting settlement. So here is a table showing the general stratigraphy of the site. So our main focus is that the stress influence should not touch the weak layer, which is the clay soil type. So now I'll talk about the methodology used. The soil profile, which I just showed before, was obtained from Abu Dhabi. 14 boreholes were drilled down to 20 meters below the existing ground level, and the standard penetration test was conducted from the ground level at every 0.5 depth up to 3 meters, and then at every 1 meter depth till the rock head was reached. Once we reached the rock head, through the SPT refusal, we got the rock parameters. And then those parameters was entered in this Geo5 software to analyze the strip footing with limiting settlement of 12 mm. This limiting settlement of 12 mm is as per the UAE standards. Then we took 4 different widths, that's 1.5 to 2.5 meters of footing, and analyzed those at different foundation depths of 1.5 to 2.5, 3 and 3.5 meter below the existing ground level. And then these footings were tested under 3 different loads of 260, 600 and 1000 kilometer per meter run of the footing. So the bearing capacity was analyzed using the Brinch-Hansen's method. This Brinch-Hansen method is actually a method which is used in Europe, which calculates the allowable bearing capacity of the soil. So we analyze the bearing capacity using this method with a factor of safety of 1.5. The foundation settlement was calculated with the odometric modulus. So in this figure is an example of 1 meter strip footing. And as you can see, with the help of the parameters, with the help of these dimensions, we can conduct the analysis with various variations. After we enter all the required parameters for the analysis, we get the results as shown in this figure. The results show that shows whether the bearing capacity in the vertical direction is satisfactory or not. We also see if the eccentricity of the load is satisfactory or not. If the bearing capacity fails, it can be seen that the bearing capacity in the vertical direction is not satisfactory. So in this case, it's okay. So under the settlement criteria, all the different factors are shown, which is the foundation stiffness, verification of load eccentricity, and the overall settlement and rotation of foundation. So the settlement obtained here is 55.3 millimeter with the depth of influence as 8.18 meter over 260 kilonewton. Similarly, the load and settlement analysis was carried for different sizes of footing with different loads. Now we'll come to the result. So on performing the mentioned analysis, the bearing capacity and settlement was obtained. So in this figure, we notice that as the depth of footing below the existing ground increases, the settlement decreases, and this is for 1000 kilonewton load in strip footing. Similarly, similarly for all tested footing sizes, this was the pattern observed, which is for 600 as well as 260 kilonewton. Now, in figure 6, we see that as the depth of footing increases, the depth of influence zone keeps decreasing under 1000 kilonewton load. And figure 7 is again showing a similar pattern for different load, that is 600 and 260 kilonewton for all the tested footing sizes. Here we see as the depth of footing below the existing ground increases, the maximum vertical load at the settlement criteria keeps on increasing. Okay, lastly, this is a table of the depth of influence zone at limiting settlement criteria. We see that for all the analyzed footing sizes and depth, the depth of footing at which the influence zone crosses the weak layer, which is the clay layer, decreases with increase in size of footing, and it increases with increase in width of footing as well. This is some of the selective references we used in our paper. Yes, thank you.
Yeah, okay, madam. Yeah, thank you, madam. Thank you for really, the presentation was wonderful. I request the participants kindly ask any questions if you have. Participants, please. Somebody, some question, maybe I can see in the chat box.
Your questions in the chat box. And
Madam, can you?
Sir?
Madam, can you go to previous slide, madam? Next, before that. Yeah. No, madam. Next slide. Next slide. No, the previous one, madam. Not before this references. Yeah. Wait, madam. So here the depth of the footing and why just I'm checking this influence zones actually. Okay, so here the increase in the depth of the footing and but increasing the size, this influence zone is reducing. Okay. I was a little confused actually. Fine. Okay. Yeah, Mr. Chaitanya, if you have any announcement, please make. Yeah. Hello.
Announcement is I have just put the
Yeah, Dr. Chaitanya has shared this feedback link. I request all the participants, please fill the link. Please fill the link. No, there's some problem actually. Madam, thank you, madam. You can wind up the presentation. Thank you, madam. Tanisha, madam, thank you.
Thank you, sir.
Okay.
Narendra sir, please. Sir.
Yeah, actually, once again, thanks organizers and other management team for inviting me to share this session. So it was great to listen two keynote lectures. They're really good. Actually, if you can see, so in India, currently we are following elastic layer theory for design of the flexible pavement. And also mainly for the rigid pavement, we are using this finite element method, but the flexible pavement still layer theory we are following. This is very, very important actually. Sir has nicely explained the importance of viscoelastic theory, since the bituminous material itself is a viscoelastic material. So what are the advantages and how you can get the accurate results? And also, Dr. Ari explained the tests, actually requirements of the test. See, like why we are all like constructing the roads. See, if you can, you know that the design life of bituminous pavement is 20 years, but after 3-4 years you are seeing lot of distresses on the payments. Why? The reason is because the quality control. Like, see, for the design of the flexible payments, or I can say we are not supposed to use the word called flexible payment. It's a bituminous payments. So bituminous payment, we consider the modulus value 3000 newtons per mm square. That is 35 degrees temperature. But if you can see some of the like in India at different locations, the temperatures goes up to 60 degrees. So last year, I went to Varanasi for some forensic investigation. I noticed that the air temperature was 46 degrees and pavement temperature was something like 62 degrees. There is huge difference actually. So at high temperatures, materials, we are not at all considering the behavior of the materials at the high temperatures. Okay. So that is also very important. That's what sir, he has emphasized the importance of the testing and other things in this lecture. And the second lecture, it was again a beautiful lecture by Professor G.V. Rao. Actually, now, as I explained you also, so using this geosynthetic products can significantly reduce the aggregate consumption. Right. See, nowadays, actually, some of the states, if we can go to some states, even some part of the Gujarat, like this one, states which are close to the Himalayan region, like UP, some parts of the UP and Uttarakhand, many more states, like getting aggregates is very, very difficult. So that too, for pavement, if you can see, on the subgrade, we use each and every layer aggregates are required. So instead of that one, this using such type of products can significantly reduce the total pavement composition, and also not only reduction of the pavement composition in terms of aggregate consumption, also environmental friendly, and these are very, very good durable layers actually. Using they don't decay at all, so they give very good strength to the pavement actually. So that's why, so the lecture given by Professor G.V. Rose was really fantastic, and he has shown number of the case studies and all. And coming to our presentations, paper ID 26, he has explained what like uses of ceramic waste in the GSB layers. Not only GSB layers, it is better to study even WMM layers also, how the strength affects. And my suggestion to the paper number 26 is wrap. He said usage of wrap in GSB layer. Better we can restrict the wrap usage up to the WMM layer, not to the GSB layer. See, GSB is mainly for the drainage. So using of this wrap and other things, if they can avoid or maybe reduce this drainage potential, then it will be dangerous to the pavement again. So I have done some experimentation on uses of wrap in WMM layer in some of the projects in Kerala. And of course, bituminous layers also that everybody is using. So that is also one thing. It was that whatever the study like he has explained, it was also good. And similarly, the other presenters also, paper number 40, exactly that name of that one I have forgotten. See, one person presented on the usage of the glass. See, nowadays different type of waste materials are available, and everybody is facing lot of disposal problem. So these people, like they have suggested interesting studies on usage of this glass, and of course rubber aggregates. Okay. So these are all actually all the papers I found they are very good and relevant to the conference. So it's good to like be a part of this conference. Thank you once again, and thank you organizers and other friends.
Thank you very much, Amarendra sir. You have done complete justice to your role, and we are really very much thankful and grateful for your contribution. And the knowledge that you have shared with everybody is immense, and the discussion that you have initiated with the keynote speakers and the suggestions that you have given to the authors that who have presented are more valuable. And the healthy discussion that has been happening, that is the main motto of this particular conference, and we would like to share our knowledge during the conference. And your participation has enhanced the motto. Thank you very much for your contribution, sir.
Thank you, sir. Thank you, Hanumantrao sir, for giving this.
Thank you, Dr. Amarendra. Thank you so much. Thank you so much for sharing the session and also sharing your actual consultancy works also. I'm very thankful.
Yeah, we will continue working with GV Rao, sir. There is a lot of potential in this area. See, recently
definitely.
in a number of the platforms nowadays, I am pushing this geosynthetics. Like people also they are showing some interest. Adani they have convinced, and other Monte Carlo also this time convincing them to use this geosynthetic products in the pavement layers.
Okay.
So let us
Actually,
definitely choose it.
inform that he will help us in establishing Center of Excellence at KL.
Okay. Do
So I
that
am
one,
in
sir.
the process in the next we just started our MTech in geotechnical engineering program.
Oh, very good, very good.
So as a part of developing the MTech geotechnical laboratories, we thought of developing geosynthetics testing lab itself so that it will become model center here in Vijayawada, and also facility will be extended to the public. That's what our view is. Anyway, thank you so much
Right,
for
sir. Thank
sharing
you
the
very
session
much.
and supporting us. Thank you. And I also thank all the presenters and the participants and the keynote speakers for attending the session. I also look forward all the participants to attend tomorrow's session sharply by 9 o'clock. We are going to start with Dr. Mallikarjuna as the keynote speaker, and it's wonderful sessions are there tomorrow. And I request every one of you to kindly join sharply by 9. Thank you. Thank you all. Thank you, Dr. Makithan.
Okay. Right, Dr. Sir.
Thank you, sir. Thank you.
Thank you, Dr. Makithan.
Thank you.
And Hemant Rajan.
Thank you, sir.
Thank you.
Dear participants, please do not forget to fill the feedback form. That will be considered as your attendance for this particular session. That is there in the. You people gained so much of knowledge this particular session. Thank you. Thank you very much for participation, and have a good day.
Hello. Hello. Which application we need to fill for attendance? Hello? 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 Ay, ay, ay. Hello?